We're here.
Hey, Claire. Yay.
It's happening. I like the music that Teresa chose this year.
I absolutely, Claire, and you're a producer, so you saw me vibing backstage.
I just did see you doing a little dance there. Okay,
Excellent.
well, welcome to Posette, an event for Postgres. Let's go ahead and dive in and get this party started. This is Livestream 2. They're of one of 4 live streams. They're all unique. They all have a different collection of talks with 42 talks total. And I'm going to, even though I'm in California, I'm going to think of myself as in the Central European summertime.
It is nice here, so welcome.
Yes. And my name is Claire Giordano. I head up Postgres open source initiatives here at Microsoft.
Right. My name is Floor Drees. I'm based in the Netherlands, so not quite Central Europe, but central enough. And I work in the open source community at Ivan.
And I'm so thrilled to be co-hosting with you today. It's a lot more fun to do this with a partner. Posette, an event for Postgres, is brought to you by this Postgres team at Microsoft. So thanks to my boss and everybody who's funded this initiative and supported us along the way. And why do we do it? I mean, I'm a huge fan of in-person conferences. In fact, we were together in Prague last December for PGConf EU, which is one of my absolute favorites. But there's also, I think, a real need to create great Postgres speaker content that's available online to anybody with an internet connection, even if they don't have travel budget or are between jobs or have elderly parents or whatever the reason is that they can't travel to an in-person conference.
I think the mix is just really great. Being able to do a little bit of in-person and a little bit of virtual, I think that's good.
Yeah. So we do have a code of conduct, even though it's a virtual event. And if you have an issue or have a concern, there's a URL on the right-hand side of the screen, aka.ms/PosetteConduct, that you can use. But the gist of the code of conduct is to be considerate and thoughtful and patient and respectful of other people as you interact with them around the event, whether that is on our virtual hallway track on Discord or, on the social platforms or wherever. Captions.
This is so great, right? That we have live captions available in English today, and that the videos will have captions in multiple different languages. I believe that this number on the slide is not even accurate anymore, is it, Claire?
It's not accurate. Apparently, Dutch was added to the list because of you.
I won't believe that, but I'll take it. Yeah.
Yeah. So I do have a list here. I think the English captions get QA'd, so they're super high quality, and then it gets translated into multiple versions of Chinese, Czech, Dutch, French, German, Italian, Japanese, Korean, Polish, Portuguese, Russian, Spanish, Turkish, and Ukrainian. So
wow.
Yeah. Lots of languages. And accessibility is a thing. If you're live posting the event, use the hashtag #PosetteConf. Some people think it's just #Posette, but don't do that. It's #PosetteConf. And I know some people are live posting the event, which I think is great. And hopefully they don't get screenshots with us, and our eyes closed or a wonky look on our face or whatever. You can also follow PosetteConf on socials. There are accounts on X as well as Mastodon and Threads that you can follow. And this, I think, is one of the most important slides.
Look at that. Look at those faces.
I know.
Doesn't just make you happy.
Just some amazing, amazing Postgres experts, contributors, committers, engineers, community members. I think about 30% of the speakers are from inside Microsoft, which of course means that 70% are from the broader Postgres world. So I love how people from all sorts of different companies come together around Postgres. Absolutely. So big gratitude. Would not have this event without them. And we should probably thank the talk selection team.
Yes. Do you feel awkward about saying your own name? Because Claire, a huge thanks goes out to you, of course, as one of the major contributors behind this event. And then also Alicia, Danielle, and Melanie. Thank you so much, because making that right selection that is good for everyone is incredibly hard, striking that balance. So thanks for all of the work that the talk selection team has done.
Just to put it in context, we had 184 talk proposals that we needed to whittle down to select a final roster of 38 talks. And then the keynote talks are invited, so they're not part of the CFP process. And we did write a blog post about the whole process. One of the things that's really important in the Postgres community is that there be transparency around talk selection. People know who's on the talk selection team. So that was published up front. And then we wrote this blog retrospectively, looking back on, and explaining how we made our decisions, how we approached the process. So that link is showing on the screen as well on the bottom left. Okay. Also wanted to say thank you to the organizers. Teresa Giacomini is the chair of the event, but could not have done it without work from Aaron and Adi and Eden as well. So big thank you.
Thank you.
And their job's not over yet. They're working behind the scenes right now.
Exactly. There's several more live streams to come, and then also the video publishing. There is a lot to do still.
We do have a virtual hallway track. And it's pretty active. I don't know. You got to experience it as an attendee yesterday, Flores. You tell me.
Yeah, it's been a lot of fun. Sometimes I had to step away to make dinner, because those things also happen, right? And then I would come back to the Discord channel, and it would be so full, and I had to scroll up quite a bit. So there's a lot of chatter going on there, but also excellent questions are being asked. So definitely join that channel if you can.
So you go to aka.ms/open-source-discord. That takes you to the Microsoft open source Discord. And then on the left-hand side, you should be able to find the Posette Conf channel. And that's where the conversation is happening. And what you might not realize is that even though this is a live stream, the speakers actually pre-recorded their talks for the most part a couple of weeks ago. And so each and every speaker has committed to be present on the virtual hallway track on Discord while their talk is being live streamed. So feel free to chime in and ask them questions. Like I think it's a nice way to get access to speakers and, get those questions answered. So swag, we need to talk about swag.
Those are some very, very pretty stickers. So I've heard that we have some sticker packs to give away, and then there is also socks for the very, very engaged people among you. So there's a voucher on the slide right now, or on the screen right now, that Claire is sharing. So definitely grab that and enter your code, and make sure that you get some of that sweet, sweet swag.
And we will pop the code up again later in the live stream. So, and then you fill out that form at aka.ms/PosetteSwag. But the sticker packs are kind of cool. There's also a Cloud Skills Challenge. And this is for, we have a mix of people attending this event. We have open source contributors. We have Azure engineers. We have customers of Azure Database for Postgres. We have users of Postgres open source. I mean, people from other clouds and other hyperscalers. So the bottom line is, if you want to skill up on Azure Database for Postgres, there's a link in the bottom left right now where there are these 2 Cloud Skills Challenges that are open until June 24th. You can do one, you could do the other, you can do both. It's up to you. And then once you complete them, you're entered into a lottery to possibly win one of these cool hoodies or shirts. So that is our Cloud Skills Challenge.
Yeah, I saw a couple of people in Discord already mentioning that they have finished. So apparently it's something that you can finish in a timely fashion, and then, get some cool shirts or hoodies.
Exactly. Now, surveys are an important part of any event, whether it's in person or whether it's virtual. Speakers, of course, pour a lot of their personal time into creating their trainings and their talks. And so the survey QR code and link on the left is for talks. So as you listen to a talk, if you want to fill out the survey right away, it's super easy. There's just like 4 questions per talk. You can use that link over and over again. You can submit it multiple times, once for each talk that you want to give feedback on. And then the event survey is a kind of a one and done thing. It's about your whole experience with the whole event. And that's for the organizers, and super helpful as we start planning, next week on next year's event. So please, if you can, fill out the attendee surveys, and we'll pop these links up again later in the show as well. There's an ultimate guide if you want to get an overview, not just look at the schedule by live stream and by time zone, but see all the various talks grouped into categories. And like there's 7 AI related talks total. 15 of the talks are about the Postgres core technology. There's ecosystem talks, extension talks, some Azure Database for Postgres, of course, and some community talks. And that's where yours falls in, right,
Yes.
Flor?
Yes, I'm very excited about. Well, I'm not entirely excited about hearing myself speak because that's always a bit awkward. But yeah, no, I'm very curious what people will think of it. Yeah.
All right, keynoters. So yesterday in Livestream 1, Charles Feddersen from Microsoft gave a talk about all the Postgres things at Microsoft. He's my boss. So I'm predisposed to appreciate that keynote, but I think he did a really good job kind of giving that
a really good job. Yes.
Giving that overview. Today's keynote speaker, I will introduce in a few moments, Regina Obe, very world famous in the PostGIS and open source geospatial communities. Livestream 3, Sarah Novotny, really well known in the open source world, particularly the Kubernetes world. And I am privileged to have worked with Sarah, and I'm really excited to hear that one. And then Thomas Monroe with his historical walking tour of Postgres. Have you met Thomas? Do you know him, Flor?
I have. And when you talked about the skateboard yesterday in the stream yesterday, I was like, so if I want something to happen, there should just be a sticker and it should be on on Thomas's skateboard. That's good to know.
Yeah, he brings his skateboard to all the Postgres conferences he goes to, and then he makes sure to put a new sticker on there for each one. And so it's like a wonderful collection of where he's been. And his keynote is going to be fun. All right, so there are 11 talks in the roster today. For Livestream 2, and this is a bit of an eye chart. So I feel like we should pop over and look at the schedule for today's live stream. So I'm just going to go ahead and pop that on the screen so that we can look at it. And this is at aka.ms/Posette-schedule. And you can see there's 4 tabs at the top, one for each live stream. Obviously, we're in Livestream 2. If you're looking for the link to join the Discord, it's here on the purple bar at the top of each live stream. But you can see we've got Regina giving a keynote about PostGIS. Heikki's going to talk about vector data. Adam is also going to talk about AI, right? Retrieval Augmented Generative, or I just call it RAG. How do you say?
Lotte.
Lotte used to be an intern in the Citus engineering team. Now she's getting her PhD in computer science and specifically databases. So I'm really interested in hearing her benchmarking talk. Marco's going to talk about data-intensive Postgres. Silvano, HA and DR at a glance with Azure Database for Postgres. Chris Ellis is amazing. And he's such an expert user that I'm really eager to hear how he connects the dots between JSONB and schemas. Boriss.
What's not to love?
I'm speechless. Boriss is not giving a traditional talk. He's giving a storytelling kind of talk, all about synchronous replication. So that should be a lot of fun.
And there will be a cameo by another community member, right?
Oh, that's right. In Boriss's talk, there is a cameo by another customer of Postgres. We won't reveal who right now. And then Jimmy and Flor, you're giving an amazing talk about how to work with other people, and it's going to cover, I believe, and I haven't seen it yet, but neurodiversity in tech and all the different types of ways our brains work and how we can work together better. Deepak is going to talk about Oracle to Postgres and using pgSQL code conversion when migrating. And then Ryan Booz is going to finish up the day and talk about partitioning, both from a performance and a maintenance perspective. So that's our plan for today. Looks pretty awesome.
What an excellent plan.
All right, so let's go ahead and introduce our keynote speaker now, Regina Obe. Regina is president and co-founder of Paragon Corporation, which is a Boston-based Postgres and PostGIS consulting company. She's a member of the PostGIS Executive Steering Committee and has been for a very long time. She's been involved from very early days on the project, which is probably like 20 years by now. She's on the open source geospatial system administration team. And she's co-authored several books on PostGIS, on PG routing, on Postgres. And the title of her talk today is The Open Source Geospatial Community, PostGIS, and Postgres. Are we ready, Flor?
Very.
Okay, let's do it.
Hello, I'm Regina, and today I'm going to talk about the open source geospatial community, Postgres, PostGIS, and how PostGIS joins the two. So why would you be interested in this talk? PostGIS is one of the oldest extensions that's not part of the Postgres core. And over the years, it has built on top of what has been added to Postgres, and it has also influenced the direction of Postgres in terms of what it can do, which is later used for other extensions. So a little bit about me. I'm the president of a database consulting company located in Boston, Massachusetts, primarily focused on PostGIS and Postgres consulting. I'm also a member of the PostGIS core development team and steering committee, as well as some other geospatial projects. Over the years, I've co-authored several books with my husband on SQL, PostGIS, PG routing, and PostgreSQL. And I'm still working on 2 new books, which I hope to be done with next year. So what exactly is PostGIS? Well, PostGIS started out as a single Postgres extension, but over the years has expanded into several more extensions that are part of the PostGIS project. And there are many ways of pronouncing PostGIS. There's the way that I normally pronounce it, PostGIS. And for people familiar with geographic information systems, they might call it PostGIS. And it's also a play on the fact that it came from Postgres and that it is a successor to the GIS movement. And then there's another pronunciation, PostGIS, which I think is cute, but I rarely hear that one. So why PostGIS? Why did PostGIS even come to being? And the primary reason for PostGIS is to make spatial data not special. And to understand what that means, if you flash back to before PostGIS was created, there were some standards coming about that were reaching maturity. There was the Open Geospatial Consortium Simple Features for SQL, which later morphed into the SQL Multimedia Standard, which is now part of the ISO SQL standard. And along the way, numerous output standardized formats were produced that allowed for sharing of data between systems. The most popular of which is the well-known text and well-known binary, which pretty much every spatial database supports. And then in addition, PostGIS supports several others. Some of them are not geospatial. For example, the scalar vector graphics allows you to draw PostGIS vectors directly on a web browser. And then there's the X3D, which is a successor to virtual reality modeling language. So PostGIS was born 2001, as mentioned, to make spatial data not special. And what exactly that means. So in 2001, there were very few relational databases that supported spatial data. So the world was divided into the geospatial world, which used primarily desktops and files to distribute systems, and the relational. And when they needed to interact with relational data, they grabbed the relational data, they stuffed it into their desktop, and they produced these files. But there were some spatial databases around that time. There was Oracle Locator, which pretty much could only do distance. There was Oracle Spatial, which cost 4 times the amount of Oracle, but was really what you needed to do advanced spatial operations. And believe it or not, before PostGIS even came on board, Postgres was already a spatial database. It's even in the name, GRES. So GRES stands for Graphical Retrieval System, and its predecessor, Ingres, stands for Interactive Graphical Retrieval System. Presumably they removed the in because it wasn't that interactive. And the other relational databases, aside from DB2, had no spatial functionality whatsoever. So at that time, everyone that was in the relational camp and needed to work with spatial data often migrated from the other relational databases, Oracle, SQL Server, MySQL. You saw quite a few people migrating from those to Postgres because of PostGIS. But PostGIS wasn't the only spatial extension for Postgres at the time. There was another that was around the same time called pgSphere. pgSphere was designed primarily for astronomical data, not for geospatial. And you might recognize some of the people that spearheaded that, Oleg and Theodore, who co-founded the company Postgres Pro, which much of the JSONB and GIST and full text advancements have come through them. And at the time, PostGIS and pgSphere both had a great interest in improving the GIST support, and so they banded together to improve that, which later on was used for other extensions. But PostGIS, even though it was standards compliant, it would be nowhere without desktop tools to support it. And that was one advantage it had over what was built into Postgres, in that it had friends. And these were various open source geospatial projects that came together later to form a foundation called the Open Source Geospatial Foundation. So the most popular of these are GeoServer, MapServer, QGIS, and GRASS. So QGIS started out as just a tool for viewing PostGIS data, but over the years expanded to view hundreds and hundreds of more, and it has a whole plugin extension system for people to hook in their various specialized workflows. And so if you look at what makes up PostGIS, it's got a couple of key features. There's the proj, which is the compass, and that allows it to transform between the various coordinate systems, which is very important for geospatial data, not so important for regular spatial. And then you have Postgres at the head, which allows it to interact with other relational data in the Postgres system. And since Postgres already built on standards and there are many drivers for it, it could easily interact with other relational databases. And then there's this other spatial components, Geometry Open Source Library, which I'm a member of too, which is the engine that does most of the processing, like buffering and intersection and unioning that PostGIS is most known for. Then there's the Geospatial Data Abstraction Library, which is used by the PostGIS raster extension for reading various rasters and doing things like map algebra on rasters. And there's the Computational Geographic Algorithm Library, which is used to power much of the 3D functionality in the PostGIS SF-Siegel extension. So those are all the pieces, but there's another project which is much bigger than PostGIS, and that is the OpenStreetMap project. And OpenStreetMap is a crowdsourced, think of Wikipedia except for maps, which aggregates work of hundreds of thousands of people to create a human-created map, as well as getting data from other governmental sources. And it started out storing their data in MySQL, but it did use PostGIS for tile generation, for the map, the displaying of the maps on the web. And eventually, it decided that Postgres had more functionality and the transactional support was much better than MySQL. So they migrated all their data to Postgres. For editing, they don't really use PostGIS, but they use it for tile generation. And then there are other tools like Leaflet, MapGL, which are JavaScript libraries, which can use the outputs like the GeoJSON that PostGIS provides or the Mapbox file. So you can use PostGIS even if you don't have like a mapping server. So I said spatial data is not special. And what do I mean by that? What I really mean is spatial data is not only special. Spatial data will always be special, but that doesn't mean that it can't benefit from the resources that a relational database can provide. And that's control of who has access to it, transactional support, and being able to use it from any language you want to use it from. So since PostGIS can speak SQL and it can provide pretty much all the standard spatial formats you can think of, you can tap into all its functionality with nothing but your basic .NET C, Go, or other languages that you're used to using. But if you didn't want to do all that plumbing, you could take advantage of the various desktop tools that have been created and map server tools that have been created to work with it. So here's an example PostGIS query. Find me the 3 closest roads, which looks like a pretty standard query, except for the less than dash greater than, which is the KNN distance operator. And that operator you'll see in other extensions such as pgvector. And you could also do, if you're you're into demographics, you could do analysis with any arbitrary area, such as boroughs of New York, or even areas that you define and ask, what's the count of the various types of crime that have happened in that time? So even though I can't prove it, I would say that PostGIS, beyond affecting Postgres, also affected the wider relational database market, and even new databases, data warehouse databases, distributed databases. So, for example, before, there were very few relational databases that had spatial support. But now it's almost a requirement that all relational databases have spatial support. And you could see that in SQL Server, which adopted the SQLMM in 2008. And MariaDB and MySQL have been slowly trying to beef up their spatial. And even SQLite has many extensions. So there's SpatialLite, which is basically a PostGIS but hooked into SQLite instead of Postgres. And you have the SQLite GeoPackage storage format, which is useful for distributing spatial data. And then you have CockroachDB, which is a distributed database that has a Postgres wire protocol compatible and SQL compatible interface. And it has built into it PostGIS. And then you have some other copycats. You have Alibaba Ganos. So they have a fork of Postgres, but they also provide, in addition to PostGIS, their own spatial extensions, which go beyond what the PostGIS raster, but the geometry is more or less equivalent. And so what exactly does PostGIS provide? Well, PostGIS provides 4 ways of modeling space. It has a flat, round, matrix, relational, which sometimes referred to as declarative because you declare that 2 things share an edge. So the flat model is the original model and the one that is part of the SQL standard. And it defines objects on a Cartesian grid. You can put 2-dimensional objects to 3-dimensional objects. So there's the 2.5D, which is basically a polygon with elevation, but then you can have true 3D, which are polyhedral surfaces and triangulated irregular networks. And those are used for city modeling and landscape modeling. And then you have the geography type, which PostGIS kind of borrowed from SQL Server, but it's not really part of the SQL MM. And it has more or less the same subtypes as the geometry, except it's missing curves, which geometry has, and it's missing the advanced 3D formats, polyhedral surface, and tins. However, the objects are drawn on a spheroid or sphere, and the coordinates are stored in longitude, latitude, so they're easy for newbies who are just trying to feed their GPS data into PostGIS. And then you have another format, which is probably my favorite format, the PostGIS raster. And raster data is my favorite because you can think about it in 2 ways. You can see it as a pretty picture, or you can see it as a set of matrices that are overlaid on the same space. So it's kind of a paint by numbers way of doing it, and you can aggregate things to form polygons and other things. And it's very popular in elevation, soil, population. It's the final product of aerial imagery, of aerial flights. And then you have the PostGIS topology extension, which provides the topogeometry type. And that basically treats objects as if they were primitives. So when you create a new topogeometry, it creates lines, points, and polygons in your topology. And so anything you add later on either uses existing ones or builds on that. So it's easy declaratively to say these 2 parcels share the same edge because they share the same edge. They're pointing at the same thing. And this is very popular for cadastral work where you have to manage boundaries. You don't want somebody's property folding into another person's property, and you want your boundaries, like your county boundaries, to be completely collective of the state. And in addition to the extensions that are part of the PostGIS project that provide types, there's also ones that just provide extra functionality. So there's the PostGIS SF Siegel, which provides much of the processing power for polyhedral surfaces and tins. So you can ask things like, what's the volume? What's the surface area? Give me a 3D convex hull, things like that. And then there's the PostGIS Tiger Geocoder, which is used for geocoding or reverse geocoding US data. And it utilizes US Census Tiger data, which it provides a loader script for. And then there's the address standardizer, which is the first step to geocoding. You want to take your address and split it into its elemental parts, like the street number, the street, the postal code. And so that's what address standardizer does for you. And so if you look at the box that has PostGIS 3+, those are all the extensions that come with PostGIS. But there are other extensions that extend PostGIS that are not packaged with PostGIS. And those are separate projects. So there's the PG routing project, which I'm a member of also, and it provides network routing. Primarily, it's used for geospatial networking, for example, trip navigation, plane routing, train routing, bicycle routing. But it's really just a bag of graph algorithms. So it can be used for any problems where a graph that can be expressed as a graph. And then there's Mobility DB, which extends the PostGIS geography types to provide a temporal element. And one of the nice things about Mobility DB is it has things like a temporal speed, average speed, aggregates, so that you could quickly, using a group by or an SQL group by, ask for the average speed of a portion of the trip. There is OGR FDW, which is a spatial extension, a foreign data wrapper, but it can read more than spatial data. You can read a whole folder of CSVs, for example, and it will automatically interpolate what the structure is of those. So I think PostGIS will be around for a while, and it's going to always contribute to the movement of Postgres. And I think it's a good example of how other extensions can build on top of each other. Thank you for listening. And if you need to contact me, my contact is here.
Well,
that was so good.
That was so good. I actually, when Regina came, the way being a keynote speaker works for Posette is I extended the invitation and threw out like a bunch of ideas. And then Regina came back with this proposal, right, of tying together the geospatial community, the PostGIS project, and Postgres and connecting those dots. And I loved it.
Yeah,
absolutely.
I'm so glad you did. I had no idea that OpenStreetMaps started with MySQL and then sort of like morphed to Postgres. That's a good origin story.
All right, so thank you, Regina. Thank you so much for being part of Posette and for kicking us off with the keynote talk today. Reminder to those of you who want to give feedback right away after a speaker gives their presentation, that link on the left, aka.ms/Posette survey talks, is how you can do that. And you can use that survey over and over and over again for as many talks as you want to do. And then the event survey is you do that once, obviously, for the whole thing. So those are our reminders. We have another reminder too.
Yeah, so there is a lot of chat going on in the Posette Conf channel on our Discord server, so definitely check that out. There's also being like a lot of really, really valuable links are being shared. Now I heard that there is already someone has already been voluntold to aggregate all of those links and make those available after the conference. But definitely there's a lot of valuable information being shared there, so check that out.
So aka.ms/open source Discord and go to the Posette Conf channel when you get there. If you are live posting this event, use the Posette Conf hashtag, please, whichever social platform is your current jam. And I think it's time to introduce our next speaker.
Yes, absolutely. And that honor is all mine. So our next speaker is Heikki Linnakangas. So Heikki is a co-founder of Neon and a longtime Postgres developer and committer. Since 2023, he's also been contributing to PG Vector, which is all the rage, of course, now. He was on your podcast before, Claire, right, with Andreas Freund, about how he got started as a developer and how he got started in Postgres in the first place. So that is definitely a one to, I wanted to say one to watch, but it's more one to listen, right?
one to listen. And it got a lot of extra listens after Andreas Freund discovered the XE backdoor a couple of months ago. So
yes, that will happen. And I, for one, I can't wait to learn more about vector data in Postgres and how it's different from normal data. So Heikki?
Teach us.
Hello, I'm Heikki Linnakangas. I've been working on Postgres and traditional databases for a long time. Today I'm going to talk about the vector data and how vector data is different from other kinds of data. So my background in pgvector and vector data in general is only since about last autumn. So I started to look at pgvector source code from the point of view of someone who knows how traditional databases and data types work. So I dove into the code. I didn't pay much attention to how do you actually generate vector data or how do you generate the data that goes into the database. That's not so interesting to me. But I looked at how Postgres and pgvector deals with this data. So one of the first things I found, like looking at the code, is this little snippet. This is a piece of code that runs whenever you're building an HNSW index with pgvector. This is code pretty deep in a pretty tight loop, so this runs hundreds of times for every tuple that you insert, like every vector that you're inserting. And I was thinking, HNSW index build was pretty slow, so I was thinking, how do you make that faster? And one thing that immediately stood out to me was that if you're doing a lot of allocations, look, there's 3 allocations here in a tight loop, so that has got to be very expensive. Or so I thought. And I have a lot of experience with B trees and traditional index types, so I thought, that's got to be the problem. It turned out that it really didn't matter. With HNSW, it's such a more expensive algorithm than regular B trees and stuff that those 3 allocations, they were just lost in the noise. I actually wrote a patch to fix them, like remove those allocations and make that faster. But again, like it didn't make any difference. It was like a couple of percentage points of the overall CPU time because there's just so much other stuff going on. So that was kind of my first lesson on vector data. First lesson was that these indexes and these algorithms are pretty expensive. They consume a lot of CPU. And what you might think from regular B trees or other index types, like the knowledge isn't applicable with these algorithms. They are different. So what is a vector anyway? If you go back to high school maths, you might remember that a vector is it's basically it has multiple dimensions, and each dimension has a magnitude. Like how if you think about a 2-dimensional vector, for example, it has an x-axis and y-axis, but it can have any number of dimensions. So at the database level, a vector is stored as an array of floats, basically, an array of floating point numbers. The number of dimensions that you have and what those dimensions actually mean depend on the use case and how you generated those vectors and what you're trying to do with them. For example, if you're using OpenAI, it has these language models with 1,536 dimensions. They have other ones with different amounts of dimensions. And in those models, the dimensions are kind of hard to imagine what they even mean. But what you basically just do with them is you compare them with each other, and and it depends on the model you're using. So one thing to note here is that each of these floats is stored as a 32-bit floating point number. So if you have 1,500 dimensions, that's over 6 kilobytes of data just for each vector. So that's a pretty large chunk of data if you compare it to a single integer or some simple data types or even text. So that was kind of my second lesson when I started to work with these vectors. They're pretty large. 6 kilobytes of data for each tuple, like each value in a column is pretty large. Postgres has a limit of 8 kilobytes per page per physical page, and 6 kilobytes is actually pretty close to that. If you have a piece of data that's larger than 8 kilobytes, then it gets what's called toasted in Postgres. So it actually gets split into smaller slices, and they're stored out of line, like not in the main table itself. So that typically happens with vector data. They get toasted and stored in a separate what's called the toast table. Postgres can deal with that, but it can affect the performance in, depending on what you do, that is either what you want, because you don't want your vectors to be part of the main table, because that speeds up queries on the main table if you're not accessing the vector. But on the other hand, if you are reading the vectors, then it can slow that down. So what's the big deal really with vectors and being large? Well, I mean, we have other data types that are also large. For example, you can have just text documents, or you can have binary blobs. The difference with that is that with the text document, you just store it in the database and you can retrieve it back, but you're not typically doing any queries on those large documents or binary blobs if you're storing images or such. You're not really doing any queries on them. There is full text search, but that works slightly differently. In full text search, you index each individual word or fragment of a word, but not the whole document as such. You're not really pushing around the whole document. Except if you do want to do some kind of smarter search on text documents, what you would actually do is to create a vector out of that text document, and then now you're kind of back to square one, and that you're dealing with vectors. Saying if you want to index images in Postgres, what you would actually do is that you index the vector that represents the image, and now you're back to square one with a large vector. JSON is another interesting case. JSON documents can be quite large. But what you actually do with the JSON document is, again, you don't index the whole document as such. It's not very interesting, but you split it into smaller key value pairs and you index those with the GIN index, for example. But that strategy doesn't work with vectors because in the vector search, all of the vector dimensions need to be searched together and considered together. You don't get just pick one of the dimensions and index that. So I mentioned vector search. What is vector search then? It's basically all about the nearest neighbor search. So you have an input query that is represented by one vector, and you have a lot of vectors in your database, and you want to find all of those vectors in the database that are similar to your search vector. And your query typically looks like this. You do select star from a table. You might have some extra filters there or something, but then you do order by the distance from your query vector. And you need to have a limit, or otherwise you're just going to return everything anyway. For example, here's an example query where I use the DBpedia, which is like Wikipedia articles database. This is a common example used in a lot of blog posts about pgvector, so I use the same one. If you're looking for all of the articles that are similar to parabolic reflector, you might run a query like this, and you might get results like that. And you can see the order by distance there and the limit. So isn't this very similar to how we're dealing with geospatial data? I mean, Postgres has, or there's an extension called PostGIS, which can deal with geospatial data. And even built-in Postgres has a point data type, and you can do nearest neighbor search on that. And the query, if you look at this geospatial query down here, I mean, that looks very similar to what you saw in the previous slide, which was it's a similarity search. Like you have an input point in this case, which you can think of as a two-dimensional vector, really. I mean, it has x, y, and y coordinates roughly. And you do a nearest neighbor search, so you wanna find the points that are close to that. So this looks very similar, right? So what's the big deal with vectors then? Is because we have had geospatial data for a long time, and you can deal with that just fine. Well, the basic difference is that the vectors just simply have a lot more dimensions. In maps or geographical data, you have 2 dimensions, 3 maybe, if you're dealing with the sphere like an Earth or some other system like that. But these vectors that you create for OpenAI stuff, like AI stuff or image search and applications like that, you have hundreds of dimensions or thousands of dimensions. And it turns out that the traditional approaches that you use to deal with geospatial data, like R trees, KD trees, partitioning, among some of the axes or some of the dimensions, they kind of stop working when you have so many dimensions. So you need different algorithms to do vector search. So and I went through this thought process myself. Like, can't you just use one of these approaches? And no, you cannot. The thing is that there's a phenomenon called curse of dimensionality, and I recommend to look it up on Wikipedia. But what it basically says is that many of these algorithms, especially if you're calculating the distance between 2 points, the distance metric kind of breaks down when you have more than 2 or 3, or maybe a handful, maybe let's say more than 10 dimensions, and the distance metrics kind of stops making sense. And I'm not going to try to prove that. I recommend to look it up and read the Wikipedia articles and other resources on that. But basically, one way to think about it is that your intuition of how the world works in higher dimensions is just wrong. It's very easy for humans to think in 2 dimensions, like, you have a flat surface and you can see all of the points there, or in 3 dimensions because our world is 3-dimensional. Maybe you can deal with the 4th dimension as a time, but if you try to go beyond that, like it's just impossible for a human to kind of. What does a sphere in 1,000 dimensions look like? It doesn't make sense to a human. And because of that, your intuition of how the algorithms and stuff works with the higher number of dimensions is just wrong. If you look at any of the papers on graph algorithms or vector search algorithms, you will see pictures like this one. This is from an HNSW paper. It's the first one I happened to find. And it's mapped as a 2-dimensional levels or layers. But it's important to realize that this is just a very flat approximation, because in reality, you would have thousands of dimensions here. And it just doesn't kind of fit in a human brain. So forget about it. Like, just trust the curse of dimensionality and smarter people who have done the research. These traditional algorithms that work fine with 2 or 3 dimensions, they don't work with higher dimensions. So one upshot of this is that, unfortunately, there are no good algorithms to do accurate nearest neighbor search in higher dimensions. But what you can do is what's called approximate nearest neighbor search. And therefore, all of these algorithms that deal with vector data, they are in fact approximate nearest neighbor search algorithms. They will not give you exact results, but you always have to kind of make a trade-off between recall, which means like how accurate is it, and speed. How fast is it to search? How fast is it to create the index? How much work are you willing to put into getting better, more accurate results? And if you're willing to accept that you're not going to get the exact results, but the approximate results, these algorithms work pretty well, but it is something to keep in mind. For example, here's one query from the same data set. And you can see that even though there is an order by distance, if you actually look at the numbers carefully, there is a problem there. Like, the distance of some of those things are marked here in red are actually not, those rows are actually not in the right order. If you run the same query, but you disable the index scans, you would get the correct result. But then it takes a lot longer. Here's another very typical case. People run into this all the time, and there's discussion on various approaches to fix this problem. But if you do a query and you add some filter, like in this case, you will have an extra condition that the title must begin with an A. The way the HNSW search will work, it will first find a set of results and sort them in the right order, and you do the filtering only after that. And it might actually not give you all of the results. So clearly, with the result here on the left with the index scan, like, that's incorrect. Like, you only get one result back, whereas on the right side you can see the correct result with the sequential scan there, and the index search just leaves out a lot of the details. So that's just something to keep in mind when working with these algorithms. And like myself, I've been working with databases for a long time, so it takes a little bit of getting used to that your query might actually return incorrect results, and just be cool with that. I think there would be stuff we could do in Postgres side to deal with this better. Because one consequence for this, for example, is that the planner might make like wrong choices or bad choices with the rest of the query plan. So if you have a complex plan and some part of that plan is using an index like this, and it doesn't return all of the correct results, but an approximate result, that can really screw up the rest of the plan. There isn't any great solutions to that, but like one workaround can be that if you put your vector search in a with clause, that can actually help, because and it's easier to think about anyway. Like, do the vector search separately as a separate part in the query, and then you add the additional filters and other conditions after that. At least it might not be the fastest way to do it, but at least it will, you know where the inaccuracies are coming from, at least in that way. So that's just something to keep in mind with vector search. It's not accurate, it's inaccurate. So vector search algorithms can be categorized into roughly 3 families of algorithms. There's cluster-based, which is the basic idea with cluster-based algorithms is that you try to find groupings of different vectors or different tuples, and you create a list of maybe 1,000 different lists or 1 million different lists, list of clusters, and then you clump together all of the similar stuff that is similar to that cluster in that list. That's one approach, and pgvector implements IVF flat, which belongs to this family of algorithms. Then there's graph-based. These are slightly newer algorithms. HNSW is the very common one, and that's the one also implemented by pgvector. There are others like DiskANN, but it's the same kind of approach. You have a graph, and you navigate that graph until you find the ones that are similar to your search. The rough trade-off between these algorithms is that the IVF flat is much faster to build, like it's relatively fast to build, but it's slower to search and provides less accurate results. The graph-based algorithms are slower to build. It takes a lot of memory, a lot of CPU to build, but they're very fast once you build the index, and they get pretty accurate results. One thing to note is that HNSW index build is an in-memory algorithm, and this is what I was looking at when I said that when I started to look at pgvector back in autumn, and I showed the piece of code with a lot of allocations. That was from HNSW index build. So it's very memory hungry. It basically assumes that the whole graph, the whole index fits in memory. And in Postgres, it better actually fit in what's called the maintenance workmem. Like that's an allocation, piece of allocation that you do upfront when you start to build the index. So it's very important that you tune the maintenance workmem correctly. It has to be basically large enough that your index fits in that memory. If you don't tune the maintenance workmem, then pgvector will actually give you this warning if you're trying to build the index and it doesn't fit in memory. If you will still try to soldier on and build the index, but it will take a long time. So you probably want to abort the index build at that point. Increase the amount of memory, like set maintenance workmem higher, assuming you have the RAM, and then try again. Searches are also pretty memory heavy. Like the same HNSW actually uses roughly the same algorithm for searching and inserting, like building the index. So even searches actually do like hundreds of random accesses all over the graph, which means like hundreds of pages are accessed for every search, which can be very slow if it doesn't fit in a RAM. So there are a few different approaches to this. At Neon, we are building something that like auto-scaling, which helps with this because you can have a large instance when you start to build the index, and you give that enough resources that you finish that quickly and you have enough RAM, and then you can shrink it down when you're doing the searches and you don't need such a big machine. I know there are some projects out there where you would use a large cluster or like a different instance types to build the index. You would ship the work of index build to a separate machine, and then when the index build is done, you just load it into the main database. That would be another approach of having the resources available at index build. But in general, the rule is that you need to have a large enough instance type when you're building the index that it fits in RAM. Otherwise, you will probably run out of patience. What this also means is that the amount of data that you can deal with is actually typically limited by the amount of memory you have. Like if you have billions of rows, in practice, you need to have a machine that has enough RAM to fit the whole data set. That's different from other data types in Postgres or in databases in general. Like Postgres can easily build a terabyte index or a B-tree index, even if you only have a gigabyte of RAM. It will just take a little longer, and sure, having more memory helps, but there are very efficient external sort algorithms that can build that index fast, even if it doesn't fit in RAM. But that's not the case with vector data. You are really bound by how much memory you have available. So some of the big advantages of or new stuff that came out in pgvector 0.7.0 version is new data types to specifically to address this problem, basically. So because you are bound by the memory size, if you can just make your vector smaller, that helps. You can fit more of them in the same amount of memory. Again, that's kind of true for any data type in Postgres and in database in general. Like if you can make your database smaller, that always helps because you have less data to deal with. Like you can fit more of your data in memory. It takes less time to warm the caches because there's less data to deal with. It makes your backups go faster because they're smaller. It makes restore go faster because it's smaller, and kind of the database size is a multiplier for all of the other things. But with pgvector, like with vector data, it's especially important because kind of your performance will go off a cliff if it doesn't fit in memory. So you have to make it fit. So the new data types in 0.7.0 are half-vec, which is basically an array of 16-bit floats, where the traditional vector data type is an array of 32-bit floats. So you lose some of the precision in all of the dimensions, but it makes the data a lot smaller, like half as big, basically. So that allows you, roughly speaking, to deal with twice as large indexes with the same amount of RAM. There is also support for indexing bit vectors, which is a bit string, like just 1 bit per each dimension. So that's obviously a lot smaller than the vector or even half-vec, like 1/32nd piece, 30th of the size of a 30-bit float. But that loses quite a lot of the precision. So it really depends on where your vectors are coming from. If they're still useful, if you reduce it down to 1 bit per dimension. If it does work, then great. I mean, that will make everything go much faster. But you probably want to experiment with that and see what works basically for your use case. Then the third one is called sparse-vec. So the basic idea of that is that if your vector data has a lot of dimensions, but most of the dimensions are 0 in any particular vector, then sparse-vec will only store the non-zero dimensions. So again, depending on the source of your vector data, like for how do you build your vectors, that might be a big win. So I have an example here of the half-vec data type. For example, you can see that this is the same data set I had with the queries earlier. The index build with the regular vector type took almost 7 minutes, 6 minutes and 42 seconds here. But with the half-vec, it only took 5 minutes, 14 seconds. So the time to build the index, it didn't quite go down to half the time, but it took like a quarter of the build time. And I think that's mostly because the operations are somewhat faster with smaller floats. And also, just because you have less data, it means that you get more benefit of caches. Like your CPU caches are more efficient. You can fit more data in your caches when the data is smaller. If you look at the size of the table, like you can see that it is, roughly half the size of the original table with the regular vector type. So that's the summary. My lessons when I've been working with vector data is that vector search is expensive and the vectors are large. And also they're large and they also need to fit in a RAM to really be able to deal with this data. And also vector data is, vector search is approximate, so you have to take that into account, and you have to get used to that if you are a traditional database guy who doesn't like incorrect query results. With vector data, you just kind of have to get used to that. That's all I have. Thank you.
All right, thanks, Heikki. I mean, those are a couple of caveats, but I think every new and exciting technology comes with some caveats. So definitely thanks for challenging, our way of thinking about vector data and AI, both in your talk, but also in Discord. There's a lively conversation going on in Discord. I think Heikki at one point on his slide said something like, but what about blah, blah, blah? Nope. And there's a lot of, but what about going on in the Discord, but that's only healthy and good. It's an opportunity to learn together, I think.
Well, so that is actually a reminder for me to pop up the screen that shows the address where you can join this virtual hallway track, aka.ms open source Discord. And when you get there, you join the Posette Conf channel. So all of the speakers have pre-recorded their talks. So as the talks are being live streamed, that speaker should be available on Discord to answer your questions or talk about universal greeting time. In the case of Heikki, he shared that, which is something I was unfamiliar with, and now I've got the explanation up on my screen, and it's a today I learned value, in addition to learning about vector data in Postgres. Okay, other logistical reminders that we want to make sure to share is that there is Posette community swag available. In particular, I have codes that I can pop up on the screen for people who want the sticker packs that are showing on the bottom. So if you go to ak.ms Posette swag and enter the code that's being shared there, you can get access to those. And then apparently people who were super active on the virtual hallway track, there's a way to get codes for the socks, which are in much more limited supply. So please feel free to go ahead and try to snag some of that. And then I think it's time to introduce our next speaker. And that responsibility falls to me. Entirely. Okay. So Adam Wolk is a principal technical program manager on the Postgres team at Microsoft. He's based in Poland, and he first started his database work with Oracle and PL/SQL in the finance world, and later became an OpenBSD developer. I think he worked at a free BSD-based company for 4 or 5 years, and most recently has been working on the AI capabilities with Postgres and Azure Database for Postgres here at Microsoft. And so his talk today is titled, as you can see on the screen, From Postgres Full Text Search to Retrieval Augmented Generative Search. And with that, let's go. Let's see what Adam is going to show us.
Hi, everybody. Welcome to my talk about going from rich text search to RAGS, Retrieval Augmented Generative Search. My name is Adam Wolk. I'm a principal program manager at Microsoft. This talk might be interesting to you if you happen to work with PostgreSQL, if you want to learn how to employ recent developments in machine learning models into your PostgreSQL applications. So without further ado, let's go into the slides. We will be building a chatbot email helper, and we will start with basic search, go through full text search, then AI-enabled semantic search, and finally end up on Retrieval Augmented Generation, also short for RAG. Now meet Millie the main elephant. Millie is a helpful little being going over the PostgreSQL mailing list archives that you may have been using to ask questions about PostgreSQL, and she will be here to answer all of your questions about PG based on what she read on the mailing list archives. So the way to approach implementation of something like that, you would go to the public PostgreSQL archives that you can download and then load into a database, let's say to an emails table. And then you could start with a naive implementation where you can do things like queries with a wildcard search and enter what the user said, like write a headlog. And you would happen to find this email, which is PostgreSQL capabilities. But another user may say wall log, and this email is no longer being found. Another user may have entered 2 spaces, and again the email would not be found. Now you may say that you built it wrong. You can use the wildcard search also between the keywords. And that's true. That would give you the first email again. But that's not very efficient. And also the amount of permutations you would have to do to capture both this and any other form would be just too much to implement. So what you can do to remedy this is to rely on full text search that happens to be present in PostgreSQL. So to enable full text search, we can alter the emails table, adding a TS vector column, and TS vector here stands for text search vector, not PG vector. And what we will do is we will take the subject and content. We will assign the weight A to the subject, weight B to the content, concatenate them together, and store them as a generated all results column called TS. Now, when you do that, all the emails will be parsed, and we will have this TS column that looks something like what you see on the screen right now. And now if the email has, for example, the email talks about PostgreSQL capabilities, and in the body it has capability, both occurrences of this word would be brought down to the common form kappa BL, with the location of each occurrence being noted next to the word and the weight that we assigned being also there. So for example, any form of the word log, which includes logs, log, logging, etc., will be enumerated. But what is the number standing for? The number is the end token in the email in our case. So I brought this from the previous slide to have it handy. Log 15B, 35B. This is the 15th token of the email, in this case logging, 35th token of the email, in this case log. And how do I know that it's the case? Well, with PostgreSQL, we can actually log into how things work. That's the benefit of having an open source database. You can call the TS debug function, which has been implemented by the developers of the database. That shows you exactly how the document is being tokenized. So we can see that the 15th token is the ASCII word logging that got stamped into the lexeme log. And this is how you can confirm these numbers to the content that you have been parsing. Now I did the highlighting manually, but you can also ask PG to highlight it using a user-defined function, UDF for short, called TS headline. And it will output by default the HTML bold tags around all the places where the content matches. And you can of course change what it outputs around it if you have a different app. Now, full text search does a ranking. So this number, the more relevant the result, the higher the number. And the complexity of this query is to show you how the output of the TS rank column itself and the web search to TS query user-defined function is just a nice way to write something in English and have it translated into this complex query language that the extension uses to find all what you said. And it understands things like cat or dog, and it would translate that to the logical OR operator, so it knows that it's either this or that. Okay. With full text search, of course, it's not cheap. It still takes time. So what you can do to speed things up is you can create indexes on it using, for example, a GIN index. So create emails index on the email table using GIN, and we can see the above query went from 3.5 milliseconds down to 0.062 milliseconds, which is a significant improvement. So what is semantic search? Now that we know how to search with full text search, we still won't get all the permutations that user asks. So for example, if I enter durable transaction log, that's the same thing as write ahead log, but a full text search will not be able to make a connection, but a large language model would. So to use a semantic search, we need to work with vectors. And a nice way to work with vectors in PostgreSQL is to use the pgvector extension. And what you typically store is embeddings. Embeddings are created by large language models. And the distance between two embeddings, so two vectors created by large language models, will show a similarity between them. So if you create an embedding for a transaction log or durable transaction log, and an embedding for the write ahead log, the distance between these two things will be shorter than from a cat or a dog. So that's what these models will be able to encode. Now, searching vectors is still costly. So there are multiple ways of indexing that. There's the inverted file index and hierarchical navigable small worlds. These are available in pgvector. They have different trade-offs for performance and recall, so read into them on what's more important in your specific use case. So now that we know how to work with vectors in PostgreSQL, how do we get embeddings? And if you are using Azure Database for PostgreSQL Flexible Server, you can actually use the Azure AI extension, which has multiple functionalities for cognitive services, for for extractive summarization, language detection, key phrase extraction, translations, and you can also create embeddings. So let's put this together. We start by creating a vector extension, which is pgvector, the Azure AI extension. We create the endpoint. We set the endpoint to what we defined in our Azure OpenAI deployment. We set the subscription key, and then we alter the emails table as we did with full text search, but this time adding an email embedding column of type vector, which is pgvector, of dimensions 1536, which matches what my deployment returns, generated always as a call to Azure OpenAI, create embeddings using text embedding add O to deployment, where we take the subject and content, concatenate them together, trim them to roughly 8,000 characters, because that's the limit of my deployment. And now that we have this, we can search over all our emails using semantic search, using this inner product operator to find the distance between whatever email and what is the write ahead log. And if you remember from the first slide, we had up to one email, which is the first one that had the exact occurrence of write ahead log, but we didn't see the remaining ones. And here we can see that the model was able to make the connection. And of course, semantic search takes time. So what we can do here is create an index, like we said, in this case, HNSW for inner product. And we can see the time of the above query going from 10 milliseconds to sub 1 millisecond. And since emails are big, you can see how we could use, for example, summarize abstractive to know what the email is talking about. So if I concatenate 5 emails that are semantically close to what is the page size and ask the model what they talk about, it describes them, but also you can see this part, specifically the 8 kilobyte page size of PostgreSQL. So it did find something that answers this question in the content. So what is RAG? RAG is Retrieval Augmented Generation. And if you ever used a large language model like ChatGPT, you know that it learned on a lot of the data from the internet. So if you ask it questions like, what's the write ahead log? It will answer that, but it may as well tell you how it works in MySQL, SQLite, or Oracle, for example. And it may make some weird connections like that. And even if you told it that you want to learn specifically about PostgreSQL, it might tell you how that worked in the 90s, not today, because that's overrepresented in the data on the internet. So what you want to do is you want some way to tell the model, hey, ground your answers in this set of documents and don't go over it. So you could write a simple prompt like this saying, answer the question using the document. And if you don't know the answer based on the document, say, have you tried turning it off and on again? And then you could add the content of the email as the document, and the model would see the question, what is the write-ahead log, look at this email, and it would be able to say, what is write-ahead logging more conventional way of assuring atomicity, etc., because the answer is in the document. So the big query here is not that important. What I want you to remember is that that's the way you grab an email and all the replies to the email, because the question is what's relevant to our search, but the answer is likely in the email chain below. So without further ado, let's skip into the demo and see how to put all of that together. So I built this Rails application and loaded it with some emails from the mailing list archive, and you can see there's a bunch of them here, like this one talking about passwords, and a reply that has an answer that somebody wrote a blog post to this on how to recover passwords. So how does it work? We have this email class that has this big query that you saw in this semantic thing. So let's use this to find all emails that talk about what is wall. And this is our Rails console. And you can see the big query being executed. And I have this context, which is a huge email. And I don't know what it is, but I could ask a machine learning model to summarize it. And I actually implemented that with a call here to, in the email class that uses Azure Cognitive Summarize Abstractive to summarize the content of the email that we just grabbed. And this will take a while to concatenate all the text, go over the internet, and return back a short summary what the document describes. So that's cool. Let's go further. We want to ask questions to the model. So we have also this chats interface where I can ask, what is the wall? And it will be going over the internet, asking them, like grabbing all the emails, chunking it, sending it over the internet, and hopefully getting back to us with an answer that the write-ahead log is a standard feature of PostgreSQL that ensures durability. So it works, but how? We have this the mailEvent class, where we define that if you have no idea, have you tried turning it off and on again? And then we have this brag pattern. So we need to split our data because my model happens to have a limit of tokens up to 4.5k tokens per request. And if we look at, using this Ruby method, how many tokens this above email has, we learned that it's over 7,000 tokens to get the answer. So that's too much within my limit. So I need to do this in chunks. Instead of one request, I'm going to do multiple. And for every request, I'm going to tell the model, hey, you're Millie, the playful mailEvent that knows everything about PostgreSQL. Answer the question based on the context. And if you don't know the answer, say no idea, which is have you tried turning it off and on again. Then we pass the content and the question, and we grab the list of responses, reject all the no idea ones, and return the first one that looks good. So how does this work in code? Let's run this in the Rails console. You see the big query being executed to grab the context. You see each chunk, as I described, being processed because it has to fit in my token limits. And there are multiple replies, and one of them is the one that we selected and presented to the user in the chat. Now I can ask it anything, like I can ask it, how do I forgot my password, help, and it will process again. And some of the chunks may not have an answer, so we will get, have you tried turning it off and on again? And we ignored that. But others are good, and we get an answer that's acceptable. We can also ask it different things like how to store binary data. And it should tell you something about, for example, byte arrays in PostgreSQL. Or something else, depending on the emails it finds and the decisions that the model takes based on the data that it's provided in all the chunks. We will let it run for a while as we prepare for the next one, which is when do I manually vacuum? Okay, unfortunately, these things are undeterministic, but we have binary data is best stored in byte A data type in PostgreSQL, and you can see a lot of them have answers. So let's ask it, when do I manually vacuum? And it tells us that manually vacuum when dealing with temporary tables, because auto-vacuum, auto-analyze cannot process them, which is a great answer. And the interesting part is, if you noticed, in my query here, I limited emails to above 2020. And let's remove that limitation, reload the Rails model, and redo this query, and see what the model tells us. Now we are also reading all the emails that I have loaded from the 90s, like I said in the example where I mentioned ChatGPT, and I expect it to provide not so good answers anymore. And it tells me that it is common practice to set up cron jobs to vacuum databases nightly and things like that. And the reason it does that is because in some of those emails, they are so old that auto-vacuum was not a thing. So that's why you might want to do this hybrid search approach, where you take both things like basic search, column filtering, and full text search to pre-filter the data set. And that helps you to save time on indexing, time on searching through all the vectors, because vector similarity search is costly operation. So you can benefit from other methods of searching. And maybe as a final thing to show, we can see how it behaves if we ask a question in a different language. For example, j'oubliais mon mot de passe, aide-moi. So I forgot my password, help me, in French. And you can see in the query that it also did the query in French, so you don't need to translate what the user typed in the search field. And it told you, we actually saw this email. Hi, the answer to this question in French is, you might want to read this blog post that tells you how to recover a lost password in PostgreSQL. And you can modify the prompt to have it answer in the same language as the user asked the question. And in the case of all these answers I had, where there were a lot of them and I just picked the first one, you can also grab the full list of answers, send it to a model and say, hey, pick the best answer out of these. And that would be a smarter way of doing that, so you have some ideas on how to improve this. So hopefully with this, you feel more encouraged to explore how you can employ AI and vector similarity search within your PostgreSQL-based applications, and see how easy it is now to do this quickly in your apps. So thank you for watching the talk. It's been a pleasure. See you around.
That was so much fun.
It was, and I'm super grateful that Adam actually shared a link to that demo so we can all try it at home too.
Thank you, Adam, for your talk today and sharing all of your AI expertise with Postgres. All right, let's see. We have a couple quick reminders. The first is, here are the links to the surveys for the attendees. You can fill out the talk survey for as many talks as you want to give feedback on. It's showing on the left-hand side. And if you want to give feedback to the organizers about the entire event, that's something you do once. And that event survey link is showing on the right-hand side. So please, feedback is a gift, and you're welcome to do it at any point. And then just a reminder, Flor just mentioned the virtual hallway track on Discord. So you can get there at ak.ms open source Discord. And when you arrive on that Microsoft open source Discord, you go to the Posette Conf channel. And that's where the chit chat is happening during the event. Now, what's cool is we have a movie trailer. So I don't know if anyone's eating popcorn early in the morning in the EMEA time zones. But
it's not very common to eat popcorn in the morning, even in EMEA.
Okay. Well, what we're going to see is about 20 seconds of video snippets for each of the upcoming talks in the next live stream. So here's our movie trailer for live stream 3. Let's roll.
Hi, I'm Sarah Novotny, and I'm a longtime open source community contributor. I've worked in projects and communities like MySQL, Nginx, and Kubernetes, to name a few. And today I'm going to talk about Kubernetes and the different things that I have learned and loved from that project.
2 years ago, I gave a talk at CitusCon called Explain the Postgres Query Optimizer. And today I'm giving the follow-up to that talk, building on the basics of Explain the Query Optimizer, talking about all the other things that the optimizer does that I didn't get a chance to talk about 2 years ago. So I'm looking forward to this talk, and I hope you enjoy it too.
I help customers migrating their workloads to Azure, and I've been working with many customers around the world across different industries in complex PostgreSQL implementations, and I've been helping them in resolving their performance and scalability issues.
Hello, I am Pamela Fox, and I'm talking about pgvector for Python developers. pgvector is a great extension that you can use in order to store vectors in your database and then do distance operations on them. It's incredibly useful if you're doing any sort of similarity search, especially for generative AI applications like Retrieval Augmented Generation, in order to search and chat with items in your database. So come to my session to learn more about pgvector for Postgres and Python.
We are here today to walk you through a presentation on PostgreSQL physical replication, the internals of this, recent developments, and what sort of future work can be done around physical replication.
Hello, my name is Grant Fritchie. Today I'm going to talk to you about using Query Store to understand performance inside your PostgreSQL database. This is really important because unless you know what's happening inside your database and you know how your queries are behaving, tuning those queries and getting them to run fast is going to be really difficult. But Query Store inside of your Azure Postgres database will absolutely help you get it done. Come to the session, find out how.
Hello, my name is Taylor. I'm here to talk to you about Postgres, specifically task queues in Postgres, specifically how to implement and use them for great benefit so that you do not have to use something like PubSub or Airflow or Kafka, whatever those other things are. You could just use Postgres. It's very nice. So yeah, let's get into it.
My name is Denzel Ribeiro. I'm a principal product manager at Microsoft working on the Postgres service. And today I'm going to talk about 6 things you can do with the Azure AI and Azure Local AI extensions, which are first-party extensions. They greatly simplify building Gen AI applications on Postgres.
And today I'm going to give a talk on how to use Postgres views to revitalize your complicated or outdated data models. I think this is very relevant for software developers who are working in startup environments where your data model is constantly changing.
My name is Varun Dhawan. I'm a product manager with Azure Postgres team at Microsoft. Today, I'm going to talk about top features that make Azure Postgres great for developers. I believe this will be an interesting talk for anybody who wants to start developing on Postgres, whether community Postgres or Azure specifically on Azure Database for Postgres.
I really love these trailers, and especially Taylor's comment. You can just use Postgres. It's nice. It's
Whatever those other things are, just go ahead and use Postgres. Yeah, classic mantra in this space. Okay, let's go ahead and do our next introduction.
Yes, and that's on me, and it's great because I can speak a couple of words of Dutch. So our next speaker is Lotte Felius. Lotte is a second-year PhD student at the Centrum voor Wiskunde en Informatica, or Mathematics and Informatics, based in Amsterdam, in the Netherlands. She's in the database architectures group at CWI, and her current research includes secure query processing, lightweight compression on GPUs, and secure next-gen file formats. Also speaks Spanish, I found out yesterday. That's pretty cool. And for this particular talk, Lotte investigated the performance of Citus using the Citus benchmark suite while being at Citus as an intern, right?
Yeah. In fact, I think Lotte's work as a summer intern, an engineering intern, is what first got her into databases. I'm not sure she would be doing her PhD in databases if it weren't for that. But you never know. Like, you never know what the other paths in life might have been. And I know that Lotte's on the virtual hallway track on the Discord right now if people have questions during her talk.
Yeah, joining us from a very different part of the world today, I think. So that's very cool. Ask her about that. And let's watch the video.
Hello, my name is Lotte Felius, and currently I am a second-year PhD student at CWI in Database Architectures in Amsterdam, the Netherlands. I was a former intern in Citus in 2022, and a part of this talk will actually address a part of the work that I did as an intern in Citus. Mind you, I was completely new into databases. I never heard about PostgreSQL, and I barely knew anything about any software engineering practices. So if you are also a beginner, please stay tuned for this talk because it might be interesting for you. And before we begin, this talk is lessons learned from benchmarking and profiling distributed PostgreSQL. It's not exactly about the benchmarking numbers that I got, but it's more about how I use the benchmarks to, in the end, identify some limitations or bottlenecks inside this. So hang on and let's start. So this is the outline of the presentation. First, I'm going to tell a bit about different architectures that are used for different PostgreSQL offerings. Then I will talk about the goals for the research and the challenges that I faced. Then I will talk about how I actually benchmark Citus, which benchmark tooling I used, for example, and how I did it. Then I will talk about how I measured and quantified the performance. Following, I will explain how I identified the bottlenecks. And last but not least, I have some key takeaways for you that might help you if you also are going to profile or benchmark Citus or any other distributed PostgreSQL offering. So first of all, there exist multiple different PostgreSQL offerings, such as Yugabyte, Amazon Aurora, Google Spanner, CockroachDB, and AlloyDB. But there's also, of course, Citus. And these systems have in common that most of them are based on a shared nothing architecture or a shared disk architecture. And Citus is even a little bit different because Citus is an extension on PostgreSQL, which makes it easy to be compatible with the PostgreSQL open source ecosystem and libraries. And this, for example, is very handy whenever a new PostgreSQL version is updated, and it costs very little effort to make Citus compatible with this newer PostgreSQL version. So now we're going to explain shared nothing versus shared disk. So What is the difference between these two? Well, Citus is based on a shared nothing architecture. A shared nothing architecture basically is a cluster that consists of different nodes, but each node is considered as a separate machine. So each node has their own memory and each node has their own disk. And there's no way that each node can directly access the memory or the disk of another node. So how does that translate in Citus? Well, a Citus cluster consists of independent machines or nodes. The coordination between these nodes is actually happening on the software layer. And in the case of Citus, Citus manages the coordination itself. How does it do that? It creates distributed tables and shards across many nodes. And Citus also enables elasticity to scale up or to scale down. So whenever the workload intensity changes, a user can add nodes or remove nodes of the Citus cluster to match the workload intensity, basically. And for example, if we take Amazon Aurora, it makes use of shared disk. What is the main difference between shared nothing and shared disk? Is that it disaggregates compute and storage. So there are still separate nodes in the cluster, but each node are accessing all the same disk through the network. So this has some advantages because by disaggregating compute and storage, you can manage, for example, writes asynchronously. On top of that, Aurora has some smart tricks to minimize I/O, for example, because it only writes redo logs to storage, which basically means that it only writes changes of data pages to storage instead of that it writes whole new pages. Then it pushes these changes to the storage layer, and the storage layer itself takes care of finally writing the new data pages. So in the end, an instance in Aurora can just request the newest version of a page from disk. A downside, however, is that there's only one primary instance in Aurora, and there are multiple write replicas, up to 15, that you can configure. But this means, because there's only one write instance, that it can limit write throughput. And this is different in Citus, because when Citus 11 was released, the default mode of Citus enables every user to connect with any node within the cluster. And this means that the write throughput can actually be better, because every node in a Citus cluster can take care of the coordination of a distributed query, but it can also serve the distributed query in itself. This, however, means that there are multiple connections established within the cluster as well. However, Citus does a smart trick. It caches connections to obtain a higher performance. However, a downside from this could be that this could lead to a connection scaling bottleneck in the end. But still, let's dive in. How does Citus do this coordination exactly? Well, let's go back to the PostgreSQL query processing pipeline. This consists of a parser, of an analyzer, of a rewriter, a planner, and an executor. The parser makes sure that the query gets parsed correctly, so it does also some syntactic analysis. And then subsequently, the analyzer analyzes the query and checks, for example, if the columns that are referred to, if they exist. And it also makes sure that the data types are inferred. Then we have the rewriter. The rewriter rewrites some query expressions into according to a set of rules, mostly based on relational algebra. And then the planner evaluates many different query plans and tries to choose the most optimal query plan so that the query gets executed most efficiently. And last but not least, we have the executor, and the executor makes sure that the query gets executed according to the query plan that the planner proposed. Citus extends the planner and executor phase of the PostgreSQL query processing pipeline, and this is necessary because a Citus cluster consists of multiple nodes, so it needs to have a different plan. And on top of that, it also extends the executor. The distributed executor makes sure that every query, which is now divided in query fragments, that all these fragments get executed on the right nodes. And also the executor is responsible for opening a connection from the shard to any worker node. So yeah, basically the executor is the final step. However, there are some potential pitfalls. The first is that PostgreSQL in general is process-based. This means that it's single-threaded in most of the cases. There are exceptions. But this means that if you want to fire multiple concurrent queries, you need to establish also multiple connections. And connections are not for free. Actually, they consume a bit of CPU, but they also consume a bit of memory. So it's not that you can have unlimited connections with any system. Also, within the Citus architecture, each connection to any node leads to one or multiple connections within the cluster because a query needs to be forwarded to a second node. This connection overhead, if there are a lot of connections, can increase ultimately the network latency because the network can get saturated by sending all the queries over to different nodes, but also the management of the connections can be pretty heavy. And on top of that, distributed queries require coordination. And this coordination is extra on top of just a single node system. And this coordination itself can just also incur a bit of overhead. So now the scope of our research. We're today benchmarking the scalability of Citus. And you can define scalability in multiple ways, but we are only adding nodes. We will see how much Citus scales by adding nodes. And we're also going to see how Citus scales by adding connections. This way, we hope we can identify some limitations or bottlenecks that occur in certain configurations. However, there are some main challenges, specifically for distributed systems like Citus. Because benchmarking a distributed system is not straightforward. It's actually pretty hard. And this is because nodes may fail at any moment in time. You have absolutely no control over that. You might figure that out very late. So that's really something you need to take into account. The second challenge is that monitoring all factors involved is very, very hard, because even monitoring a single node system already can be hard because there are many concurrent processes that are executed at one node alone. So if you have multiple nodes, you need to monitor everything on all the different nodes. Plus, you need to monitor the communication between the nodes, such as also the network saturation and that kind of stuff. So it's also very hard in the end. How do we quantify this performance of a distributed system? Because there are so many factors. And another thing that we need to pay attention to is we need to avoid the Heisenberg effect. And the Heisenberg principle ascribes the uncertainty in the measurable quantities to the jolt-like disturbance triggered by the act of observation itself. Well, this actually seems a lot, but it basically means that if you monitor a lot of stuff, you might introduce noise yourself, that you're in the end measuring yourself. And the noise can also decrease the performance in the end. So to give a little example, if you will log every query in Postgres, this will incur a lot of overhead because you need to write all the logs also to storage, and this will have an impact on performance. So how did we benchmark Citus? For that, we use the Citus benchmark suite. It's available on GitHub. It already had a HammerDB and CH implementation. But we also added the YCSB benchmark suite. So now you can also benchmark Citus with YCSB. So what is YCSB? YCSB is the Yahoo Cloud Serving Benchmark. It's very often used. It consists of 7 core workloads, and the workloads are very simple. Just small create, read, update, and delete operations, also referred to as OLTP. And within YCSB, one record is pretty big. It's around 1 kilobyte, and it has 10 fields, and it consists of completely random data, as you can see. This is an example of a YCSB insert. You cannot make any sense of it at all. So YCSB is also compatible with the JDBC driver. This is very handy because the JDBC driver distributes the workload among many nodes in a Citus cluster. So we make a lot of use of that. And the performance of YCSB is measured in transactions per second. So in this talk, we are only focusing on workload A, which is 100% inserts, and workload C, which is a read-only workload, and it consists of 100% selects. We do this because we want to keep it relatively simple, but also because we want to measure as good as we can the pure effect of only inserts or only selects on Citus in this case. So this is the benchmarking setup. We have some kind of control plane locally on our laptop where it spins up the Citus benchmark repository. The benchmark repository spins up a driver VM, and the driver VM itself also spins up another instance of the benchmark repository, which in the end also initiates YCSB and the JDBC driver and actually starts the benchmarks automatically. So everything is done automatically. And the driver VM also makes sure that when the benchmarks are finished, that the benchmark results are collected and actually brought back to your local machine in the end. So here you see some results. These are for 100% inserts. And what we did here is we increased the amount of connections. We increased them until 3600 because after that we sometimes got out of memory errors, which means that connections cannot scale further than that if you don't want to get errors sometimes. But you can see that there is actually an increase in throughput in transactions per second. So the more connections you establish with the cluster, the higher the throughput is in case of inserts. However, if we look at the case of the 100% selects, we see different behavior because here with 800 connections, we see some kind of optimum. The throughput is the highest when we use 800 connections. And if we use more connections than 800, actually the performance starts to decrease quite a bit. And this is a bit of behavior. So let's investigate why that actually happens. So how did we measure the performance? How did we further investigate it? What happened under the hood? For that, we use some profiling tools. Mind you that Azure itself also provides some statistics, but in this case, it was easier to manually use IOStat in this case. And IOStat collects like the CPU usage and the memory usage and IO and stuff like that. Then we just use regular Postgres logging, but in a slightly different way, which I will explain later. And we use perf, and perf is between brackets because we only sometimes manually used it to identify under very large workloads which processes took up the most CPU. And this could only be done by hand as far as we managed. So I'm not going to explain more about that in this talk. And this is the profiling setup that we used. Actually, it's pretty much similar as the benchmark setup. The only difference here is that we also spin up a host process on the local machine. And this host process communicates with a server process that we spin up at the driver VM. They communicate with each other to give a signal, especially from the driver to the local machine, to give a signal when the cluster is configured and when the benchmarks itself are starting with YCSB. This is because the host process initiates IOStat on every node in the cluster to collect statistics, and we only wanted to collect statistics specifically when the benchmark was running to avoid very large logs of IOStat, and it's way more handy to only have the statistics from when the actual workload was executed. And this worked pretty well. Everything was automated, so it made it easy to analyze. For the sampling, this was a bit more complicated because we had to create a second user, which we call monitor. And this user was also executing a part of the workload. To be specific, 0.01% of the workload we had to find. And the workload we had to find was always 100 million records. We could do this because YCSB enables parallel execution. And the reason why we only logged a fraction is, like I said before, we don't want the Heisenberg effect. We don't want to increase the performance, decrease the performance. We had to do it this way because there was no feature yet that could log distributed queries. So to work around that, we made sure that we just logged a fraction by using a second user. So how did we identify the bottlenecks in the end? First, we looked at the research utilization, and to be specific, we looked at the CPU usage. And what you see here is a CPU usage of 100% insert workload. And what we can observe from this is that for all nodes, with 800 connections, the CPU usage is pretty low. It's around 20% with a peak in the beginning. And the peak in the beginning is probably because the establishment of connections takes always a while before everything is established. So that increases the CPU usage. But after that, it gets stabilized and it remains below. If we use 3,200 connections, the CPU usage is a bit more higher, but still it's relatively low. It's around 40%, mostly even less. And also another thing that we notice is that the variation is a bit more if you use more connections. But yeah, that makes sense as well. Mind you, we used nodes with 128 gigabyte of RAM. So 100 million inserts fit in RAM. So we had no spilling to disk at all. And from the PostgreSQL logs, we from the monitor user specifically, we tried to create some kind of profile of a query. And this consists of the time that a query spent on the worker node, or the child compute as we called it. It's the blue bar with the dashes. And yeah, we had an overall execution time, and we also tried to kind of measure the latency. But what you can see of the insert query is actually that almost all time is spent on the child compute node, on the child compute. So this means that yeah, a lot of the time the query was basically waiting, because for inserts everything gets written to a write-ahead log, and this write-ahead log needs to be flushed to disk, and there needs to be sent an acknowledgement back. And when the acknowledgement is sent back, the client gets informed that the query actually succeeded. However, if you have little nodes, there's probably kind of a queue for the buffers for the write-ahead log, which makes it very slow. So adding multiple nodes helps a lot with yeah, increasing the average execution time. However, doesn't matter which configuration, always most of the time is spent waiting for disk I/O basically. So what do we conclude about that? Inserts seem memory limited. Clusters are mostly bound by the available memory, and there are around 31 connections per gigabyte. And we identified that disk I/O is a kind of straggler cause in this case. So now we look at the CPU usage of 100% select workload. We see here that the CPU usage is way higher. For 800 connections, it's already between 60 and 80, but for 3,200 connections, it's almost saturating the CPU. So this could indicate a bottleneck. And also here, if you look at the profile of a select query, you could see that it's very different. Actually, the compute itself on the worker node is very, very little, but the latency is longer, and the pink part of the bar actually indicates that most of the time is spent on the parent node, so the coordinator node basically. And this could be because the coordination is not inefficient. We don't know the exact cause, but there's room for improvement there. So to conclude, read workloads seem compute bound. If you use more than 800 connections in this case, this could lead to a performance regression. Note that it's only for the 100% read workload. And the system here behaves as compute bound. The reason is also probably because reads are very, very light, especially compared to inserts. And connections are relatively heavy. So most of the time is probably spent into context switches. So if you have a very light workload, such as only reads, then you need to take care of how many connections you actually establish to the cluster. So last but not least, the key takeaways. First, I learned to really scope your problem. Which benchmarking tools are you using? Which workload are you using? And which skill are you using? Because each different tool, workload, and skill may expose extremely different behavior, opposite behavior. So take into account what you measure and how you want to measure it. The second key takeaway is that benchmarking a distributed system can be very time consuming because nodes indeed fail randomly at any time. And when you don't expect it, when you don't want it. So you need to take a lot of time. The third key takeaway is work step by step. So work really gradually. First set the scope, then micro benchmark, then identify anomalies or identify unexpected behavior or any other limitations, and then try to find the bottlenecks by profiling and also just thinking logically. The last takeaway I really want to stress is that identifying bottlenecks in a distributed PostgreSQL is hard because you almost never know the exact cause. And this is a general problem of distributed systems, I think, because even if you find some kind of straggler cause, it can depend on many, many different other causes. And if you remove one straggler cause, it will probably expose other bottlenecks and you will forever be optimizing. But yeah, every bit helps, I would say. So this concludes the talk. Thanks a lot. And I really hope you enjoyed. And if you have any questions, feel free to ask them.
You know, I don't know if it's okay if I reveal this or not. I'm not sure if I'm going to get in trouble from Lotte, but her talk proposal came in literally with 30 seconds to spare before the CFP closed. And oh my gosh, I'm so glad that she submitted. I'm so glad her talk was accepted. Obviously, I'm predisposed to be interested in anything Citus, but her sharing the learnings on distributing Postgres, the benchmarks, the process, I love that she did this.
And I thought it was a unique skill that there was a question in the live chat, and she's like, I'm answering this later in my pre-recorded talk. So she anticipated questions that were going to be asked. So that's impressive.
Thank you. Thank you very much, Lotte. Okay, reminder about the survey. If you want to give feedback to Lotte or any of the speakers whose talks you've already watched, you can use that link that's showing on the left, aka.ms/Posette survey talks. And you can do that as many times as you need to, once per talk. And then the event survey is for the whole event. So please, feedback is welcome. You can do it at any time. The surveys close on the 18th of June, so next Tuesday. So you've got a couple days left. I think we have just a couple minutes to talk a little bit about this podcast. And I'm curious how many people have heard of it. It's a podcast that focuses on the human side of Postgres, and it comes out monthly. And it originally started as a pre-event for last year's CitusCon, which is the former name of Posette. But then we continued, and it kind of came up with a life of its own.
I love it how that happens, right? Like something sort of like sticks and you want to continue doing it. And it would be a shame to just limit it to a pre-event for this one. I've been on this podcast and it's been a lot of fun as a speaker or attendee or podcaster. I don't know what the official title is, but it's also been super fun to be in attendance of the podcast because it is recorded live as well, and so you can join in Discord as well and ask your questions there and sort of influence what kind of questions are being asked of the speakers. It's always a really fun experience.
As far as podcasts go, it was completely inspired by a podcast that some friends of mine, Brian Cantrell and Adam Leventhal, created over at Oxide. So Oxide and Friends was the inspiration. And so that's why, yeah, we record live on Discord. And then there's that kind of parallel text chat that anybody can be part of that's happening at the same time. But you can see some of the amazing guests that we've had on who've talked about like their origin stories or how they got started as a developer, their journey into monitoring Postgres, benchmarking Postgres, being a Postgres committer, all of those journeys. So what are some of the other topics? Oh, PostGIS, Regina Obe, the keynote speaker for this event today, was also a guest along with Paul Ramsey. So the URL's in the bottom right. If any of you want to check it out, we just had to take the opportunity to make sure people know about it. And we also wanted people to know that we're going to be rolling out a new name next month. my friends were kind of beating me up a little bit. Like, Claire, this podcast is all about Postgres. It doesn't have anything to do with CitusCon anymore. You need to rename it. So we are finally going to do that next month. And the new name is Talking Postgres. What do you think?
Good.
Are you cool with it?
I'll allow it.
Allow
That's a great name, absolutely. And if you go to the website for Posette, you can actually see all of the interviews the podcast that our speakers have engaged in. So,
on the speaker pages, you mean? So when you go through the schedule, if you click on a speaker, the speaker interviews are there for about half of the speakers who submitted them. Yeah. And then if you gave a talk at a previous CitusCon or have been a guest on the podcast, those links are there too. Good point. Thank you. All right, so let's introduce our next speaker. And that responsibility falls to me. And Marco Slot, welcome. Marco is a software Imagineer at Crunchy Data. And just to turn the circle back to me, I had the privilege of working with Marco for over 6 years, and I learned so much from him. First at Citus Data and then at Microsoft. Marco is based in the Netherlands, like you, Floor, has a PhD from Trinity College Dublin, and is an expert in all things distributed systems and distributed Postgres in particular. And last year, in year 2 of this event, Marco actually delivered one of the keynote talks as well. And right now, these days, he's building a new generation of Postgres extensions at Crunchy Data. And the title of today's talk is Data Intensive Postgres, 3 Ways to Scale. And with that, let's see what Marco's going to teach us.
Hello, everyone. I'm Marco Slot. I'm a software engineer at Crunchy Data, and I'm going to be talking about data-intensive Postgres, 3 ways to scale, or rather 3 different types of workloads that you might struggle with on Postgres if you have a data-intensive application. Basically, the word data-intensive, I think, comes from this book, Designing Data-Intensive Applications by Martin Kleppmann, and he gives a good definition where we call an application data-intensive if data is its primary challenge, either the quantity, the complexity, or the speed at which it's changing. It's a pretty good definition. Another term that people have used is the 3 V's of data. I find it a bit easier to remember. It's the volume, the velocity, and the variety of the data can make a data problem hard. So how much data am I storing, ingesting, accessing? That's the volume. How quickly does it change? How frequently how fast does the data need to go through the system? The velocity, and how many different types of data and queries and relationships and distributions. That's the variety of the data. And so when these are high, you kind of have a data-intensive application, and those are always a little bit tricky to deal with. So we're going to look at a few different types of workloads that people often run on Postgres, and how you can essentially deal with them if they become data-intensive. And not all applications have a tendency to become data-intensive. If you're running you're just keeping the grades for a single school in a database, that's not going to be a data-intensive application anytime soon. Not all data-intensive applications use Postgres, like training machine learning models at scale. But some applications use Postgres and tend to collect a lot of data or ingest a lot of data. For example, software as a service applications, they can quickly add more customers that bring in more data into the system. Time series scenarios, they have this large stream of data and want to do analytics on it. And business intelligence, where we take all the data from the company and try to make data-driven decisions. So some of these applications, they tend to get to a point where they are data-intensive, where there's a lot of load, a lot of variety, velocity, volume, and then things get hard. And that brings us to the age-old question of how do you scale Postgres? And people who know me know that I only have one answer to this question. It depends. Really depends on the characteristics of the workload. So scalability and performance are these kind of multifaceted umbrella terms almost. So performance has a few different facets. For example, response time is the most obvious one. how long does it take between me clicking a button and the application doing something. But there's also the timeliness and quality of data. So how long does it take between an event happening and it showing up in the application? If the system is performing poorly, it doesn't scale, it might start taking longer, or maybe I'm missing some of my data. And systems builders also use this notion of good put, which is the work that the application or the database does, which is actually useful. Because you could have a database that's processing lots of data really quickly to answer all sorts of queries, but maybe the users feel like they're waiting so long that they switch to another screen and they never see the result of the query. So that's high throughput, but not good put. And it's important to get good put. So under high load, obviously things get slower, partly because the CPU and the disk, they might be busy. But there can also be these secondary effects where, for example, in Postgres, you have auto vacuum, where if the auto vacuum process falls behind, the table gets bigger and more bloated. And then scans on that table take longer, but also use more resources, putting more pressure on the system. So you can get into these spirals that can be very nasty to get out of. So to deal with this, I mean, one thing we should always do is tuning, but it doesn't always help as much as we'd like. The really important things to do is in the design of the application and the database, because we need really good data structures. We need to use the right indexes, materialized views, good table design. Another thing we might need to do is take a good advantage of parallelism or scale out using multiple machines. And a third, often forgotten aspect is application co-design. Like, you should design your application in a way that allows your database to scale. For example, if you need to insert a lot of data into your database, it's best not to do single row inserts because every insert has some overhead. Every commit has some overhead. It's also best not to do multi-row inserts. They just take a lot of memory. It's better to do copy. Copy is very efficient, can ingest a lot of data per second. So it's important to consider the characteristics of the workload to decide like which one of these things can I do to kind of help me deal with my data problem. So if I have building a software as a service, I think it's a great thing both for software builders and for software users, because customers, like, they don't have to install stuff on their laptops or their employees' laptops. They just sign up, and usually through single sign-on, immediately everyone in a company can start using it. And of course, for the vendor, that's great, easy to onboard new customers. And as a result, software as a service sometimes grows pretty quickly, and that can put some pressure on the database. And one of the subtle issues in that is that you get a pretty large working set, which means that the part of the data that sits in memory. So if you think of a news website, like, everyone is hitting the front page and the first article. So as long as that's cached on a lot of servers, things will be fast. But in a multi-tenant application, everyone is looking at their own data. So if you want to cache all of that in memory, it might actually be too much to do that. Also, by the time a software as a service becomes successful, it probably solves some kind of hard problem, and that comes with a lot of complexity. So we're talking about scaling really complex data models. And usually there's also a mixture between very big and a lot of very small tenants that have different hardware requirements, and they pay different amounts of money as well, so you kind of need to adjust to that. But most workloads also have some redeeming quality, something that makes it a little bit easier to deal with. For multi-tenant apps, that's basically the fact that most of the operations, sometimes all of the operations, are scoped to a single tenant. And what that means is that software as a service is supremely suitable for sharding. As long as I put all of the data for a specific tenant on the same machine, all the operations for that tenant can be handled by that machine, and for a different tenant can be handled by a different machine. And there's actually many different ways to shard a multi-tenant app. The sort of most classical one, perhaps the most commonly used, I create a virtual machine per tenant. Like I can go to my cloud provider, use their managed Postgres service, or manage my own machines. But like if I have a product that with large tenants with, let's say, pricey contracts, that's can be an attractive thing to do. I get dedicated resources for every tenant. They're very well isolated from each other. If my application has some kind of SQL injection bug, then one tenant cannot get access to another tenant very easily. So it has a lot of benefits. But if I have millions of tenants, like this is a very bad idea to be managing millions of virtual machines and millions of Postgres servers. So there's these kind of steps down where the overhead per tenant goes down, and you can handle more tenants on the same amount of hardware, but you don't get as sort of comprehensive isolation benefits. So one example is there's the serverless system where you basically, a lot of Postgres servers share the same VM and they can resize a bit more dynamically. You could have a database per tenant and spread the databases across servers. You could have a schema per tenant, spread the schemas across servers. This is something Citus can do very nicely. Or you could have a row set per tenant where there's a shared set of tables and all the data is in that set of tables. And for each table, you have a tenant identifier column that shows you that that's the data for a particular tenant. And then Citus could make sure that all the data for the same tenant is in the same machine, such that even foreign keys and joins, they can all get handled by the same machine. So each of these can scale, but with some different characteristics. As I said, like if you have a really large number of tenants, millions, like it's best to go towards row set per tenant because there's basically no overhead per tenant. It's also great for administration, like you can share everything, the configs, the set of tables. If you add a column, you can do it at once for all the tenants. You can query across tenants, so that's nice. But if you have much smaller number of tenants and isolation is really important, and you need to be able to connect your database server to their network, for example, like those are very much more specific requirements, then maybe VM per tenant is more attractive, or one of the ones in between. Now, in each of these, if you have a large tenant, you can typically isolate it to its own machine. So they can all deal with a mixture of small and large tenants. So yeah, as I said, row set is the most efficient and VM is the most kind of coarse, but the most isolated, but also the most administrative overhead. And in between, there's good option as well. My personal favorite is the schema-based sharding in Citus, because there's not a lot of extra things you need to do to make it work. You just create a Postgres schema per tenant. You could do the same thing on Postgres. And then Citus can distribute those schemas across multiple nodes if you need to scale out. And scale out is a pretty good cure for these types of applications, because if you get into these spirals, for example, where auto vacuum doesn't keep up, you can simply add more auto vacuum processes by adding more machines. So another challenging type of application is time series. And particularly time series dashboards that have a lot of users and kind of show real-time information, maybe within a few minutes or sometimes seconds. And then there's this big stream of time series data, of observations, of events that tends to grow over time that you need to deal with and you need to do your analytics on. So this is challenging for a number of reasons. One is large and often growing data volume. You have a pretty short time to insights that you want, where maybe in less than 5 minutes from an event happening, you want to be able to show it on the dashboard, maybe in less than 1 minute. There can be many concurrent queries from different users, so you want to be able to handle those quickly and efficiently. And there's usually many dimensions for aggregation and filtering. Like if these are devices producing sensor data, there can be different types of sensor readings from different types of devices in different locations. The time is always a dimension, can be different time ranges, how much in an hour, how much in a day. And so that adds to the complexity. The redeeming quality is usually the queries are relatively simple aggregations and filters. And they're usually kind of predictable. They're just the things that the dashboard does to show charts. and the queries are mostly on recent data. But still, it's a difficult problem, and here it's much more important to have good data structures than to, for example, scale out. Those scale out can also help for very large scale scenarios. And one example data structure that's very common in this scenario is time partition table, where the new data goes into a recent partition, like today's partition, and then older partitions at some point get dropped. So we can very efficiently expire old data. And keeping the data partitioned in this way keeps the indexes smaller. It means we can very efficiently select the recent data, which is something we wanted. And it has a few other benefits. So Postgres can do this natively, and then there's a few tools to automate it. I mean, they all work pretty well. But you don't want to usually query this data directly if you have a dashboard with a lot of users, because there can be an unbounded amount of data here, and your aggregations can become these super large scans. You could try adding indexes, but you could still have pretty large scans, and every index makes your writes slower, and your writes might need to actually go faster over time. So a common strategy that people use is to pre-aggregate the data in the database. So you could do this manually, where you insert into a pre-aggregated table using insert select, or create a view, or you could use some tools. PGIVM is a very interesting tool that's being developed. There's some others. And the idea is that you kind of summarize your data in these tables, and the dashboard can query the summaries. It might still aggregate across multiple summaries, but it only has like a much smaller number of rows to retrieve, usually using an index. So that way you can handle more users. Now, one thing that can happen is that the insert selects that you do to maintain the views get slower over time because you have more data. So one thing you can do about that is to scale out. So this is something people commonly do using Citus, where you could distribute your source data across many nodes, distributed by some column like the event ID. Maybe there's a tenant ID column, maybe device ID. And then the insert select commands into the pre-aggregated tables will be parallelized across all the nodes and all the cores. So if they become too slow, you can add more nodes, and they become faster again. But you also need to make very careful decisions around what are my distribution columns. How can I get queries to go to one node and not to all the nodes, because I cannot handle a lot of queries that go to all the nodes. So it's still a tricky problem, and good data modeling is essential. There's nice infrastructure. With Postgres, you get a nice Swiss Army knife, but you have to figure out how to build it yourself to some extent, which views make sense for your application. One thing is that recently, vectorized query engines are becoming better at this use case, but we'll discuss those a little bit more in the next workload. So the final workload I'm going to talk about is business intelligence. And so this is where we collect data from across an organization, from vendors, from databases, from telemetry system, from our website, and put it all together, and then try to make data-driven decisions by analyzing it. And this data might be collected in a Postgres server or some other database. It might also, but very often nowadays, it's collected in data lakes. So these are essentially files in blob storage, Azure Blob Storage, or Amazon S3, that then you need to kind of go through to find the answers to your questions. So a challenge here is that the data volumes can be enormous, like many petabytes for large enterprises. And the queries tend to be quite complex, and every day, there can be many different new queries that haven't been seen before. And then there's many different sources that you need to combine. You might need to transform, clean the data. So on the plus side, there's typically low concurrency, so not many queries at the same time. So I can dedicate all of the resources of my machines to answering the queries. Now, again, good data structures and efficient use of parallelism are quite essential here. Now, the data structure that's most commonly used for this type of scenario is columnar storage. So the idea with columnar storage is that instead of storing the data row by row by row, which is what most databases like Postgres do, is you take a chunk of, let's say, 1,000 rows, and then you take 1,000 values from the first column, 1,000 values from the second column, and that they're stored adjacently. And when you take values from the same column, there's often a lot of similarity between the values, and so it compresses very well. You can also, with this storage layout, do very fast projections where maybe you only need a few columns from your table for your analytical query. That's quite common, and maybe there's hundreds of columns. So it's much faster if you know, oh, these columns are stored here, and I only need to read that part of the table. And finally, perhaps the most important benefit is you can do vectorized execution, which is the idea that once you have this vector of 1,000 values, if you need to do a filter, a where clause, you can first just scan through 1,000 values with a simple for loop, which has no other overhead of it's not doing a lot of function calls. Because if you process the data row by row, you usually have a lot of back and forth with a lot of function calls. And also, when you do those simple loops, compilers and CPU can usually optimize that using special instructions to go much faster. And this can really be 10 or sometimes 100 times faster than Postgres doing the same query, even on the same hardware. And so there is an increasing amount of choice in terms of columnar storage for Postgres. The oldest is Citus columnar. So this is derived from CStore FDW, which is, I guess, really the oldest. And this only does the compression and faster projection, and it stores things just in Postgres. And Hydra is derived from Citus columnar, but adds some vectorization. Timescale has a different approach, but also stores data in Postgres tables itself, Postgres buffers, and it does some vectorization. More recently, there's PG Analytics and Crunchy Bridge for Analytics, which is what I've been working on. And they basically take part of the query execution and give it to a separate executor, Data Fusion in case of PG Analytics and DuckDB in case of Crunchy Bridge. And then they work on Parquet data, and in Crunchy Bridge case, that is in object storage in S3. And object storage is also an important aspect of scaling these types of workloads, because the traditional way data warehouse, where I collect everything in one database, those servers are usually very busy just kind of loading all the incoming data and extracting large amounts of data for other applications, doing all the data transformations that need to happen, and then also doing the queries. But if you move the data into object stores, the big advantage is that a lot of different applications can access them at the same time, can write to it without going through the database server. So now the load and extract and part of the transform can all happen outside of Postgres, outside of the database server, and that can just focus on queries, which is actually quite performant. So in summary, the state of the art for business intelligence is really columnar data formats with object storage and vectorized execution. And there's many analytic stores that use this. You may have heard the names of like Snowflakes and Databricks and BigQuery and Redshift, Athena, like ClickHouse. And so they all kind of follow this approach. But Postgres is now starting to get there as well by taking these sort of third-party open source query engines and embedding them via extensions. So that will make it a lot more suitable for business intelligence and potentially also helps with some of the real-time analytics use cases. So in summary, like we've looked at 3 workload patterns that can become data intensive and kind of different ways to scale them, at least at a high level. So for multi-tenant apps, sharding is generally a good way to go. It can help you escape a lot of performance problems, like your system's under pressure, just add more capacity. That works very well for multi-tenant apps. And for big tenants, you can isolate them to their own nodes in any of the approaches. You mostly need to pick which high-level approach do I want to take, how much like customization per tenant do I need, or how much isolation do I need, or how many tenants will I have. For time series dashboards, partitioning is essential. Pre-aggregation is actually also essential. You can do sharding here as well, but it's not as clear-cut as for multi-tenant apps. You need to think a bit about what are the implications on my data model. So it's always a tough exercise to build a real-time analytics dashboard with a lot of users. And then finally, for business intelligence, like the columnar storage and vectorized execution, even on a single server, actually go a really long way, especially if you're using it in combination with object storage, such that data loading and extracting kind of happens outside of the database. I've personally worked on especially the first two problems a lot over the last 10 years with Citus, and now I'm more focused on the third problem, which is also very interesting. And eventually, Postgres is going to get better at all of these. Okay, thank you very much. I enjoyed giving a talk at my my first Posette or my third CitusCon, and hope to see you at the next one.
Right, super. The third talk at the third conference. That's pretty cool.
He is such a good explainer. I think that's why Marco makes such a good technical lead, right? It's not just his ability to code and architect solutions, but just to teach people. It's kind of cool. Let's see. He mentioned Citus a bunch, so I dropped a note in the Discord chat, which I will mention here, that the Citus open source repo on GitHub hit 10K stars yesterday. For those of you who keep an eye on proxy metrics like that. Also, Marco talked quite a bit about partitioning in his talk as well. And I just wanted to flag, according to Daniel Gustafson, we have partitioned the schedule partitions for this event to make sure that we have discussions of partitioning in almost every live stream. Later today, the last talk of the today by Ryan Boos is titled Postgres Partitioning, Slicing, and Dicing for Performance and Easier Maintenance. So if that's something you want to spin up on and learn more about, Ryan's talk would be good. And then also in live stream 4, so this time zone tomorrow, Derek Van Veen of Adyen is giving a talk about partitioning your Postgres tables for, bing, 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 20x better performance.
Was that sound effect in his title too?
No, I was just trying to emulate something that he might do. I do my best. It is the middle of the night for me, so you got to cut me some slack.
Fair enough, yeah.
And just a reminder that all these talks have been pre-recorded. So what that means is the speakers are available live on the virtual hallway track on Discord while their talks are being live streamed. So it's your chance to ask questions or just interact or whatever. So go to aka.ms open source Discord and you go to the Posette Conf channel when you get there. I know it's a little bit tiring, Flora, because we keep repeating that, but we know people drop in and they leave and they come. And so
100%.
Also swag. So if you're interested in some of the sticker packs, you can go to aka.ms Posette swag and let me pop up a banner that I've got. I think you can use these codes that are showing Posette stickers and then a bunch of numbers on that form in order to get those sticker packs. And then if you want the socks, those are in very limited supply, but apparently people who are super active with the Q&A on the Discord will get invited to submit and try to get their hands on those too. There. And then I think it's time to introduce our next speaker.
Absolutely. And Silvano is already interacting in the Discord chat. We were just discussing if there is still time to make a cappuccino or not, because of course, being Italian, he's the subject matter expert on whether or not I can still have a cappuccino at this advanced time in the morning. Silvano is a program manager in the Azure Database for Postgres team at Microsoft, has over 25 years of experience in application development and database design, troubleshooting, and performance tuning, specialized in data access, libraries, query optimization, and distributed systems design. And after working on a different database product for decades, Silvana saved the best, or Postgres, for last. Those are his words, though, because I bet that he has many more years to give to the community. And as a fun side note, he even presented about Postgres at the SQL Server conference once. So that's brave. Silvana loves hiking, no doubt, while he's thinking about high availability and disaster recovery in Postgres, which we'll hear more about in his talk. Can't wait.
Hello, my name is Silvano Coriani. I work in the Azure Postgres team, and I'm here to present about high availability and disaster recovery for Azure Database for Postgres. This is an interesting topic, especially if you need or want to set up Postgres in a mission-critical deployment and setups and maintain your business ability to respond to your needs while there's a disaster or anything else impacting your system. Okay, so this is the fundamental problem that we try to solve, right? Business continuity, which means maintaining your organization's ability to perform its functions or quickly resume after a big disruption that can be hardware or software failure, natural disaster, anything which is trying to basically keep your business down. And when we talk about business continuity, there are two key metrics. One is recovery time and objective, and one is a recovery point objective. And we are basically defining those metrics based on fundamental events that can impact your system. The first one is when we basically took the last good backup of our business data, and when the system becomes unavailable, right? And next one is when the system goes back online and fully recovered. And we are basically referring to recovery time interval or objective, the interval between when the system goes down and when it's fully recovered, while the recovery point objective is between the last consistent backup or data point that we have in the system and when the system basically goes off. And in most cases, there's a chance that this is also represented the interval of data, that the portion of the data that you can lose if basically the system was not saving this consistently over time. Redundancy, so creating additional copies or additional systems is the way to actually enable high availability scenarios or disaster recovery. And high availability, generally speaking, we refer as a single physical site where we are basically duplicating the data and keeping them in sync through replication, usually physical replication and synchronous one. And but this basically is the fastest and with the setup with the smallest recovery time and recovery point objectives possible. Although it's typically quite expensive because we are fully duplicating the system. Disaster recovery enters when we want to protect from losing an entire site, right? That can be, highly available, but if we lose both copies, again, we cannot process any data anymore. So with disaster recovery, we generally have a secondary site with, again, a copy of our system, which is in sync, but generally speaking is asynchronous due to the additional latency that is basically involved in transferring data from the primary to the secondary. So in this setup, we are actually increasing our PO and RTO and still have a pretty expensive setup because typically this is paired with the high availability on the local site that we were referring to. A third cheaper option for recovering a system can be relying on just pure backups, right? And backups can be shipped from a primary location to a secondary location. And in that secondary location, we don't have any system active up and running, but we just recreate the system all the time. In this case, we have very high RTOs. We can have potentially high RPOs as well, but at a very cheaper price. So in Azure, thanks to the architecture that we have in our data centers and regions, we can accommodate actually all three examples that we were referring to: high availability with different locations within the single region, with low latency for maintaining local HA. We can have parent regions that can where data can be replicated asynchronously between regions while still maintaining data residency requirements, like for example within the EU or within the US and such. And we can ship backups between parent regions in a synchronous manner, and in most cases this actually is pretty automatic based on Azure storage. Availability zones are another super important aspect in creating these highly available solutions. The combination of availability zones and parent regions is giving us the ability to set up mission-critical applications and tolerate, for example, losing an entire data center and still keep our business up and running within the other two availability zones in a system. Right, and we can go up to 4 nines easily with the combination of hardware and software. So for Azure Database for Postgres specifically, this is the combination of the two technologies that we were referring to. So we can have our local kind of primary instance of Postgres sitting in a given availability zone in our region 1, which gets synchronously replicated to a secondary copy or hot standby server within the same region in a different availability zone. So we can tolerate losing an entire data center here and basically moving to the secondary zone without any particular impact because we are synchronous, so we don't have any data loss in this regard. And we see also another region here where we are asynchronously replicating data, leveraging multi-region read replicas. And in this case, we have a synchronous replication because of the additional latency, but we can then promote potentially our secondary copy here to a new primary in case we are actually losing the entire region over here. And so the combination, and last but not least, in Azure Database for Postgres, we are storing our backups into geo-redundant storage, which gets automatically and transparently replicated to a parent region so that we can restore our systems in that region even kind of later on to recover from bigger disaster. So if we start from a flexible server architecture here, this is a deployment without any HA. So we are basically deploying our Postgres instance in a Linux VM using managed disks to store data and logs. This system gets backed up in Azure redundant storage where essentially data will be available on different availability zones within the same region, right? We want to make this locally highly available. So the next step would be to actually enable high availability on this primary instance that we have. And this will automatically set up a standby server in the same zone or in a different zone. We are selecting a different zone here to rely basically on availability zones for full data center loss. And we have a synchronous replication within the two to make sure that basically there is a minimal or even zero data loss between our primary and our secondary. And most importantly, we can transparently and automatically failing over in case there's a problem on our primary to our standby server here, as we will see in a second in our demo. So this is pretty simple, but very efficient and highly available setup that we can enable with few steps in our deployments. Okay, let's take a quick look at our demo scenario here. In the first part, we are going to demonstrate local high availability. We have our region 1 here and our primary instance, which is sitting in availability zone 1. And we have a hot standby server in different availability zone in our setup, and we have synchronous replication between the two. So what we will demonstrate here is how we can fail over almost transparently between the primary and the secondary, and we will see how the application will react to this. Let's take a quick look at how our environment looks like in the Azure portal. So we have two instances of flexible server in this particular setup. One is located in Italy North, and the second is in Switzerland North, representing the two regions that we have deployed our resources in. If we look at the primary one, we can see that right now is in availability zone 1 within our Italy North region. And if we take a look at the high availability blade here on the left, we have confirmed that we have high availability enabled for this one, and that high availability mode is zone redundant, so that a standby server is available in a different zone compared to the primary, that the availability status is healthy, and these are the primary and the standby availability zone positions, right? At the same time, we have a secondary instance here, which is in a different location. So we can see, this is the secondary, and the way we actually have set up this is here in the same blade of the primary, we can see replication blade, and in the replication blade, we see that we have actually our primary and our secondary replica that are part of the same replica set, and in the two different regions. And we can see some additional information, like as an example here, the read replica lag between the two, and the fact that both of them have Microsoft Entra or Azure Active Directory authentication enabled for the two. We also have created here the virtual endpoint. Virtual endpoint is a single connection point from our applications that can switch then between primary and secondary in a kind of transparent manner without the need for changing the connection string the moment we will fail over from our primary to our regional replica in a different location. Okay, but it's very unlikely that in production we are creating our environments here in the portal. So let's take a look at how we can do this through coding and scripting. We are using here Azure CLI commandlets to set up our environment. We can see first server creation here, first instance creation. This is our primary actually, and we have high availability attribute specified here as zone redundant. Our primary is in zone 1, while our standby zone is number 3. Right, with this command, we are actually setting up our primary instance with high availability enabled within our single region. We are here enabling Azure Active Directory or Entra authentication, so we don't need to use password anymore. In fact, we have disabled password authentication for this particular instance. And we are here creating the new replica in a different geography, in a different region. Right, so we can see, the command is replica create. We are creating the secondary replica here with the source server specified as the primary, and we are placing this in zone 3 of the new region. And we are also creating here the new virtual endpoint, which is basically abstracting primary and secondary behind a single virtual endpoint name here. Okay, so this is for scripting and imperative creations. We also have in Azure a lot of higher level languages. We have this bicep file here. Bicep is a domain specific language where we can describe our deployments, we can see here we have our primary, our secondary, and all the other components of our deployment defined in this file. What Bicep can provide, it can provide a lot of tooling. For example, let's take a look at the Bicep visualizer, where, for example, we have a graphical representation of our deployments. Here is our primary instance, and here is our secondary instance with all the other firewall rules and administrator definitions and such. So that from here we can actually even deploy our Bicep file and get everything up and running in a true infrastructure as a code environment. Actually, Bicep can generate both Azure ARM resource management templates, but can also generate, for example, Terraform scripts, right? So we can set up our environments in a fully kind of automated manner here. Okay, so once we deploy the environment, we have a simple Python app here, which is opening up a connection using, again, Entra ID as an authentication mechanism. And then we are pinging every second with a very simple query, querying some system tables here to print out the primary IP of our primary server, the standby server name and such. And what we want to do is basically in between executing this server restart operation, which is simulating a failover. It's a forced failover actually between the primary and the hot standby server, and look at how the application is behaving to that. So we already have the application running here. As you can see, it's printing out my user, the primary IP of the primary. So it's 0.6 and the standby name. And we see we are hitting this every second, and in between we are executing this hot standby server test, which is forcing failover between the primary and the hot standby. In a second here, we will see the operation restart. Here we go. And here we go. We are starting the failover, right? So we are losing the connection to the primary. And we will see that in few seconds, usually is taking around 30 seconds to automate this. We should see the connection restarted. Let's wait just a few seconds again. And around the half of the minutes here, we should see the new connections coming in. Here we go. Now we have the connection to the new primary, which is 0.4 as an IP address and has a new standby name here, which is now up and running. So we have successfully failed over between the primary and the hot standby with around 30 seconds of downtime from an application perspective. So local HA, it's easy, relatively easy to implement, and pretty straightforward in terms of failing over from our primary to the secondary with practically zero RPO and very low RTO. We are seeing those 30 seconds around of application downtime. So let's switch now to the geo replica setup where we can protect our systems from losing an entire region. And we will do that by creating a brand new replica in a different region. This is going to be asynchronously created because, cross-region communications cannot be synchronous. Otherwise, the latency will actually impact the performance of our primary copy here. And then we can use those secondary copies in a different regions for many scenarios, like, for example, offloading read operation or, reporting whatsoever, but also from a disaster recovery perspective, with the ability to fail over our primary region to the secondary region and keep our business up and running, even when we are losing an entire region in our system. So what we will see now is effectively how we can easily set up this. Okay, let's look at the second part of the demo here. in addition to the local kind of synchronous replication that we had to provide a high availability at region 1, we are adding now a new read replica in a different region to enable multi-region disaster recovery scenarios. And between our region 1 and region 2, we have our synchronous replication stream, and we can demonstrate also how we can fail over from region 1 to region 2 in case we have a regional failure here, and potentially fail back the moment we have fixed our region 1. Okay, let's take a look at our demo environment here using Azure Data Studio right now to connect to both our primary, which is our writer version of the virtual endpoint, and to our replica using our reader version of the endpoint. Let's make sure that we are actually connected with the right endpoint. So I'm connecting to the writer with this one. And I have a second window here where I want to make sure I'm connected to my reader and to the same test database that I'm using. Okay, so if I query my IP here for the primary is 1047.04, and we can still check our application slots. We have two because, again, one is for the hot standby server, synchronous replication on the same region, and this is one, the GeoAsync replica is the replication slot for our read replica in a different region. So we can do a quick check and try to create a test table in our primary here, inserting a row. And if we go to the replica, we can see that data is already there. Actually, as we're connected to the replica, we can query our system tables views here and see that our replica here is a different, of course, IP address is 1027.04. Is the primary info for this replica are the ones that we already know. This is actually in a replica state is synced, and we have a certain lag here, which is of course changing. And actually, lag doesn't make a lot of sense when primary and secondary are fully synced. It's when they are not synced that lag is an important indication for us. But it's generally with below few seconds. Okay, so let's see now. So we have the two primary and secondary replica running, and let's take a look at a slightly different version of our test application here in Python. So this time we are connecting to both primary and replica using the same app, because we want to again extract system info from both sides, right? But other than that, again, we are pinging every second our backend servers on both ends and print out and make sure that things are still working. Okay, so while we have our application up and running here, pinging both our primary and our replica to get the system information, we will see now what is the workflow that we go through for this demonstration. Essentially, the first operation is failing over from our primary to our geo read replica, right, which is a different command than the previous one. We can see that now we are promoting the replica, which is our secondary here, to switch over as a new primary, and we are forcing this operation right now as we move. So as we force this, it is going to ask us if we are very sure to do this, because this is a pretty painful operation. Pull up, and then the forcing failover between primary and secondary will start. And we can see that the app is now, it has now started to experience some connectivity issues, right? At what's going on at the portal level here, we should see here in the replication page that now the secondary is actually the new primary, while the primary is replica. And of course, the status is still updating between the two. So what we see here is that for the duration of this first phase, we have in our virtual endpoint, both for the reader and the writer, we are pointing to the secondary until the old primary will be in the state of being the new read replica, right? And along the way, we can see that the application can still connect to the new primary, which is the 1027.04, right? And waiting for again the new the old primary to become the new replica, but the application itself is definitely can be up and running. It can start executing queries against the new primary, which is the old secondary actually. And now, after another while, we now have the full setup in place with the secondary, which is our new primary, and it's the writer, and the old primary, which is now the replica, is also pictured here in the second list, and the two are fully in place. And if we look at the application is again query both primary and secondary with two different IP addresses here. We can see also that the operation has finished here, right? So now it's time to actually revert back that operation. We have fixed our initial kind of primary region, and now we want to switch back effectively from the new primary, which is the secondary region, back to the previous one. So we can start again this operation, and we can take a look at here our application. Here we go. Now application has interrupted the connection for quite some time. We can see that in just a few seconds we should be connected to, here we go, to the application back again, right? And if we look at our portal, now we should see that the new operation is in place, right? So the primary now is effectively in the primary role here, right? And while the secondary is still updating its role back to the replica, we have the virtual endpoints right now that are pointing again to the same new kind of primary server, and for the duration of the operation on the secondary, which will bring back the secondary as the read replica role. And now we have the application back in place with our primary and secondary servers up and running with the respective IPs here, 1047.04 and 1027.04, and the replication stream are back in place. Yeah, and that's basically the demonstration that we can fail over from our region 1 to a secondary region and fail back, and the application will get minimal disruption between the two. Okay, so both local HA and geo redundant setups, we are seeing how to create the two setups very easily in Azure Database for Postgres. Postgres, last but not least, with backups, we can enable geo redundant backups, and with basically click of a button here or with a specific API command in CLI and such, and we will automatically basically transfer our backups from our primary region to a geo-paired region, where at the opposite we can actually restore and take those paired backups and create a brand new copy of our entire system in a different region in case we completely lost the previous one. Right, so very simple and very effective, but typically both RPO and RTO of this solution are going to be much higher than the previous ones. Okay, so you can get a lot more resources. It's following the links here on the page. You can go to the homepage of the Azure Database for Postgres product, go to the doc, or to the various social media pages that are talking about our service. And also ask questions directly to the PostgreSQL team in Azure if you like. Or there's also a feedback page where you can, again, ask for new features, new capabilities that we will introduce in the service moving forward. Okay, so thanks a lot for your time. Hopefully today you're seeing how Azure Database for Postgres can let you create mission-critical deployments with relatively kind of simple approach, but very straightforward and very durable characteristics for you.
Thank you to Silvano Coriani. Wow. He really nailed, I think, the approach of giving a talk about a managed service offering and doing it in a way that's just super useful, actionable, explaining the concepts, helping people understand. I suspect there's a lot of Azure Database for Postgres users who are going to benefit from it. And he wasn't pushing anything. He was just explaining. It was great.
No, absolutely. And I think Microsoft's offering for Postgres and its involvement in the larger open source ecosystem has been just so fantastic. I absolutely loved yesterday's keynote by Charles as well, sort of explaining, like where all Microsoft got involved and contributed to Postgres upstream as well. So it's so, I'm always so grateful to see like all of the places that they or you contribute. I remember my first meetup that I ran when I was still at Microsoft was the first time that I really got in touch with the Postgres community as well. And one of the speakers was actually one of the previous speakers that we had on, Marco. And it was a great introduction into the Postgres community, better than I had before, of course.
It was either Marco Slot or Jose Miguel who was like, you have to meet Flor Drees. You have to meet Flor Drees. And I'm so glad for that introduction. Okay.
The rest is history.
History. So if you are just joining and you're trying to catch up on logistics or announcements, I'm going to pop up some codes for swag. If you're interested in our sticker packs, you can go to ak.ms-posette swag and enter the codes that I'm showing on screen. And there's a couple of sticker sheets and a new sticker for the podcast that I host of the new name that we'll be renaming to next month. So feel free to go there and check that out. And then also, because Silvano just gave a talk about HANDR in Azure Database for Postgres, it seemed appropriate to pop this Cloud Skills Challenge up there. We have a whole team dedicated. The team is called Microsoft Learn, and they create these learning modules step by step to help people spin up on a particular part of the tech stack. And so these two Cloud Skills Challenges are both geared to Postgres on Azure. You can do one, you can do the other, you can do both. And you can register at aka.ms/PosetteCSC if you want to be entered for a chance to win either that hoodie or t-shirt. So for people who are looking for swag-related clothing, you've got till June 24th to do that. What is next on our agenda? Oh, we have a new speaker to introduce. Chris Ellis is just one of my favorite people on the planet. He is a self-described computing and electronics geek who loves working with open source. He's based in the UK, head of technology at a company called Next Team. And I think of Chris as an expert Postgres user who has so many tips and tricks up his sleeve and generously spends time explaining those best practices and those tips to people at conferences, which is how I met Chris. And in addition to all the work that he does with Postgres and with customers, he sometimes gets bored. And when he gets bored, he likes to build things with electronics. And I don't know if you can see this on screen, but this is an electronic elephant that Chris gifted to me at PG Day Paris earlier this year. So, and I think, I know he gave a lightning talk about how and why he built these beautiful things. So, Flora,
I just posted it in Discord. I think it's a great lightning talk, and it's such a fun little gadget. I always get so many positive comments whenever I wear it. So yeah,
it's a nice piece of jewelry. Okay, so Chris's talk today here at Posette is titled "Even JSONB in Postgres Needs Schemas." Let's see what he has to say.
Okay, so I'm Chris Ellis. I'm kind of head of technology here at Next Team, and at Posette 2024, I'm going to be talking about JSONB with Postgres still needs some form of schemas, right? And this is a talk very much about dealing with those kind of situations where you don't really know what data you're storing all the time, or you're just dealing with kind of quite complex data structures that you don't really want to just map into tables. And it's going to explore and look at just the basics of Postgres JSON support, and then how we can kind of use that to actually control the kind of data we're storing in our database. So to avoid those kind of like spaghetti data situations that it's all too easy to get into when you're dealing with kind of unstructured data. And we're just going to talk through that, so, you know, some pure SQL, and then look at an extension that can kind of help people out as well. And it's very much about those times where you just want to kind of ensure the integrity of your kind of database. So first off, a little bit about me. So I'm Chris. I'm kind of based in the UK in London, and I tend to go around calling myself a bit of an IT jack of all trades. I've kind of pretty much can do everything from building hardware and designing hardware up to kind of designing and building front ends, although not necessarily the most pretty. But I obviously spend most of my time kind of dealing with back-end engineering and databases. And I've been using Postgres for quite a while now, for about 18 odd years. And I've worked on a whole range of kind of projects, from kind of just simple website searches to also kind of smart energy kind of IoT type applications where we had a multi-terabyte database processing kind of lots of different data reads and kind of all lots of fun processing. And also kind of like just some simple small applications such as like booking and subscriptions management platforms. So a huge range of kind of different things. And this talk, like a lot of I tend to do, is all based on kind of my experience and kind of what we kind of have run into or what problems we wanted to solve. And this project very much directly is actually related to some problems I've kind of been dealing with in a very current project, and some discussions we had as a team about like how we could try and maybe improve this. And one of the kind of things I tend to find often we have to do in databases is deal with those situations where we've got either quite complicated data structures that we need to store, and often it doesn't necessarily make sense to map all of those into individual tables and as relations, right? Sometimes you just don't have the development time to do that. Sometimes it's just way more complicated than it needs to be. And that's where we had things pop up in the past, you know, like a bit like the entity attribute value model, especially for dealing with those kind of times where you've just got to store data that you don't know about, and you don't know the shape of it in advance, and you don't know what it is. So there's a whole bunch of different use cases where we're going to have to store kind of data. And let's be honest, these days, JSON has become kind of pretty much the king of how we handle and interchange kind of what we might call, say, loosely structured data. Obviously, you know, definitely replaced XML in that regard. But I think a key question here is, well, is Postgres the right tool for this job? And to my mind, of course it is. But, you know, we could have maybe just stored some of this in a file, or maybe we could have put it in MongoDB. But really, what you tend to find in these situations is you want to tie up the data between your main kind of relations and then this kind of data that's a bit on the side that maybe you only need it because a customer needs to store some custom metadata against certain records of your core data set. And you don't necessarily need to use this all the time, but often when you want to use it with the data that you've already got and you've structured well in a nice relational way. And this is where Postgres and its kind of JSON support can be a huge advantage for dealing with these kind of like more modern hybrid data models where we want to deal with these different types of data all in one place. And, you know, actually in Postgres, like how we store and deal with this is just as simple as a data type. You know, Postgres has completely pluggable data type system available, and we have a data type called JSON, and we also have a data type called JSONB. So the JSON data type is effectively just storing JSON data as text in Postgres, but with the added layer of it being validated as an actual valid JSON document. JSONB is a bit more complicated and doing a lot more processing. We're actually storing a complete binary representation of that kind of JSON document inside Postgres internally. So again, we're doing a lot of kind of processing here. You know, it has to be a valid JSON document because we have to have parsed it and split it all into its underlying tokens, stored it in our kind of binary format internally, and kind of all of that kind of jazz. So with JSONB, we do get situations where like things like object property orders can change a little bit because they're not, you know, guaranteed. They get normalized and all that kind of stuff. But Postgres also doesn't just have these as basic data types. We've got a whole bunch of support framework around it. We've got a whole bunch of functions that can work with these data types, and we have a whole bunch of operators that can work with these data types too. So we have operators to go and fetch properties. We have functions to go and build objects and inspect objects and all that kind of stuff. And we'll go through a few of them briefly here to kind of get a bit of an understanding of what we can do. and then how we can go about kind of controlling those data that we're loading. So we've got to start off with putting that data in. And to do that, right, it's just a straightforward insert command, right? All we're going to do is just cast the kind of text into a JSONB data type and insert that. And this is also where Postgres's kind of dollar quoting format is super handy at being able to handle, especially multi-line kind of JSON documents. And you don't have to deal with kind of quoting too much. You know, you can also put a word between the two dollar symbols to make sure that you don't match it $$ inside the document, etc. But, you know, inserting this data is just as simple as basic insert statement. But now we want to actually start like using this in our application. Well, then the really basic thing we want to do is probably just pull a couple of values out of that kind of underlying document. So we got two kind of like arrow style operators here that let us kind of go and fetch a property from a document. So in these two situations, we got the double-headed arrow here, which is going to fetch the property PLN code from our kind of column. So it's obviously going to fetch that kind of property from the root kind of object of that document. And we're going to actually, in that particular operator, we'll actually return the result as a Postgres text type. So that's very handy if you would then want to pass it into other Postgres functions. The second form of this operator actually returns the property value as a JSONB type or a JSON type. So that actually allows us then to chain these kind of operators together if we want to drill through kind of a nested layer of things. So for example, if we wanted to access the width property of the dims property here, you know, we can just do another kind of arrow operator. And that's kind of very handy. We also actually have built-in operators and functions to deal with complete path lookups if we need. But this is just the basics, right? And this is kind of doesn't just have to be for usage in select lists. So we can also actually do this in the kind of where clause. So we can actually kind of pull a property out and then match on it, just as we could kind of any kind of Postgres expression or function or operator. And this lets us kind of just do that kind of very basic predicate. Obviously, this particular instance here, like we could maybe kind of speed this up by using like an expression index. But if we want to actually be able to look up random properties, we kind of have to do things a little bit differently. But Postgres' support here is, again, really good. And we can actually create an index on a JSONB value. So we can actually create a GIN index on a JSONB column. And that's going to then let us search by arbitrary properties, especially within the root of that object, for when we want to search. So if we kind of, our use case needs that we need to be able to look up particular property and value pairs from this kind of document in a performant way, then actually JSONB is kind of great for this, coupled with the GIN index. We have to use a slightly different operator here to query it, right? So we can't just use the same kind of arrow style in equals because that can't be pushed down to the index. But we can use a different operator here, which is this kind of at arrow thing, which is effectively what we'd call a contains operator. And if you've ever played with Postgres arrays, then you'll have noticed this operator is kind of the same there, where we can kind of check if two arrays contain each other, etc. And we can use this here to say, effectively, does my kind of JSON document that I've got in my column contain the property CRM code and the value CRM114? And the great thing here is, and we can check this by looking at an explain plan, it's going to go and hit that GIN index. It's going to search that GIN index, and then it's going to do a quick recheck against the heap because GIN indexes are lossy and all that kind of stuff. But this is kind of super powerful. You know, we now actually have a situation where we can just store kind of arbitrary data and we can query on it. So if we have a simple use case where we need to let our customers who are consuming our APIs to store their own reference data against what we've kind of stored in our database, we can really easily achieve this with JSON and JSONB, and we can still do fast lookups. So that's kind of one of the things we were doing in a recent application. But the downside to this is kind of letting your customers or letting your users store arbitrary JSON documents into your database. Things can go wrong quite quickly. And, you know, it's very easy to build that kind of tangled mess of wires with you don't really know what's in your kind of database anymore. And, you know, definitely worked on some other kind of key value store databases where that's been a real problem. Nobody validated anything before they put it in. And not everybody actually does the validation in their application layer that you can necessarily trust. So I'm always a big fan of making sure that our database enforces integrity as well. So, you know, like we can trip ourselves up here by this insert statement will completely validly run, right? We can insert an array, we can insert a number. Even more fun is we can insert a JSON null, which we have to remember is not the same as an SQL null. They are two sort of different things, with the SQL's love of kind of tri-state logic. But that's not necessarily what we want to use and store. And at the end of the day, our kind of access operators are not going to blow up or anything here, right? They're not going to error, but they're not going to do what we want. And errors might just be a bit more subtle, right? It could be that we mistyped the name of a property, could be that we accidentally nested that kind of object twice, or maybe we accidentally wrapped it in an array, right? These are much more subtle and would be very easy for you to kind of introduce in your application layer. And without being able to enforce just even some basic shape and properties of your data in your database, it's going to introduce bugs further down the line. And I think all of us who work in kind of databases, we kind of like order. And I don't just mean order by here, right? We like data integrity. We have foreign keys for a reason. We like to use foreign keys for a reason. We like to use not null constraints. We like to use primary keys, right? All of this helps us as a whole system to enforce the value of our data and usage of our data and reduce maintenance burden as we go across the life of our project. So with that in mind, right, we've got this kind of trade-off of we want to be able to store unstructured data, but we also want to be able to kind of control at least some basic properties of that. So we can kind of do that. And the first part of that is we need to be able to make some basic assertions about that data, right? So a really basic thing we might want to at least assert is let's try and make sure we can only insert JSON objects into that column. So to be able to do that, we need to be able to find a way to specify, well, I've got this JSON value, what is it? And Postgres has a function called JSONB type of, and that lets you effectively do the equivalent of the JavaScript type of operator, which is going to tell you, like, well, in this particular instance, it's going to return the text array. If we pass it an object, it's going to return the text object. If we give it a string, it's going to return the text string. So we've now got a really fast way to know the kind of type of a kind of document or the root level of a document or a particular property that we pulled out. And so at least we can now go and clear up all that bad data of our database, right? We can just delete every row where the kind of type of that thing is not an object. But that's only so good at sorting out the mess we've got into, right? We want to actually make sure we don't get into that mess again. So this is where another very awesome power of Postgres comes in, which is check constraints. So check constraints let us apply an arbitrary predicate onto our kind of record and to ensure that it matches a whole bunch of criteria. Now, this is just specified as an SQL kind of predicate expression. So we can do kind of anything we can in Postgres with the kind of requirement that that kind of check is what we might call, say, idempotent, right? So if we give it the same value, it's always going to return the same result. So a key property of that is our expression that we specify on a check constraint cannot go and look at data in other tables. So we can look at pretty much all the columns of our row, and we can apply a whole bunch of functions to that, but we can't go and do a query on another like reference table, right? That's exactly what foreign keys are for. Check constraints aren't meant to do that. So now we've got these kind of two things, we can kind of construct that check constraint. And now if we try to insert our kind of bad data again, well, what's going to happen? Well, like everything, we're just going to get a constraint violation, right? So Postgres has gone, well, I've gone to run this check against your expression, against the value you're trying to insert, and it's violating a constraint. And obviously it tells us a little bit more detail than I've omitted on this slide, but it's going to throw an error if we try to stick bad data in now. So now we're in a situation where at least we can only store just basic object documents. But life is a bit more complicated than that, right? And the whole point of using a lot of this data is probably we want to store a bit more structure. So we want to deal with kind of a bit more complicated forms of JSON documents where we might have nested things, we might have arrays of stuff, and we want to be able to at least be able to assert a bit more detail here, right? So how can we go about that? So first off, let's move on our example and make our example a bit more complicated. And one of the things we've been doing on our project is dealing with kind of rules engines a fair bit. So we're storing kind of a JSON blob of all the rules into a table. And that's a basic structure of, we've got a bit of kind of metadata about the rule set, and then we have basically a list of rules that need to be applied. And what we want to do here is we want to be able to insert this into our table, but we want to make sure that we're always inserting a valid kind of rule set. So we want to make sure that it's got these kind of basic metadata properties. We want to make sure it's got an array and all the elements of that array are an object, and that each of those objects themselves have got different, the kind of 3 properties we need, like the fact, the operation, the value. Now, how can we go about that? Well, it's, we've learned enough already in this talk so far to be able to sit and say, well, I know I can assert the kind of type of the root of this document. I know how to go and look a property up in the document, so I can check that that's not null. I can check that that's defined. I can then check the type of that property. So we can go and call type of on the result of that property lookup, right? And remember I said the kind of single arrow operator here is going to return a JSONB type, right? So because we returned that JSONB type, we can then use the type of function, and that's going to tell us it's a string. So now it's very easy for us to make a whole bunch of very basic assertions as inside our check constraint about what we're inserting. But we can get a bit more complicated here, and we can use a bit more power of Postgres's JSON support and also just standard SQL here to do even more deeper checks. So we can take here a kind of, so Postgres has something called set returning functions. Now these are functions that will basically return and generate a table for us, right? Probably the one that everybody knows is the best is generate series. But for JSON, we have a whole bunch of these, and we have one called JSONB array elements. And that's going to take a JSON array value, and it's going to return a row for every element in that array. Now that's great in that that's kind of bridged that JSON array back into the kind of SQL world, where we can now use the power of SQL to process it. And we can use an aggregate function here. All we want to do at the end of the day is just compute that are every element of my array valid according to some kind of check. Well, Postgres has a whole bunch of very cool aggregate functions, and a very neat one that's probably not used very much is called bool and. And that's just going to give you a logical OR of every kind of value it sees. So if we just do a bool and aggregate of all of our kind of checks across each element, we just get a Boolean that says, well, this array is valid or it's not. And this is kind of exactly what we kind of want. So how can we go and plug this back into our check constraint? Well, if you remember earlier, I said, check constraints are a bit constrained about what they can execute. Well, we can't actually go and plug this in as a subquery of our check constraint. But this is where Postgres comes to our advantage again. We can define functions, and we can define them in just SQL as well. We don't actually need to use, say, a procedural language here. So we can actually just define a function which is going to check our data type, and it's going to return a Boolean that that's valid or not. Now, the only thing we have to pay a bit of attention to here is that we're going to mark this function as immutable. Now, this is because, right, it's always going to return the same result for the same input. And that's a kind of key property that we need for it to be callable from the check constraint. So all we need to do is create this function, apply our statement that's going to do our validation, right? So we're going to check that the document's an object. We're going to check our properties. We're then going to go and expand that array and check all the values there. And so how do we update our check constraint? Well, it's even simpler, right? We just specify in the check constraint, well, just use this function to check my result. And it's going to return a Boolean, right? That's all the expression for a check constraint needs to do is just return a Boolean result, right? So super simple, nice and clean, code looks really nice. This is all working really well. And now we can go a bit deeper, right? Now we've got all this basic stuff working. We can kind of like use that and accelerate and kind of cook on gas a little bit here, right? So we want to actually apply a bunch more checks to that kind of nested object in that array. Well, that's easy, right? We've already learned all the things we need to do. We just create a new function that's going to check that individual, that kind of child object. And it's going to check this an object. It's going to check it's got the properties we want. And again, right, we could specify if we had multiple nested levels, right, 3 or 4 levels deep, we can just define more functions to go deeper. And then we can just put this back together. And then rather than having to write a really complex check expression inside that bool and aggregate, we can just call the function we've created. So we have all the power from SQL and Postgres to be able to create these very simple composable validation functions and call them together, and to chain all of that together. But at the end of the day, I said this talk was about schemas, and I've not really talked about the obvious elephant in the room yet. And that would be JSON schema, right? We all know that there is a well-defined, especially if we spend time building REST APIs, we know that there is a kind of dedicated schema for JSON that also happens to specify itself in JSON. So we already have a way to declare the structure of JSON. Well, so here's a kind of brief example cut down for the slide, but we're going to just define declaratively the structure of that kind of example type that we previously wrote a function to validate. We can specify these basic things. So, we expect a property type string, we expect decisions, we can't expect that to be a type object and have other properties. We can specify that we want required properties. We can specify whether we allow additional properties or not. So we can kind of already specify all this. We already have a format to specify all of this. And we can make use of that in Postgres as well. And originally I thought first off, it wouldn't be too difficult to write an extension to do this. Well, it turns out somebody's beating me to that, Superbase no less. And there is actually an extension out there that you can go and download called pgJSON Schema. And that's going to let you use your JSON schema that you probably already have defined in your application to validate the data you're going to store in Postgres. So, simple case of install the extension. The extension is written in Rust, so it's maybe not always available on every kind of hosting provider, but you can kind of go and download it and install it. And then we can define check constraints just in the way of this, where we can specify that we're going to use the JSONB matches schema function. We're going to provide it the schema, and that's just as a JSON text blob. And then we're going to specify the value we want to validate, and it's going to, under the hood, go and do all that validation. It's basically a fairly thin wrapper on Rust's JSON schema validation framework. So this gives us a very kind of fast and easy way to be able to kind of validate, especially very complicated objects, at the trade-off of having to install an extension. And obviously the extension still works for standard JSON. So if we're not using JSONB, we can still call and use this kind of extension in that particular situation. Now, the only problem and downside here is that, as I said, we've had to install an extension that might not always be an option for us, which is why I think it's still kind of useful and valuable to talk through and build up some basic building blocks of how we can go and do this and solve this with pure SQL. And I'm kind of have a tool that's available on our website where you can actually give it a JSON schema and it will go and generate the kind of at least basic validation functions. So if you're in a situation where you don't actually want to install an extension, well, the other approach here is just generate the kind of SQL validation functions you might need from your JSON schema, and then we can load those into our schema and just use them as we would normally as anything else in Postgres. So please feel free to take a look and try it out. And with that, thank you very much for listening, and I hope you enjoy the rest of Posette.
Thank you very much, Chris Ellis. That was awesome.
Yes, I saw there was some chat in the Discord about potentially stealing Chris's slides for another talk. So I hope they're open source licensed.
Or permission is gained beforehand. All right, so that was awesome. And we're just going to keep this live stream going. If you are live posting about the event, be sure to use the PosetteConf hashtag when you take those screenshots and post them out there. And if you have feedback about Chris's talk or any of the speakers' talks that you've seen so far, you can just go ahead and submit a survey feedback on the talk using the QR code or the link showing in the bottom left, aka.ms/Posette survey talks. And you can just do that once per talk. And if you want to give feedback about the event, that's what the separate survey link is on the right-hand side. And that's for the organizers. So we know what we're doing well and what to do better for next year. Okay. We have another movie trailer to share. And this is about Livestream 4, which is happening this time of day tomorrow, correct? So in the EMEA-friendly time zones, and it's got a set of 10 different amazing talks. And this movie trailer will show us a few 20 seconds from each one of them. Are you ready?
I am.
Okay, let's do it.
My name is Thomas Monroe, and I'm going to be talking to you about the Postgres project, or PostgreSQL, where it came from, what sorts of things it does, how it is made today, who makes it, and a bit about how I myself got involved in it and how you might get involved in it if that's something that you're interested in, or if not, how you might use it.
If you're planning to partition more than a single table in your Postgres environment, this is the talk you have to see, because if you partition multiple tables, you have only one chance to do it right, and this talk gives you all the information you need to do to build a great environment, which is really fast forever and ever. So, welcome to Partition Your Tables for 20 times better performance.
So hi, my name is Tomáš Vondra. I do work for EDB. I'm a long-term contributor, developer, and also a committer. And I'm here to talk about performance cliffs, which is a performance issue affecting a lot of people that may not be aware of that. I'm going to explain how the performance issue actually happens and why.
I am a senior software engineer in a team which is responsible for internal database as a service platform. And today I want to share with you our findings and experience when adopting and supporting our internal CDC solution based on logical decoding.
Hello everyone, my name is Hans-Jürgen Schönig. I'm the CEO of Cybertech, and hopefully for this year's conference I've prepared some really interesting performance stuff you've never seen before. So if you're seriously interested in performance, check out this talk and learn something that is way beyond just adjusting some Postgres configuration parameters. Have fun.
Hi everybody, I'm Luigi Nardi. I'm the founder and CEO of DBTune. Very excited to be here at Posette. Today we'll be talking about auto-tuning Postgres. So if you are interested in learning about the configuration of your Postgres instance to achieve high performance, this may be the talk for you.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and I'm speaking at Posette about why you don't need a database backup policy. You're probably wondering why, as a DBA of over 20 years, I'd be telling you that you don't need a database backup policy. So hopefully this talk's going to be interesting to anybody who has data that they care about and want to keep safe.
Hello everyone, my name is Taras Kleban. I am Senior Solution Architect at Microsoft, and today I want to present a solution which we created for a tight NATO hackathon to advance drug search, and also show how we utilize for this Postgres and the Azure AI extension.
Hello everybody, my name is Federico Campoli. I am a freelance PostgreSQL consultant, and today I will talk about PostgreSQL running on top of ZFS, a powerful file system, but with a bad reputation. So if you are a sysadmin or DBA and you are searching for an alternative for performance and scaling up your system, you may be interested in my presentation. Thank you.
Hi everyone, I'm Paolo Mecchiore. I'm the CTO of 20Tab, and I'm a member of the Django Software Foundation. I use Django since a long time to do my web project, and today we'll see together how to integrate semantic search using Postgres and pgVector.
Wow, that trailer had everything. It had comedy, action, a love story. I love some of the ways that people tease their talks, like performance like you've never seen before. So really great these.
Absolutely. So just a little bit of enticement to tune in here to Livestream for tomorrow. But now I think drum roll is needed. It's time for us to introduce our next speaker.
Yes, our next speaker is Boriss, who is a solution architect at EDB, but rather describes himself as a holistic system software engineer. He's a free software user and also a headbanger, which probably will make sense once he starts his story. Boriss has a PhD researching distributed self-managing systems, and he has been working with Postgres since version 9.1, which, fun fact, if you watched the stream yesterday, is also when the idea of extensions got introduced. David Wheeler mentioned that in his talk. In 2018, he started the Postgres user group in Belgium. That is Boriss, not David. and he talked on the podcast that you do, Claire, about why to give talks at Postgres conferences with Alvaro. So that was a really, really great episode. I remember that one. Spoke at last year's Posette, formerly known as CitusCon, about support in the darkest hours, which no doubt is a nod to some metal song, but actually talked about sort of like being on call and being met with a strange bug. And in this year's talk, we'll meet with the heroine of that talk again. And there will be a cameo by Dirk van Veen, apparently, who you saw in the trailer just now, and is a community member that you'll find playing chess with Boriss in the hallway track of many a Postgres conference. So let the story time commence.
Well, hello, everybody. Thank you for coming to this presentation. My name is Boriss Mejias. I'm a solutions architect at EDB. And the story that we are going to see is not the typical presentation with the slides and, bullet points. This one is a storytelling. So it's a different format. And we were going to go together with Monica Debea, a tremendously talented support engineer who is going to investigate together with Kevin and Dirk about a problem that Dirk has with his project with synchronous replication. So we are going to go step by step until we find a solution to Dirk's problem. All right, so this talk is called What is Going On with Synchronous Replication? And my name is Boriss Mejias. I work at EDB, and I'm not just doing this presentation on my own. I have a super big help from two persons that I really appreciate and admire a lot. One of them is Dirk van Veen, who works at Adyen, and he's going to be coming with a problem which Monica Debea is going to try to help him to solve. Now, the illustrations are done a little bit by me, but huge part is done by Scarlett Riggs. So shout out to her for her tremendous work with these illustrations. Now, let me tell you what this story is about. If you have heard before about Monica Debea, maybe, she's a very talented support engineer that has to work in the office because the boss doesn't give her enough confidence to work from home most of the time. So she was really at the end of the day, and she was kind of waiting that everybody was going to go home because everybody was kind of tired to do anything else, while she was still monitoring everything in her system. She was looking for new problems because she's really motivated. Now, at a certain point, their phone started to ring again. And when the phone rang at that time, she's always expecting David. David is a very kind of careless developer who kind of break things at the wrong moment, and then he always blamed the database. So that's why he calls her all the time at that time. But in this case, it wasn't David. It was a more interesting problem, somebody who investigated the stuff more carefully and came up with something really straightforward to investigate. This was Dirk, that software engineer that is always carrying his chessboard and ready to challenge absolutely everybody to play a chess game. So Monica picked up the phone and said her usual sentence, Postgres support team, have you tried turning it off and on again?
Hi, Monica. I did not. Derek here from the Rapid project. I just sent you an email.
Hi, Derek from the Rapid project. So are you calling me just to tell me that you sent me an email?
No, I hate people who do that. But it's the end of the day, and I wanted you to know if you have some time tomorrow so we can meet in person so I can explain a kind of difficult problem to you.
Well, that will depend on what the problem is about.
Well, we have significant job delays, and it seems to be related to a large amount of sync rep wait events. And we observed the same delay in synchronous replication in both replicas. They seem to be correlated with vacuum on large tables and with checkpoints, but you will not really like this, but terminating the vacuum process really helps in this case.
Yeah, well, indeed. I don't like when people terminate vacuum processes.
Well, that's why we need your help. I attached some graphs to this email.
Some graph. Okay, let me check that. So there from the Rapid project, you sent me some graph with some problems with the sync replication, and you sent me a picture of a boa constrictor digesting an elephant.
I sent you what?
You sent me an elephant being eaten by a serpent?
I have no clue what you're talking about, but there is a graph with the amount of sync rep wait events measured on the primary server, and it suddenly spikes and to above roughly 400, and then suddenly drops again to near zero. Is that what you're talking about?
Oh, okay, I see. Well, okay. Yeah, this is interesting indeed. Okay, let's meet tomorrow after lunch. That seems like a good idea.
Right, cool.
Okay, so by the way, before you go, you know that the Rapid servers are not yet included in our monitoring dashboard, do you?
Yeah, I know, but I sent you the reference to all of our servers, so you can connect to them if you want to investigate directly on the servers.
Okay, that's very good. Excellent. Okay, see you tomorrow then.
All right. Should I bring my chessboard?
Okay, well, bring it. We will see if we can play.
Great. Sounds good. See you tomorrow.
Okay, good. Thank you, Dirk. All right, so Monica was with this problem, very well explained by Dirk, already wide investigated, not just something like, the database is slow, just go ahead and figure it out. That's how you have to provide information to the support engineer so that they can really help you. All right, so Monica was confronted with this problem now. She started to think immediately. She set up some stuff in the servers that Dirk sent to monitor, and then she was ready the next day to discuss with Kevin. Kevin is the other engineer who is trying to learn from Monica as much as he can, and every time that the two of them solve something together, Kevin, for some reason, gets all the flowers and the promotions from the boss, and Monica always has to stay in the back for some reason. Anyway, when they were started to discuss, they started to talk about synchronous replication. So Monica wanted to explain Kevin what the problem was, but Kevin, in his wheel of learning, he said, like, can you explain me again how synchronous replication works? You did it already, but I want to see whether I remember stuff and see where the problem could go. Okay, said Monica, perfect. Remember, we have the database, which is just files somewhere in a disk, but you need to access them through the memory or the RAM. So whenever a service starts to read something in the database, there's going to be a piece of the file that is going to go into the memory so that that information can be read. And that is the cache of the system, the shared buffers. It is shared because if some other process accesses the same data, it just reads the data that is there immediately. Now, this is just reading. Whenever you write something, you're going to make that buffer dirty. And that buffer that is dirty doesn't go immediately to the disk where the file is because that would be too slow. So we brought Postgres put it into a write-ahead log, which can also be seen as a append a string of changes. Yeah, so you're always putting all the changes so that whenever something goes wrong, you can replay all those changes and you always get a consistent view of your database. And because you can replay that stream of changes in the write-ahead log file, that is what you can be used for replication. Whether it's synchronous or asynchronous, there is going to be another machine at the other side which is going to receive this stream of changes, which are being sent by a process called the wall sender, because it's sending the wall files, and it sends it to the wall receiver. When the wall receiver gets that information, the first thing that it's going to do is put it from the memory to the disk, because the disk is your durable storage. So it's going to send that directly to a wall file again. So from a wall file through the wall sender, the receiver, to another wall file at the replica. Now, it's not enough to just send it to the wall file because this is done through the file system. And the file system is going to put it in some cache, whatever the system works. You want to be really sure that it's going to be on disk. So if something crashes, it is durable storage. So that's why you have this final loop, which is you're flashing into disk. Yeah, that's two different things. One is to write to the file system, and then from the file system, read it physically on disk. Then, of course, you can put that particular buffer into the piece of block of data into the shared buffers, and it's accessible at the replica as well. But this is secondary. The thing is that it's already on the disk at the replica. Now, that writing loop also happens locally. It's not just in the replica, but it's also locally. So this is over everywhere in all the systems that are running Postgres. So that's replication. Now let's see synchronous replication. And in the same drawing, I'm going to add some green arrows so that we can get the idea. When a process says commit this transaction, that commit will go all the way down to the WAL file, and it's going to be also written directly to disk. and then it's going to be sent, because it's reading the world sender, everything, to the replica. Normally, if it is asynchronous replication, you can immediately tell the process it's done. We have it on disk here. We're going to do all the other stuff in the background. But in this case, because it's synchronous replication, you want to prevent data loss, as in the Rapid project, and you want to do it fast. You want the replica to acknowledge that it already sent the information to the disk. So what you usually do is that when you send, well, not you, it's the Postgres service, when you send that message to the replica, there is a wait event called sync rep. And that is the wait event that Dirk is saying that is go to about 400. So there are 400 commit transactions that are waiting for that sync rep to come back from the replica. And then Kevin says, okay, it's all good, but slow down. So you have this sync rep, which is waiting. At which moment does it returns back? Immediately when it receives it? Oh, okay, let's see. There are two possible points, actually three. When you send it to the disk, it says like it is a remote write because it's written to the file system. But if you say that it's really synchronously on, it is when you put it back on the disk immediately and it's physically on the disk. If you have more than one synchronous replica, which is recommended, you're going to get it from the file system to the physical disk. So you don't really have to wait too much for that one, and you can take a little bit of risk, and then you, as soon as you get the file system telling you that it got that commit, then you can reply back as it is drawing here with the green arrows. At that moment, when the sync rep gets acknowledged, it disappears from the wait events. And when it disappears, it means that we can confirm to the other process that the commit is fine. And the application is happy because the data is in at least two places. Okay, so that's the synchronous replication. So we need to understand why there is an accumulation of synchronous replica at a certain moment. All right, Kevin says, this is the point. What could be the file system, could be the disk, but I don't think there is that because we have very good disk. This is SSD, is as fast as we can go. It might be the network. So they started to investigate. And they said, okay, we look at the picture, we see all the possible arrows. Let's start investigating the possible root causes of this. When another process sends a commit, another commit, and it's going to have another sync rep, that could be the network. Yes, we can investigate that. So they look at the network, they look at the values that Monica puts monitoring the day after. It was not the network. The network was super fast, no problem there. Then they continue looking then at the CPU consumption. The CPU consumption could have been an issue, but in this case, it was not. So carry on looking at the RAM. RAM consumption was okay. The amount of free RAM that you had available, it was enough to store the latest release of Thunder Mother without any problem. And then they look at the disk then, but the arrows were like kind of not exposed to a lot of usage. There was something in between there that was causing this problem. So none of the usual suspect was there. At that time, it was remembered by Monica upon the question from Kevin that there was some issue with the vacuum, some correlation with the vacuum. So they continue investigating. So these commits that are accumulating the synchronous replication there is not the only thing that is sending data to the other side. There are some processes like vacuum that needs to load tables in order to clean them up. And this is going to generate more WAL files. And those WAL files have to be sent to the other side, creating a lot of WAL when the vacuum process a table which is very, very large. When we say very large, we're not talking about gigabytes, we're talking about terabytes. So that's something to consider. So although this was not part of the commit messages, it was generating a lot of WAL files. And this was being sent through the same process of the WAL sender to the WAL receiver, generating more WAL files at the other side. And when you have too many WAL files, you reach the threshold of the maximum WAL size, which is going to trigger a checkpoint, which means that more I/O going from the shared buffers to the disk in order to write all the data that is in the buffers. And that produces a restart point at the replica. So a whole concatenation of things. So might be something there. All right. So when you send that message to the disk, it is already a lot of accumulation of WAL files. So the synchronous replication starts to accumulate. They go beyond the 400 and then more and more. And then you get this problem that Dirk is super worried about. All right. This is the graph. This is why this is being observed. We just don't know why. Okay, so Kevin, we need to talk to Dirk again because he's coming after lunch. Yes, but we first need coffee, said Monica, very wisely. At that moment, Dirk arrived in the office. They didn't have so many good news. Hey, Dirk from the Rapid project. You were right. This is indeed a very interesting problem. And thanks for all the information that you already sent via email. It's a very good investigation so far, what we have observed.
Yeah, thanks a lot for the compliment, but we are still very puzzled with what we see.
We are puzzled too. Actually, we had to look at the RAM consumption, CPU usage, even the storage, which is SSD. I mean, this is bare metal. It's the fastest thing that you can get. I mean, but the serious problem is there. So we look at the network, of course, the first, but nothing is a problem. So no usual suspect is having the problems.
Okay, but there definitely is a problem. So do you have any clue what could be causing this huge amounts of wait events?
We will continue investigating what you said about the correlation with vacuum and checkpoints. So we don't know yet. We will investigate more. So let's meet on Friday.
Well, if we have little to discuss now, sounds good to me. And as this meeting fell short, shall we play some chess?
Okay. Although I'm telling you the story, I don't know all the details, so I don't know actually whether they played chess at that moment on the Tuesday. What I know is that Monica and Kevin were really puzzled about this particular problem. So they continue investigating why did they have these wait events. They were waiting and waiting and accumulating and waiting even more. What was going on? So they get back to this problem. And they started to see, okay, there is something when you are writing the synchronous message from the word receiver down to the file system that is causing some trouble there. So they decided to zoom into that particular moment when there is a lot of WAL files and a lot of restart point happening at the same time in all the replicas, because this is something consistent across the replicas. You always want to have at least 2 replicas if you want to do synchronous replication. Yep. So they decided to look at the WAL receiver process, and they investigated it with 2 particularly useful tools. SS for statistics of the sockets, because the network is actually files where you're writing those sockets, and then it's going to produce an input and an output. And also with perf, where they can see what are the events that a process is waiting for. And then they observed that when the buffer of the word receiver was being accumulated, there was a switch into what they were waiting for. So when you are writing stuff to disk, that's a certain operation, but then when you're waiting for the disk to be flashed, that's an operation called the F data sync. That's a normal thing that you have to wait more because physically writing takes more time than just writing to the file system. But in this case, when that buffer was full, there was a switch to the pwrite64, which is actually just writing into the file system. So it wasn't really the disk, it was the file system the problem. They look at network, RAM, CPU, disk, but it was a file system. They said, why would it be the file system, said Kevin. We are just generating a lot of files. Let's get more coffee before we continue investigating, because there's too much things to investigate. All right. So what's happening with those WAL files then, said Kevin, because there's too many of them. Well, whenever there are checkpoints, there is the archiving that happens as well afterwards. They're saying like, okay, we already wrote all these WAL files, so we can get rid of some of them, and then we archive them, but you don't just delete them, you reuse them. Does that mean an operation in the file system just to rename a file? And apparently, for some reason, something that should be super fast is taking a little bit of more time when there are so many WAL files. So that could be an issue. So, okay, so Kevin, can we do something about this recycling of the WAL files? Yeah, well, there is a parameter called WAL recycle. Maybe we should disable this. That should be safe. Okay, what else? What else? So whenever you have to create more WAL files, what you want to have, the reason why you reuse them is because you want to have a certain amount of disk, 16 megabytes, all in the same place. You don't want to start creating new pieces of 16 megabytes because it could be split into 2 and 4, and then 8, or then 2 pieces 8, or you just want to have the 16 in all one single place. So what Postgres does is whenever you want to create a new WAL file, it adds zeros on it so that you immediately reserve the entire stuff. It's like when you want to have a drink with your friends in a pub, you immediately put your jackets in all the chairs so nobody else pick up that table. And everybody then can arrive afterwards and pick up the chairs. Now, that pre-process, before you sit, that you have to put a preparation for the table, that also takes time on the file system. Can we do something about it? Yes, there is a parameter called the WAL init 0. That is the one that says like initialize the file with zeros. Maybe with the amount of WAL that they're generating, you don't need to prepare anything. You just write the whole thing. Said Monica. Then WAL recycle, WAL init 0. Please give me an idea. Let's just disable these two things. Let's go and talk to Dirk. Dirk, go. It was Friday. Dirk arrived. A little bit tired for the very busy week. But then it was time to talk to him. Dirk, so here's our hypothesis. We believe that all this thing, as you were saying, it is really associated to vacuum and checkpoint. And when the large tables that gets vacuumed, there is a huge amount of WAL file that is generated. And I must admit that I haven't seen this amount of volumes of WAL before. I mean, this is an 18 terabytes table. I mean, shouldn't we be considering partitioning the table?
Yeah, we know it's in our roadmap, and we will partition this table in our as part of our next large upgrade, which is scheduled for next quarter.
Okay, good. So partition your tables. Too much WAL. And because there is so much WAL, when this vacuum process starts, the threshold of max WAL size is immediately reached. This triggers checkpoints.
Yeah, we already increased the max WAL size a few times.
Yeah, we saw that the value is already large enough. So we are not going to plan to change that value. But there are other things that we want to do. Because when the checkpoint starts, it is going to clean up WAL files. And by cleaning up those WAL files generated by the vacuum, all this stuff is going to delay the writing of new WAL file. And because it's delaying that thing, when the synchronous flag arrives, it cannot immediately start writing, so that delays the process of the sync rep. And the primary stays there waiting for those sync rep, because the system just cannot write.
Okay, I'm following you, but is there a suggestion in this?
Yes. We want the system to write as fast as possible. So we don't want anything to prevent that preparing chunks of 16 megabytes or whatever. So we know that this is a value that normally works in every system. It's an average workload, but you don't have an average workload. Your WAL rate is super, super large. So what we suggest is disabling this WAL init 0 that prepares the file to be one single chunk, and to disable the WAL recycle of file. So this might be the two changes that we want, but definitely the WAL init 0 might be the most relevant change that we want to apply. What do you think?
Well, it's definitely something we didn't consider at all.
Okay, good. Yeah, we never considered that either. So, but this is a really special case. Okay, so let's do that. Let's change the WAL recycle and the WAL init 0.
Yeah, let's do it right now. It's Friday, end of the day. What could possibly go wrong? We can observe over the weekend.
Yes, let's do them right now then. All right.
All right. Do you want to play some chess?
Okay, so they decided to play some chess. They look at the stuff. The suggestions were given to avoid that when the commit was checkpoint was happening, those sync replication were going to be immediately removed. So the suggestion was to have the WAL files written as fast as possible by disabling recycle off and init 0. And happily, they went to play some chess. Not just a Friday evening, they carry on playing the entire weekend. Both Monica and Dirk beat the pride of Kevin, who lost all the matches. But between Dirk and Monica, there was such a competition that they finished the weekend in a draw. They don't know what they were going to do about this. Maybe they will join the Postgres Chess League or chess team and start playing with other Postgres people that play chess. So after the weekend, they continue looking at these values. Those changes were super good. Finally, the WAL receiver could write as fast as possible, and it could sense the acknowledge of the commit message super fast, so that the sync rep would accumulate but not as fast as much as possible. And this message will be sent immediately back to the process that we were writing, and everything will continue working at normal speed, even when there was a lot of vacuum and checkpoints. And with this, we end this story of Monica DBA until the next challenge. Thank you very much.
The creativity of Boriss's Postgres storytelling just continues to wow me.
Yeah,
Really fun.
this was so much fun. I definitely laughed out loud a couple of times, almost spitting out my coffee, especially over the, what could possibly go wrong if we deploy on a Friday?
Nothing. Famous last words. Really nice cameo by Derek Van Veen, who will be a speaker in Livestream 4 as well tomorrow. And shout out to Scarlett Riggs for some of that amazing artwork. But especially Boriss for his storytelling. Okay, let's see what we've got. Just to remind people, Boriss and Derek are both available on the virtual hallway track on Discord right now. You can go to the Posette Conf channel after logging in to aka.ms open source Discord. So please feel free to pop on over, ask questions, give feedback. I'll also continue to share links to the surveys if you want to give talk survey feedback to any of the speakers whose talks you've seen today. And now it's my pleasure to introduce our next talk. So Jimmy Angelakos and Flor Drees. Jimmy is a systems architect and database architect and a longtime Postgres contributor. He's author and co-author of a couple of books, author of Postgres Mistakes and How to Avoid Them, very important, and co-author of the Postgres 16 Administration Cookbook, a very frequent Postgres conference speaker, and he's co-presenting today with Flor, who is also my esteemed co-host on this live stream. Flor is a staff community PM at Ivan and is based in the Netherlands and has previously worked in developer relations at Grafana Labs and at Microsoft. And first started working with Postgres as an application developer, working on Ruby projects. Flor is one of the organizers of the first ever PG Day Lowlands, which will be happening this September and is just in the process of being rolled out. We'll talk about it a little bit more in the wrap up at the end of today's live stream. So don't disappear after the last talk. Stay for another 10 minutes or so. And Flor is also the co-organizer of DevOps Days, and Community Over Code, and lots of events. She also talks about open source Postgres, dinosaurs, and chickens. And she's giving me the, come on, Claire, speed it up. Is that what's going on?
No, it's just like too many conferences, but yes.
Okay, got it. So with all of that, they're talking about, I think, a topic that doesn't get discussed enough in the IT communities, neurodiversity and people and the different ways our brains work, mental health. And the title of their talk is How to Work with Other People.
Hi, and welcome to our talk. My name is Jimmy Angelakos, and we're going to be discussing neurodiversity and how it affects interactions within the workplace and the IT community in general. What prompted this talk was the fact that I noticed many people were anxious, depressed, they had trouble with their employers, they had trouble interacting with their teams, and I reached out on social media to collect these stories, and one of the people that wrote back was Flor.
Absolutely. I did. I saw your call for input and experiences, and I had just given an internal talk about my ADHD diagnosis and how I've been basically coping with something that I, had all of my life, but I only found out about fairly late in life, right? And asked if we could do a talk about it together. And we talked some more and figured we should submit something to Posette.
So the talk is called How to Work with Other People. We discussed what prompted it. The other question for anyone who knows me is, what's wrong with Jimmy? Why isn't this a technical talk? But moving on, there's a very clear lack of awareness in IT circles around mental health issues, and that leads to unnecessary stress, as we mentioned. It leads to strained relationships with your colleagues, with your employees. It leads to burnout. It leads to people leaving companies and having this churn of people moving from company to company. It leads to conflict and strife within open source projects. And so if we can move back to the previous slide, please. It's really important to say that understanding how different things affect different people differently. What do we mean when we say that neurotypical, when we're talking about neurodiversity and mental health, is a bit of a misnomer, right? Everyone's brain is wired a little bit differently. And being accommodating to neurodivergent people has benefits for them, but for everyone in general, because everyone stands to benefit from having, let's say, clearer instructions, or having better calendar management, or the option to drown out the noise in the office, right? So this is why we reached out to peers in the PostgreSQL community to get their stories and get their feedback on this issue. So the goal here is to contribute to a wider understanding of what makes your team members tick. And after this talk, please, by all means, we invite you to give us your stories and your feedback. So I'm a systems and database architect. I've used Postgres exclusively as a database for 16 years and open source in general for more than 25 years. I've written an extension called pgSQL and a couple of books on Postgres called PostgreSQL Mistakes and How to Avoid Them, and the PostgreSQL 16 Administration Cookbook. And I have been diagnosed late in life with autism spectrum disorder, which was a revelation in the sense that the signs were there, but until you read about them or you hear someone talking about them, you don't recognize them. You don't go to speak to a professional and find out what it means.
Yeah. And I'm happy to join Jimmy for this talk. I do open source community work at Ivan. Postgres is a large part of what we do. I used to work at Microsoft Grafana Labs, always in developer relations types of roles. I'm a serial conference and meetups organizer because I love getting together with people. And I always think that I have too much time on my hands. Hence, my ADHD diagnosis also later in life. I had heard about ADHD before. My mom is a primary teacher. I heard all about it for a really long time. But it took me watching someone else do a talk on ADHD and their discovery journey. And they said something that really stuck with me. They said that there was only 2 times for them, now and not now. And finally, sort of like everything made sense because that's exactly how I felt as well. And I figured out that that's maybe why I have trouble planning ahead and making sure I make deadlines. So before we go any further, I want to make sure that everybody knows that as a disclosure, neither Jimmy nor I are doctors. So we're speaking from experience here, and we're relaying the experience of some of the Postgres community members that they've shared with us. But by no means this is any medical advice. And also, as a trigger warning, we might use some ableist language in one of our slides, but that's just to prove a point. So I really hope that we don't offend anyone. And then also, before we move on, it is a little bit time for definitions, right? So I want to make sure that we catch those too. What is neurodiversity? Neurodiversity is a word that is used to explain the unique ways in which people's brains work. So while all of our brains develop it similarly, no 2 brains are exactly alike. And being neurodivergent just means having a brain that functions different from the average brain, right? So from a neurotypical person. Because it's not an external condition, you can't see that someone is not neurodiverse. It's invisible in that way. And it also makes it much harder to talk about it and to remember to consider. How prevalent is it then? Well, between 15 and 20% of people have a neurodiversity or are neurodivergent. This includes up to 10% people that have dyslexia, 5% of people that have ADHD, and 1 to 2% with autism. And despite many autistic people being very talented and qualified and willing to work, only 29% of the global population with autism are full-time employed, and oftentimes in positions that they're actually overqualified for. Then there's comorbidity. That's when one condition occurs alongside with another condition that you have been diagnosed with. And sometimes the effect is a mix that will make you being perceived by others as difficult to work with. We'll get back to that in a little bit. Then masking or camouflaging, that's when you're trying to suppress, for instance, autistic traits to appear neurotypical. And that can lead to discomfort for long periods of time while you're suppressing things that are an integral part of you. And that can lead to comorbidities like feelings of depression or anxiety. And often people that are already underrepresented in technology do a lot more masking and only find out about their diagnosis later in life.
So you may have already grasped that from our abstract, but times are hard for people in IT. There's been mass layoffs recently. There's been restructuring of companies. There are few entry-level positions. Everyone wants 10 years experience on technologies that are 5 years old. The job descriptions and interviews aren't ideal for neurodiverse people. We've had, if you remember this time, for a couple of years had to work from home, which meant that people were isolated and lost the connections they'd made at work. And then even worse, when everyone was talking about how great it was that finally companies have embraced remote work, those same companies ordered people to return to the office. And the mandatory return to office really caused some issues. And so we had the anxiety and depression of people looking for work, hopelessness and despair when the positions weren't suitable for them, which leads to feelings of inadequacy and or imposter syndrome. Maybe I'm not good enough for this position. Also, staying away from the work environment, from the office, meant that some people lost the structure that they needed to structure their day around. And then when other people were forced to return to the office after they had adjusted to working from home, then they had to deal with distractions and noise and other things that come with things such as open plan offices, let's say. So let's talk a little bit about the conditions that we're talking about. Now, depression is super prevalent. It means you have extremely low energy for most people, difficulty concentrating, sense of emptiness and despair, or being on the verge of tears almost all the time. So it's not feeling sad. Depression is something beyond that. It brings lack of motivation and pleasure in doing things, even those things that were previously very enjoyable for that person. Now, moving on to the autism spectrum, many people know that autistic people have difficulty in social interaction. Just the other day, someone said, "I'm afraid to ask you, Jimmy, because you're scary." And that is just one of the perceptions that get created, when you have poor social interaction skills. Or anyway, moving on, hyperfocus is a trait that autistic people have. And this is related to something we call monotropism, which is the inability to pull oneself away from what they're doing or what they're thinking about at that time. Generally speaking, autistic people set very high standards for themselves and then get very disappointed when they can't live up to those impossibly high standards, right? There's a constant internal pressure to do better and the tendency to take on too much work, which is then exploited sometimes by employers who just say, okay, they can manage, let's just give them more work and more work. And that, of course, as we all know, leads to burnout. There are comorbidities, there are things that are associated with autism spectrum disorder, like anxiety and depression, and there's also a significant overlap with ADHD in some cases. And let's hear from Flora about ADHD.
Excellent. So ADHD stands for Attention Deficit Hyperactivity Disorder, and that's an executive dysfunction. So executive function help you manage things like focus and concentration, emotional regulation, self-motivation. And so people with ADHD struggle with all of those functions to degrees varying, of course, on the individual. There are several subtypes. There is inattentive, hyperactive, and impulsive, or there is the mix. But you might know these people as either the dreamer, you can't reach them, or the person that can't sit still on a chair. Some things that come with ADHD is, for instance, time blindness. That's a term that is used to describe the difficulty that people with ADHD have in perceiving and managing their time, and that could lead to challenges with punctuality and with planning. There's also that tendency to take on too much, but just because you don't really know all of the other things that you have already taken on and where you might get into trouble time-wise. So there's a risk of burnout there too. People with ADHD also often struggle with feelings of depression, anxiety, substance abuse because they try and self-medicate, and eating disorders as well. So let's look into a couple of situations where those kind of neurodiversities come into play even more. So say, for instance, the situation where your manager asks you to meet in an hour. Now, a neurotypical person would look at this request and think to look at their calendar, see if they have time in an hour, probably plan in that meeting and send their manager a meeting invite. A person with ADHD, however, thinks, an hour. Probably I have time because I don't really know what I'm going to do in an hour. I won't check my calendar. I won't necessarily send out a calendar invite, but only think in that hour, there's all these things that I could do. Oh, look, my inbox is full. Let me respond to this very urgent looking request. Forget about the meeting and then be prompted an hour later by my manager asking, weren't we supposed to meet? Another situation is a colleague who would ask you, do you have 5 minutes now? Or are you open to feedback? Now, where your request like that without any context, like you could have said, do you have 5 minutes to discuss or to share with me how you did that travel request for PG Day New York, because I'm looking into also going there, and I think you just did that, and you could maybe share how you've done that. Like giving that sort of like context to your request makes it a lot less open to interpretation, and so a lot less stressful. This goes for neurotypical typical people as much as for people with neurodiversities, of course. So adding some context to your request is very, very helpful. Then another situation where a colleague might use ableist language. That is, to anyone with neurodiverse, who is neurodiverse, might feel like, I am not normal, I am a joke, I will never fit in. And that can be incredibly hurtful because this is a condition and it's not a meme.
Right. So some other mental health issues that we skipped over but are worth mentioning, and neurodiversity conditions are like dyslexia is really prevalent, obsessive compulsive disorder we just mentioned, Tourette's syndrome. Many people that are neurodivergent have melatonin deficiencies, and that means they have erratic sleep patterns, which makes them not a morning person. So in some people's minds, lazy. And this brings us to the social stigma of acknowledging mental health issues. you will have noticed that whenever there's a news report about crime, and if mental illness is present in the perpetrator, it is always mentioned, right? So that brings to some people the fear of being singled out as crazy, and it makes them afraid to speak out on their condition and how they feel about the workplace or team they're working in, because they fear that that will affect their employment or their career prospects. Also present in a community that is close to our heart, and even the PostgreSQL community, we have to say that words matter. So when someone contributes to the discourse, or they contribute a code patch and they get feedback like, that's stupid or that's nonsense, neurodivergent people already have enough self-worth issues and imposter syndrome, as we mentioned, and that certainly doesn't help. Maybe that person will be put off contributing from the project for life if they get treated that way. But also, if you share your condition, and this is a real story that one of the people sharing with us said, when they shared their condition with their workplace, they had heartwarming acceptance and support from their colleagues. Now, it doesn't logically make sense that everyone should have the same skills and aptitudes. Are you listening, employers? And also, it doesn't make sense that you can accommodate someone's broken limb, but you can't accommodate their anxiety and depression. So maybe you can work fewer hours for less pay is not an accommodation. Finally, when it comes to hiring people that are neurodiverse, having people that think differently in your team can literally break the danger of group. There are skills associated with neurodiversity, like dyslexic people are really good at seeing the bigger picture and big concepts and ideas. ADHD, people that have ADHD are quick problem solvers and they're very agile. Autistic people deliver really high quality work with attention to detail. So everyone's bringing something different to the table depending on their skills and aptitudes. But neurodivergent people usually self-select away from companies because of the job description and because people ask for things such as a bubbly data center manager or a sociable data center manager, right? Things that have nothing to do with the job description. But if someone reads that and thinks, oh, I don't tick that box, therefore I'm not suitable for that job, they won't apply. So that's something to think about. And also, sorry, if we can go back to the previous slide, not everyone thinks that the same things are desirable perks in a job, right? So it's not everyone's cup of tea to have beer in the office on Fridays or foosball, right? That it's much more important to be accommodating and understanding about people's mental differences. And this brings us to changing these attitudes in companies, which is really hard. And sometimes it feels like the HR department is not there to help. So it's better to internalize those things and try them out with your colleagues, with your team, because that will eventually make enough people aware of the issues that it will spread to the companies as well, hopefully.
Yeah, and we want to dive into a couple of those tips that were on the previous slide. One of the things that I mentioned when I did my internal talk about my ADHD is some of the sort of like coping mechanisms that I use, and a lot of people found them incredibly helpful. Again, not only neurodiverse people. So one thing that I use is buddy doubling. And buddy doubling is when you hold each other accountable by doing a thing together. So, for example, my expenses are due, and I absolutely hate doing my expenses. And I used to refer it even as my ADHD tax. That is the money that I lost by just every fiber in my body resisting opening up that expense program. So with buddy doubling, I find someone else who also needs to do their expenses or has another chore that they're really, really like fighting against doing. We open up a video call, we open up a chat, we do the thing, we tell each other that we've done the thing, we celebrate each other for doing the thing, and then we go about our day. And so now at Ivan, the employee resource group for neurodiversity has actually set aside time every week so that people can just dial in and do the buddy doubling together, whatever task they need to get done, and get it done, literally. Another thing that I think is incredibly helpful is writing your own README. So sometimes like talking about the thing that you have might be very difficult for people, but maybe writing about it is a lot easier. And especially when you can do that by writing your own README. So hopefully we're all familiar with READMEs because we write at least that level of documentation for our projects, right? But if you write a README for yourself, that is incredibly helpful because it's almost like an internal cheat sheet for knowing how everyone prefers to work together. And so it's important that everybody in a company does it, and it's shared in a very in a central place that is accessible to everyone. So maybe on your wiki, your Notion, your intranet, whatever you're using. It's standardized questions to literally question your preferences. And it's absolutely wild how we don't think about it before we are answering those questions. Maybe as a bonus, take time to walk through these READMEs together with your team members to add some context to these. So I put some resources on the slide where you can find some of those type of READMEs templates. Another thing that is incredibly important is is timeout or time off. So a Postgres community member shared with us because they love to be around people, but it's also very exhausting. And when stuff gets too much, when they get overwhelmed, their body reacts and they start crying. And that can be completely normal to you as an individual, but it can feel a bit embarrassing, and it's not always very comfortable for everyone around you. Making sure that you have a quiet space that you can retreat to when things are too much is incredibly helpful. So, for instance, when your work includes a lot of traveling, making sure that you book a hotel that is close to or at the venue where you need to be, so that you always have a place that you can retreat to is incredibly important. Also, taking time off. One of our community members tells us that they have taken very little time off work over the years, partly because of their perfectionist tendencies and partly because there is a stigma attached to mental health issues and taking time off because of it. And they were worried about being seen as weak or unstable or not good enough at their work. Particularly unhelpful, I have found, are unlimited vacation days, because especially neurodiverse people tend to not take those when they already feel like they're being a burden. And purely speaking for myself, if I have unlimited vacation days, I will simply lose track of how many days I've taken. I feel like I've probably taken too much already, even if I probably didn't take any near the amount that one should actually take to fully recharge. I want to mention assume good intent, because really most people mean well. Nobody wants you to fail. But as a person underrepresented in tech, again, I would like to add that make sure that you cover your bases as well. Try to find your community at work, maybe in that employee resource group, sorry for that horrible acronym, or a special interest group, and find your community there and make sure that they can support you.
Other things you can do is practice empathy for other people. So you can schedule messages or emails to be posted during working hours. My personal favorite is when someone tells me what we should do next week on a Friday evening as I'm signing off of work. That's not stressful at all. And people can also write and maintain wikis that explain to people how things in the company work so that they don't feel lost. In the workplace, in the office, you can practice low lighting and low noise environments. These are helpful to lots of people. And you should probably accommodate these things by default, so people don't have to beg you for noise canceling headphones, right? Or you can have fidget devices laying around in the office so that people don't have to ask for them. And most importantly, you have to listen instead of immediately offering solutions, right? So when someone says I'm dyslexic, then don't immediately recommend, oh, use a spell checker and that'll solve everything.
How come I never thought about that?
These are places you can find us online.
Yeah, I would love to chat more.
And these are resources that are really important. There's a really important book, podcast, a legendary article on HuffPost, and there's also warnings associated with online mental health care, right? So you need to make sure that you protect your privacy, you protect your sensitive data. There have been fines associated with these platforms, so make sure you use someone that's approved by your health authority, and that you are speaking to someone licensed, right? You should speak by all means about your condition and the way you feel to friends, to professionals. Don't keep it all inside, because otherwise you may never find out what your limitations are, what your capabilities are.
Thank you.
Thank you very much. We're very grateful to Posette for inviting us. And we want to thank you for tolerating us during this talk. Hopefully you can use this information, whether you're neurotypical or neurodivergent, to improve your experience and other people's experience as well. And we do believe that the PostgreSQL community does stand to gain from opening this discussion and keeping it open. Thank you very much.
Okay, Flora, that was amazing. Such courage on your part and Jimmy's part to just talk about your personal experiences and be open with them in the hopes of helping other people, whether they are neurotypical or neurodivergent. And I'm really glad that we accepted this talk. You both, I think, have done us all a service. And somebody on the Discord chat was even saying they're going to recommend this talk to their friends who have nothing to do with Postgres. So I think it's going to do well once we get it published online, beyond just the people here today at the live stream. So thank you.
Thank you. I was very glad to read that. I mean, I also only started my discovery journey after hearing someone else talk about it. So, paying it forward only seems like the right thing to do. I am very overwhelmed by the wonderful responses that we got in Discord. And I just want to echo again that Jimmy and I are both very happy and willing to talk to you, to anyone in private, in DM or whatever, if they so feel like.
Okay, so somebody else on Discord asked if it sounded like they wanted to go back and listen to the entirety of this talk or just some of the previous talks. So I just thought I would pop this up on stage where you can find the individual Posette all 42 talks after the event is over, which means after live stream 4 finishes tomorrow, probably in about 28 hours. And there's 2 pages. You can go to the Posette schedule page, aka.ms Posette schedule, and all of the items are going to be updated to include YouTube embeds. And then there's going to be a YouTube playlist as well. If you go to aka.ms Posette playlist right now, you're going to be directed to last year's CitusCon Year 2 playlist. But soon it'll be updated to reflect everything from this year's event. And you'll be able to watch Jimmy and Flora's talk all over again individually. So you can, I also dropped a link to the YouTube live stream for this live stream today. And you can obviously kind of just move that scroll bar back and watch something that happened earlier. With that, I think it's time to introduce the next speaker. And so let me pop that up on the screen.
Excellent. Yeah. So our next speaker is Deepak, and Deepak likes to call himself the database guy who works in database development, performance tuning, consulting, and migration. Was born and brought up with Oracle and Postgres databases. for 7 years now, he is actively working on database migration to the cloud. Deepak is passionate about Postgres and all cloud-managed database services and is actively working on seeking new migration patterns for solving complex migration challenges. Deepak has a wonderful blog that he updates often, so definitely encouraged to check that one out. I will pop the link in Discord if Deepak doesn't beat me to it. Also, I encourage everyone to check out the PGConf that takes place in Bengaluru, which is his favorite. Takes place every year. And in this talk, Deepak will share the current learning that he had moving customers and large code bases to Postgres with pgSQL.
Hello everyone, I am Deepak Mahto, founder at Data Cloud Case. We help our partner and customers succeed with migration to Postgres on any cloud. Today my talk is about how we can accelerate migration to Postgres on pgSQL when we are migrating away from commercial engine like Oracle or SQL Server. Let's go into our talk. Welcome. I hope you all are having a great time at Posette. I'm enjoying each and every talk here, and I'm pretty excited for my own talk, which is accelerating Postgres language conversion when migrating to Postgres. In this talk, we will cover some of the agenda, which is around understanding key challenges that we have with pgSQL, how to overcome them to accelerate the overall conversion process to Postgres, why acceleration is a critical piece as part of conversion, and also we will look into how we can conduct a code conversion planning and list some of the accelerator or helper for the conversion process. A typical migration process involves multiple critical steps. At a high level, it includes assessment, schema conversion, code conversion, testing and fixes, migrating data, performing cutover, and validating the complete stack of application from downstream perspective as well. From an effort perspective, and based on my experience, migrating dozens of customers to Postgres, most effort are concentrated in conversion and bug fixes. This constitutes approximately 50% of the effort for the enterprise customer, primarily due to most of the logic being embedded in the database in the form of procedures, function, triggers, or package. And thus, accelerating code conversion to Postgres become more important to have an efficient cost and time. What exactly is a PLPGSQL, right? A fun fact is PLPGSQL itself an extension, which is created by default when we create any new database in Postgres, as it is part of template database. It is primarily a loadable procedure language that allows us to encapsulate logic around our data and execute it at stored code or anonymous code block. We have lots of different procedure languages supported in PostgreSQL. To name some, we have PL Perl, PL TCL, PL V8, which is a JavaScript library, PL Python, and Rust. In today's talk, we'll focus more on PLPGSQL. Now the question arises, why PLPGSQL? One thing that I have learned from my experience as database developer is the importance of bringing logic closer to the data to reduce client and server communication overhead. And this is where PLPGSQL shine. It is readily available by default, easy to use, and it's a standard language with similarity with PLSQL from Oracle or TSQL from MS SQL. So in short, PLPGSQL allows us to group logics around data within procedural function for repeated execution across connection. A typical structure of PLPGSQL is a block base. It typically comprises of code enclosed within a quotes or a dollar quoting that we use to handle enclosed quotes within quotes. It includes block, as in an example, it is block 1, declaration of different variables, procedure logic embedded within begin and end. In the next section, we will talk about some of the challenges that we have with PLPGSQL. Now, the very first challenge that we have with PLPGSQL is that most of the code logic are enclosed within string. And it can become cumbersome for some of the complex logic because of different issues related to variable substitution or a surprise exception at the runtime. If you look at the second challenge that we have, and also the example that I'm sharing over the slide, you will see that we are defining a package, or we are defining a function over here, which is referencing a column that does not exist. But over here, creating function or procedural code does not guarantee a check on syntax. Hence, my create function procedure was succeeded. And this is also one of the surprise that we see for most of the developer coming from a different engine like Oracle or SQL Server. So in short, we don't do a syntax check or semantic check as part of creating functional procedure within a procedural logic in PLPGSQL. And because of this dependency that we have, you'll see that it becomes cumbersome to have a dependencies across functions created and the logic that we have. Because of that, the interdependency that we have within the function is not present. And if you look at the example that I have in the slide, one function is dependent on another function. And if you try to drop the dependent function, then dropping itself is successful. Because in PLPGSQL, by default, we don't have a way to identify what are the dependent objects that are dependent on a particular function or procedure. And hence dropping is success. In short, PLPGSQL does not do syntax checks as part of creating object. It does not do a dependency check when we are dropping those dependent objects. And those are some of the key challenges that we have to solve when we talk about converting to PLPGSQL. So overall, one core conclusion I want to draw attention to is that successful creation of function or procedure in PLPGSQL does not guarantee code conversion completion. We might encounter embedded runtime exception that need fixing when the procedural code runs for the first time. Over here, let's take a sample example that I've shared on the slide, which include multiple issues at each and every section of if conditional block. Let's explore some of those exceptions that we have. It include missing function. It include missing tables or constraints that we are using as part of the code logic. And it also include missing some of the component as part of division by over here. Now, when we talk about this section, PLPGSQL interpreter parse the function source text and produce an internal binary instruction tree the first time the function is called. The instruction tree fully translates the PLPGSQL structure, but individual SQL expression or SQL command used in the function are not translated immediately. Now that causes an issue because the code piece call based on the input argument might not be testing the whole code of the function procedure. So we might not have the whole code coverage as part of compilation or as part of some of the testing that we do. So one of the key message that I want to pass on as part of conversion over here is that it doesn't matter what is the automated conversion percentage based on any preferable conversion tool that we use. The key accelerator as part of code conversion in PLPGSQL is planning, doing necessary mock or code sanity, and making sure we have some functional test cases from day one of our conversion. Now let's look at the code conversion planning component. And it is one of the critical steps as part of having PLPGSQL conversion accelerated. As part of code conversion planning, we should have an understanding of object to migrate. And we can start with some simplest characteristic that we have for the objects that include total number of objects, total lines of code or LOC. Also, we need to have some information around interdependency that help us streamline the overall conversion process and actually guiding us where to start. So we capture the number of objects, trigger, functions, packages, procedures, understand line of code, and also draw a line of understanding how they are interdependent with each other. And dependency-based approach for conversion is something that can guarantee us a better approach which we can scale, learn and fail faster, and allow us to uncover core issue earlier in the conversion process. If we talk about some of the source from where we migrate, we have some of the views that give those information about interdependency between procedural objects. Oracle has all dependency views. Same with SQL Server, we have system dim SQL referencing entities views that help us build something called as dependency metrics. In basic terms, metrics inform us about the database object to begin conversion or testing with. Typically, those either having no interdependency or minimal dependency, and those are some of the objects that we can always start with. And gradually, you build your dependency a level up, and it increases one after another. If you look at the screenshot that we have shared on the slide, it basically elaborates a week-wise planning that we have built, where we have taken into consideration the interdependency and the team size, and we have decided how much lines of code we can burn per week. And based on that, we have plotted the code that we will touch base and convert per week based on the interdependency, starting from triggers, views, procedure, and to the most dependent object, which is package in our case. So overall, it's very important consideration to have this planning done as in we are starting the conversion process with PLPGSQL. PLPGSQL also comprises of multiple configurations that we can leverage during conversion process. It includes those configurations that can be set at a session level, which shows us some warning and error for some of the identifier that we'll see in our next slide. And it also talks about some additional configuration. For example, a variable config allows us to define how we want to handle variables in case of conflict. It also gives you some of the option where we can print some strict parents, which is very useful for testing no data found kind of exception, which print out the variable for which those exception has been caused. And if you look at some PLPGSQL extra warning, you will see that it highlights different warnings at different level, and it helps us to use those in our development and testing environment. For example, we have shadow variable, query returning too many rows, or inconsistency with string and the assignment, which are some of the very common components that we see in PLPGSQL. Those get highlighted as part of the configuration that we set in extra warning or extra error as part of PLPGSQL. So setting those configuration as part of conversion help us uncover issue early during conversion phase, and those are easily and readily available as part of PLPGSQL configuration. And when we talk about conversion, how we can mess empty string or null comparison. In Postgres, empty string and null are not treated the same as compared to some traditional database like Oracle. Now, as part of code conversion, meeting functionality is one of the key success criteria. And if the code flow expects that the empty string and null should fall within an if block, we should have to other those post-conversion as well. So if you look at an example, if you pass an empty string in Postgres and doesn't take care of making sure where it can go based on the comparison, by default, it will go for a category where it is not null. But ideally, we want it to go for a section where it is null because that's how the code was written at the source. And we can use simple functions like nullif, which help us meet the functionality at the source. So this is a small accelerator which helps us to uncover functional issue that can encounter as part of testing. So whenever we have a text variable into a comparison in if clause for empty string or null, it's always wise to use nullif to overcome those differences. Okay, now coming to the next section, right? In Postgres, a data type mapping for functional procedure argument is a very important aspect that we have to build during the part of conversion itself. So we should have something called as migration pattern, which help us decide what should be my data type for a particular data type on the function. If you look at an example over here, right, a number is a generic data type in Oracle that can encapsulate the different types of information that we have in number. It can be integer, big int, numeric, or double precision. But if we try to do the same in Postgres, if my function is defined with an input type of integer, and if I try to pass a float, a big int, or a numeric as part of the call stack, it will fail the execution with the cast error. Hence, it becomes very important to be considerable around those function arguments that we choose and make sure we follow the same pattern across the whole call stack. I'm also sharing a tabular representation of how choosing a particular data type and how compatible it is with different numeric data type in Postgres. Like, for example, double precision is compatible with all the data type as part of input argument, but it can open up some door as part of being approximate or can create a truncation of the data as part of processing. At the same time, defining a numeric input argument might not work well when you're trying to pass a double precision to it. So overall, by sharing this tabular representation, I just want to highlight that it's very important consideration that we also have migration pattern that do take care of what should be my function input argument type and try to follow the same data type across stack or across procedure function within your procedural block. Okay, and this is what I call as subtle art of code conversion, right? Now, if you look at an example that I'm sharing on the slide on the left-hand side, you'll see we have an Oracle code. And if I want to understand the code, it is a bit cumbersome for me to understand. But if I just walk through what it is trying to do, it is trying to have a hierarchy query and which is doing some string operation. Sometime in code conversion, it is very difficult to understand and mimic exactly same code. So the idea as some of the cases is primarily working backward, which means that understand the code requirement for which the code is built and try to re-engineer that with PostgreSQL. Over here, if I run some of the test cases on the function that we have, we can understand that it is giving me the number of tokens based on a delimiter that is part of the string. Now, once we understand those requirements, it's very easier to mimic those in Postgres. So we can use a string split array functionality and cardinality and achieve exactly similar functionality instead of trying to mimicking and converting each code line by line and writing it with a complex CT which is recursive in nature. So the whole idea of subtle art of conversion is sometimes we have to take a step back, understand the functionality that we have the code built for, and try to work backward and create those functions with native Postgres option that we have as part of Postgres itself. And moving further, I also want to highlight one of the features, which is one of my favorite features that is added, which is an atomic function. In our previous section, we talk about having interdependency between function and procedure, which means that in case we have interdependency, it should not be dropped because it should be well aware that it has some other objects that are dependent on it. If you look at an example over here, add_number is used in square of some function. Whenever we define such function as atomic, it is well aware of those dependencies, which is parsed at the creation time itself and provide those dependency information. And in case we want to drop the objects like add number over here, it is aware of dependency and hence it will not allow it to drop. Currently, though begin atomic is something which is available only for language SQL, but it is something very important to have in pgSQL as well, where we can have a code dependencies, awareness of which function is dependent on other function, so that whenever any of such operation happen, we can be cautious of either dropping it or be well aware of how the dependency look like within the code. And again, when we talk about Postgres, how we can not talk about extensions? And sharing some of the extensions which you can make your conversion buddy and which has helped us a lot to accelerate some of the migrations. ORAFC help us have some of the function wrapper to emulate some of the functions that we have in Oracle or some of the proprietary packages which start from DBMS in Oracle. We have PLPGS_check function, which basically analyze the code and give you an error which might happen at the runtime. So it's a very interesting tool which scan the code and help you uncover some of the challenges that you have to solve at the runtime. We also have pgTab that allow us to have a unit testing framework using test any protocol for Postgres. Performance is also a very important aspect, right? So PL profiler is something that can help us to create a performance profile of a complete call stack when we're trying to analyze performance issue with procedure or function as part of procedure language. Also sharing you some of the additional tips on how we can easily get the performance issue with one of my favorite extension, which is PG stat statement. right? So PG start statement offer different options like track all, which you can set for your test or dev environment, and which will help us understand what are some of the top level or nested level calls or SQL calls that happen within a procedure which are problematic in nature and might require a tuning. A simple tips where you can enable in your test or dev environment, track all the nested calls that is happening between procedure and function, and make sure you're well aware of the performance aspect of those underlying queries that we have converted within function and procedures. Overall, one key thing is having a sanity of mock testing of functional test cases from day one of conversion. Runtime execution of PL pgSQL uncover core issues to fix, and it's very important to ensure code integrity and achieve overall functionality as part of conversion. I'm sharing a sample of PLPG callable that should be run as part of code conversion process itself. If initially we don't have functional test cases available, we can still mock some of the code sanity call and leverage some of the issues like type mismatch that can happen in a code workflow. We can also automate creation of such mock test cases using underlying Postgres catalog within information understanding schema using some of the tables or views like routines or parameters. Having those callable give us confidence that the conversion that we have done for our function procedures, it's not having a surprise runtime error. It is meeting a functionality based on the test cases that we have written. And we can always reuse those test cases further in our deployment cases to have those handy and run it whenever the need arises. So overall, we saw a different aspect. We started with the challenges that we have with PLPGSQL. And overall, the key accelerator that we should have is basically having a definition of done for code conversion that not only include conversion and compilation, but also include code sanity or functional test cases being available as part of code conversion itself. We also saw some of the extension that help us drive and accelerate some of the different challenges that can happen as part of conversion, like PL profiler, PLPG check. We also saw some of the differences that we have to take care as part of function argument, null empty string, and also some of the configuration that we will show as part of errors and warning for different use cases that we have. Overall, that's what I wanted to cover as part of PLPGSQL acceleration when migrating to Postgres. I had fun sharing all the challenges and the different ways to overcome those for conversion, sharing some of my social handle to get in touch for further information, and thanks a lot.
Thank you, Deepak.
That was some very useful information. Thanks also for sharing those extensions. I'm checking them out, all of them at once right now.
Well, and Oracle to Postgres migrations are definitely a hot topic these days. And so there's a lot of planning involved and a lot of code conversion that you have to do. And yeah, actionable tips there. Okay, moving on. I wanted to throw up the banner again with codes for people who want to get sticker swag. So you can go to that website, aka.ms, Posette swag, and enter the codes that you see on the bottom of the screen right now. And there's like 2 sticker sheets and also the podcast sticker as well for the new name that rolls out next month. So please enjoy. And for people who are looking at those socks thinking, hey, I want a pair of those socks. Apparently for folks who are very active in the discussion on the Discord, you might be able to ping Aaron Wislang and figure out how to get a different code to try to get some of those socks.
Which is everyone. Everyone wants those socks.
Yeah, who doesn't? Speakers do get them. So Flora, you're set, given that you just gave a talk. So I think that's part of the gratitude gift for Posette speakers. All right, and then next up, we just have a couple more reminders before we introduce the last speaker in today's live stream. One reminder is that you can fill out talk surveys on individual talks at any point in time using that link that's on the bottom left. And then the event survey is something that the organizing team would really appreciate for you to give feedback on your overall experience We know it's a virtual event, but we still try to delight people and would like to know what you think. And then Discord. Have we mentioned this enough? Do you think people know about it? No?
I don't think so. It's worth
Okay.
mentioning once more, because if you're not in Discord right now, you are missing out.
aka.ms/open source Discord takes you to the Microsoft open source Discord, and then you go to the Posette Conf channel once you're there. And speakers are available there because all these talks are pre-recorded, and so they can be present while their talk is being live streamed. Now, we had two more things that before we play the trailer, but before we introduce our last speaker. And one is people asked us to talk a little bit about what it's like to be a speaker at Posette, what it's like to give a virtual talk. And there's chickens on this slide. Do you want to tell that story?
So we did the sort of like briefing for all of the speakers for Posette. When was it? Well, recently. And because one of the organizers of Posette started with like a little intro and said that she has chickens, suddenly all of the speakers that have chickens as well mentioned that in their intro. And it turns out that people that are a Posette speaker and do not have chickens are in the minority. Didn't know that. That's fun to figure out that apparently it's very prevalent for Postgres people to have chickens. I do have chickens too, so.
I got a kick out of the fact that some of the speakers said, well, I don't have chickens, but I do have children. Does that count? So it was kind of a nice bonding moment. But seriously, I'm a big fan of in-person conferences, but there are some benefits to giving a talk virtually. You don't need the travel budget. You're going to ultimately be able to reach a lot more people with a video online. It is a little harder to rejigger your talk if you're used to giving like 45 or 50-minute talks, to come up with something that fits in that shorter form factor, 25 to 30 minutes. But you can reach more people with it. So it's probably worth the effort.
Yeah, and I mean, you see a lot of conferences in person that have 20, 25-minute talks as well. I don't think that is a special feature of virtual, but I do really appreciate that it's only 25 minutes, because that is just enough to get your point across, but isn't too long of a, sitting down and listening.
The other thing we wanted to just give a shout out to, in the wrap up, which is after the last talk today, Flora and I are going to cover a couple things, including some upcoming Postgres community events. But looking backwards, about 2 weeks ago, pgconf.dev happened in Vancouver, Canada, and I was there in person. I was lucky enough to be a speaker at that event, and the organizers just did an amazing job pulling together a wonderful schedule of talks, but also organizing like some patch review workshops and what it's like to be a Postgres contributor, an extension summit. They did a bunch of things differently than I'd seen done before, and really, really had a good time. So shout out to them. I took all these it was really a fun period. So those of you who hear about pgconf.dev next year, happening usually in May in Canada, might want to try attending, because it was very rewarding. All right, we have another trailer, don't we? So this is a trailer of all the talks that were in Livestream 1. So that they've already happened, but obviously the talks will be published in a couple days. So we wanted to give you a sneak peek. Let's roll it.
Hi everybody, my name is Charles Ferguson. I'm the Director of Product Management for Postgres at Microsoft. In my talk, in 25 minutes or less, I'm going to try and cover a variety of things that Microsoft is doing in Postgres, both our commitments to the open source aspects of Postgres and also what we're doing in the cloud.
Today, I will be talking about Postgres parameters. The title of my talk is Tuning Postgres Parameters versus Tuning Log Queries.
And I'm going to talk to you about connection poolers and their support for prepare statements. One of those connection poolers being pgBouncer.
Hi, I'm Paul, the CEO and co-founder of Supabase. Today I'm going to cover everything that you need to know about Postgres row-level security. I'll cover how to use Postgres row-level security, why you might want to use it, and some neat performance tricks.
and I'm going to talk about open source Postgres and how code gets into the Postgres codebase. And if you wanted to put a patch in, the process of submitting patches.
I'm currently leading engineering team here at Ikigai, and I want to share our story because it will give you a lot of insights if you're trying to build and develop an end-to-end AI platform using complex data types and complex AI workload.
And my talk today is called SaaS on Rails on Postgres. It's all about building multi-tenant SaaS applications and the capabilities that we have to scale up and scale out with things like Active Record, horizontal sharding, and Citus.
This session would be really helpful for the customers who are planning to migrate their on-premises workloads, especially Postgres workloads, into Azure, as well as our single server customers who are planning to migrate from single server to flexible server.
Welcome to Scaling the Wall of Text, Best Practices for Logging in PostgreSQL. This talk is for people who are new to Postgres, but also for those who want to improve their experience administering Postgres databases.
This talk is about how you could make your inserts faster, and any PostgreSQL developer who is dealing with data uploads, this is the best talk for them to go through.
Good day, everyone. I'm David Wheeler, creator of PGXN and principal architect at Tembo. Today, I'd like to talk about the state of the Postgres extension ecosystem, its past, its present, and the future.
Oh, that was fun. That was fun. It makes me want to go watch all those talks again. Okay, introducing our last speaker today, but please don't drop off after Ryan is done because we have a few logistical announcements and a couple more tidbits to share with you all. Ryan Booz is an advocate at Redgate Software. He's worked in Postgres as an advocate. He's worked as a developer, a DBA, and a product manager for more than 20 years, primarily working with time series data. And he's a really good explainer, which means that this Posette conference is not his first rodeo as a speaker. He frequently gives Postgres talks at conferences. And like Marco Slot, this is Ryan's third Posette. He gave talks in years 1 and 2 as well, formerly when it was called CitusCon. But he is not just about databases. Ryan Booz is also a beekeeper. And the title of Ryan's talk today is Postgres Partitioning, Slicing and Dicing for Performance and Easier Maintenance.
Let's hear it.
Hi, my name is Ryan Booz, and I'm excited to be talking about PostgreSQL partitioning at Posette this year. Now, as our databases continue to explode with more and more data every day, partitioning is key to really understanding how to manage both performance and maintenance of your database. And I can't wait to talk to you about it. So this is me. This is where you can find me on social, generally Ryan Booz everywhere. I love to connect, talk about Postgres at all different levels, about Postgres community, and really just understanding how folks are using Postgres in their current roles. So I would love to connect with you at some point. Please feel free to reach out. Now, the agenda for today is pretty straightforward. With 25 minutes, it's not easy to fit everything into a short period of time. So we're going to do our best to do this in a way that's not too fast, but gives you the basics of what you need to know. We're going to talk about the what and why of partitioning, the 3 different types of partitioning that you can do inside of Postgres, creating and maintaining partitions. That's really what we all want to get to and actually do to manage our database. And then just a couple of tips to understand about Postgres partitioning as you begin to explore it. So let's go ahead and get started. So first, the what and the why of PostgreSQL partitioning. Now, why would we partition things? Now, in our regular life, we actually do this all the time. You know, we have things like file systems. We were used to many years ago, something like a card catalog. We could take things, divide them up into like groups to make it easier to find that information. And in some senses, that's one of the reasons that we do partitioning in Postgres. We can keep like information close together, which can help our queries, help the way that the planner goes about finding that information. But that's not all. We can also think about partitioning as an opportunity to increase throughput and actually the way that we can scale our Postgres database. Sometimes I think about it. In the US, we have turnstiles like this for our interstates. And I think about, there's multiple lanes here, and we can decide how data gets to tables depending on what kind of data it is. So, this allows us both an opportunity to split the data up so it goes to multiple places faster. And at times we can say, hey, this specific kind of data, in this case, if I was an EasyPass customer, I can use these lanes, but if I'm not, I get to go, or I have to go over here to this table or this partition to, just keep things in the right form. So we see, representations of partitioning really every day in our lives, whatever it might be, emails and file systems. But the reality is, the real use of partitioning is mostly about maintenance and then the performance that can come alongside that. Large tables in Postgres, and quite honestly in most other databases, don't scale terribly well. Now, the size of what counts as large has certainly grown over time as, hardware and memory and disk storage space has all changed. But adding partitioning to a table really begins to solve that scaling problem, both in the way that we store the data and the way we query data. So as you begin to move forward and you start to ingest things like time series data, which usually increases in volume pretty quickly, knowing how to go about this is really essential to managing your Postgres database. So what are partitions? In Postgres, partitions are really regular tables. Now, they're tables in today's versions of Postgres that we don't actually maintain. We create one parent table, and we then go ahead and allow the process to create the children tables that actually store the data. And they're regular. They have schema. They have table space. The partitions don't have to reside all in the same table space. Actually, they don't have to reside in the same schema as the parent table. They're attached to those parent tables. And then one of the unique things is recognizing, because they are individual tables, they have all the same things self-contained. They have indexes. They have constraints. However, they themselves, because they are regular tables under the covers, they could also be partitioned further, something we call subpartitioning. Now that gets into a much more complex layout of why and how you might do that, something we won't cover here today. But it is, worth noting that we're just talking about tables used and in some ways disguised as something different within Postgres. Now, this comes around as declarative partitioning in PostgreSQL. There are other forms, and actually still are other forms and ways that you can partition data in Postgres, but starting with Postgres 10, although I generally say Postgres 11 because of a few fixes that really lowered the threshold and made sure that partitioning worked well, began in Postgres 11. And so declarative partitioning simply means that we are saying this is the table that's going to be partitioned, and we declare how the data is distributed among the partitions. We don't have to write triggers. We don't have to come up with an algorithm in a program on our own. We allow Postgres to do that. We get to specify the method. Currently, there are 3: range, list, and hash. And then the 2 things you do need to understand are that partitions need to exist currently in supported versions of Postgres. They actually need to exist before the data arrives. And so if there is not a partition and you happen to be distributing or partitioning on time, maybe you're getting data for the past and you don't have a partition for that data, you will actually get an error. And so we need to be able to manage those partitions so that you always have a place to store the data based on how you're distributing it. There is a default partition that you can create, which is kind of like the catch-all. However, as we'll talk about briefly at the end, this is really just meant as an emergency and actually can make the maintenance of partition tables a lot more tricky than you probably want to deal with long-term. So what does it look like to create a table that is now a partition table? Well, it really doesn't change that much. I can take this table, it's a regular Postgres table, has some columns, has a couple constraints and a primary key, and I can simply say, hey, in this case, this looks like time series data, so I want to distribute it based on this payment date. And as I said at the very beginning, this allows us to store records of similarity, in this case by similar dates, close together dates together. Now, why would we do partitioning? Well, one of the reasons is, again, simply scale. If I were to say select star from payment and I don't have an index on payment date for some reason, Postgres has to scan through the entire table row by row to decide which rows meet this criteria. Now, if we have an index, that's helpful, but there is no guarantee of the order. And so we may actually go through that index. We know which pages of data on disk or in memory to go get that data in, but it's often randomly accessed. They are not close together because we haven't directed Postgres to try and maintain them in a similar table space. Now, with partitioning, we get to take that index. Remember, all of the child tables get all of the things that a parent table has, like indexes and their own constraints. And now, if we form this query appropriately, the master, the parent table knows which partition to go to and can ignore all of the other partitions. And that becomes both a speed up in how we are doing our querying, how the planner can decide how efficiently, most efficiently to go get that information. But one of the other benefits is this. When you have a very large table, you will often hear about tuning Postgres around shared buffers. So shared buffers is the configuration parameter that allows us to specify how much RAM on this computer will be used to cache the data pages that store our data that we're querying. Now, often you want the most recent data to be accessible there, particularly in things like time series applications. If you're only looking at the most recent day of data, you want to have enough shared buffer to retain that. The problem is, particularly when there's random access of data and it continues to grow and grow, we get to the point where this index is so big as one major index and the data and the tables that it represents that it starts to occupy most of shared buffers. And then that means as we do more queries, it's hard to do it efficiently. We have to push data out and pull new data into that cached space. However, if I partition data and I'm mostly querying the most recent partition, then I only have to keep that subset of the index and the data in shared buffers, making more of it available to the other tables and queries that we need to use throughout the application. Then there's one or two other benefits, particularly around data retention and archiving. Now, if you aren't using partitioning and you do something like archiving or particularly data retention by deleting older data, you tend to run into problems. First of all, delete can add locks that are challenging, and delete doesn't actually delete the rows immediately. It simply marks them as ready for vacuuming later on. And so what you end up doing is spending a lot of time potentially affecting other connections to delete that information, and then you have to wait for the vacuum process to come around behind and actually free up that space. It's not an efficient way to deal with lots of data as it grows to do data retention. And then there's index maintenance. There's a lot of ways and reasons why deleting as a form of archiving or retention becomes problematic the larger a table in a database grows. But with partitions, they are just tables. You can simply drop that partition at some point in the future, and then the data is simply gone. It's almost always a fairly instant operation. It doesn't contribute to table bloat and so forth. Or maybe you want to keep the data and archive it to a cheaper location like object storage or a file system somehow. Well, then you can simply detach the partition so it's no longer a part of the table right now. But if later you need to reattach that partition to query it, you can. So using partitions really makes the maintenance of your large tables so much easier. All right, so that's why we would use partitioning. That's why partitioning exists. And now we need to talk about the three ways that you can partition data inside of Postgres. So the first one I mentioned earlier in my sample table. And I would say this is probably the type of partitioning that's used predominantly and for anyone that's actually doing partitioning with their data. Now, typically, this really works well for something like time series data when you're partitioning based on a timestamp or a date. And again, that allows all of the information for a specific day and time to be close together, even if it's randomly accessed within that one table partition. Now, the other potential is something like object identifiers. So maybe we need to store, a range of information for 1 million rows at a time per partition. Now, is that the best way or method for your application to partition data? I don't know, but there are reasons to do that, and people certainly do. Now, the one thing to recognize is that when you set up your range, Postgres only gives you one option. It takes care of it under the covers. The range that you specify is inclusive of the lower value, and it's always exclusive of the upper value. The assumption being that the next partition will include at the beginning that upper value that you ended with on a particular partition. And so that means in something like time series data, maybe you're partitioning based on a log date. Log tables tend to get very large very quickly. And so in this case, if we say January 1st to February 1st, it would include all the data starting with January 1st, 00000, all the way up to the second or the microsecond right before February 1st, 000. And then the next partition picks up right there and repeats similarly. Now, we are defining this range, so we have to make sure we have the appropriate overlap, as it were, so that no data is lost between partitions. And if you're doing something like an ID, maybe it's a category ID, you're saving all of the information around a category of product or a range of products within partitions. It's the same thing. In this case, 1 to 10 means any product IDs of 1 to 9 if they're integers, and 10 to 20 from that point forward. The second, and honestly used fairly often depending on the application, is the list partition way of partitioning data. And it simply allows you to specify a known list of values somewhere within the table that you're partitioning so that you can specify partitions and say, hey, maybe all of the products that are bike in type go to this partition, or a ball, or they're a drone. Maybe it's regions. Maybe you support, some kind of application across multiple regions of the country that you are in. And so you could specify and partition data based on those specific lists of values. And then finally, you can partition based on hash. Now, this means that you aren't really controlling the value. It has to be numeric in some way. And we're simply saying, hey, we're going to specify, we get to specify really the modulus, the way that we're dividing into that value. And whatever the remainder is becomes the partition. And so it's actually a good way to distribute data randomly and hopefully evenly over time. So if there's no clear partitioning key, hash partitions could be a really good example, a good way for you to proceed or at least test your application. And again, generally, if you have a lot of data and what you are using as your hash key has some variability to it, this can be a good way to distribute that data evenly. All right, so now we have talked about why, we've talked about the type, and now let's go ahead and actually look at how you create and maintain these partitions. So we're going to go back to our table example earlier. Now I've called it something different, and I'll talk about why in just a second. Instead of payment, I've called this table payment 2. And again, we want to go ahead and partition based on that payment date. Now, if I had time to do a demo, I would tell you that the reason I created payment 2 is because you cannot partition an existing table in Postgres. So if I realized that my payment table was getting very large, I would have to create a new table, partition it appropriately, and then somehow figure out when a good time to do is to move the older data over into the partitions. And then I could do a drop rename, something we often call expand contract pattern in dealing with your database and your schema. And then the other thing to note here is that whatever you partition by, the column that you're partitioning by, particularly in a range partition, must be part of the primary key. So if, for instance, this table had started with just a primary key on payment ID, which might make sense, and I tried to partition based on payment date, you would get an error. And so the solution is just to make sure that your primary key, if you are going to have one, includes whatever column you are going to partition on. Now, again, You don't have to have a primary key. And sometimes in something like a time series table, it might not really be that beneficial. Because of time and maybe other foreign key IDs, it's very easy to identify the unique nature of each row. Once we've identified and created that partition table, we can now begin to create the partitions that will store the data. And so in this case, I'm simply creating 3 partitions spanning 1 month of time. We create the table, we name it whatever we'd like. This is a typical naming scheme when you are doing something like monthly partitions. And then you simply give it the constraints. You say, hey, for that table that you're partitioning by this payment date, go ahead and make sure that any of the data in this table is from the 1st of January to the 1st of February. And then we continue on. You can attach and create as many partitions as you want ahead of time. And there are tools and ways to actually help you do that. Maybe you need to create partitions for historical data before you copy it over. So you get control and you have the ability to do that. Now, all administration of the table, adding columns, adding indexes, dropping columns, renaming things, even constraints are all done through the parent table. And so you don't actually, rarely should you ever have to go to an individual child table to do any of this. In fact, if you try to modify the schema of a child table, you'll get an error because you'll notice when we specified the table, the child partitions, we didn't give it any schema. Postgres implied it from the parent and created those partitions to match. And so again, everything you do to a table, any kind of modifications should always go through that parent table. So that would mean something like this. If I want to alter, and add a column, I have to do it on the parent table and it will propagate to all the children. If I want to add an index, again, I do it through the parent table. It will then go ahead and propagate that to the children tables. Now, there are some things like an index that I could add to children tables. There might be a reason for that. Maybe you have a particularly large partition that has some kind of unique value or constraint. It's pretty rare, but some of these things can be done at the child level. But generally, you should do everything through that parent table. One other thing to recognize, and this has become a source of confusion at times when you're dealing with large time series applications, is that when you add an index to that parent table, it is not a global index. Right now in Postgres version 16 and even 17 that's coming, we don't have a concept of a global index that allows the planner to better understand where the data is distributed. Now it can, as we'll see in just a second, avoid going to partitions if you set it up correctly, but it doesn't have an index that really helps it get to the individual rows in a partition more quickly than going to that table and using the indexes at the child table. So just recognize that. This is simply instructing Postgres to create this index individually at each child table. Now, data retention, the maintenance of your data. Again, as I said earlier, you can simply drop a child table and Postgres won't complain. It just says, oh, there's no more partition that's attached for that particular constraint range. Now, if I want to retain the data, I could detach the partition. And then finally, I could later reattach that partition if I need to query it, as I mentioned earlier. So there are a lot of ways you can handle the data in partition to really help you maintain and query the information you need as efficiently as possible. Now, again, I did tell you earlier that there is this idea of a default partition. Again, it's not created by default. You have to actually specify that you want it for a partition table. It is a catch-all. So this is a way to make sure that data is always inserted, even if there's not a partition that actually matches the range or constraint of that data. It does prevent data loss. You won't get an error saying no partition exists. However, the maintenance of having a default partition can be really frustrating at times. Essentially, what this means is that if I then want to later add a partition for data that's currently inside of the default partition, I actually have to create the data. I have to scan I have to actually, get it to the child table and then do some check constraints before I can delete it. It just becomes a maintenance headache, quite honestly. And so it is often a necessary help but one that you really have to understand as you begin to use partitioning in your database. And that might look like this. Often I'll see scripts that start in some way like this. I created the partition table by initially, and then the first statement that we create might be this default partition, and which I'm realizing at this moment I have the wrong name on. So I do apologize for that. Normally it would be something like payment2_default, and that allows me to identify that partition. Notice there's no constraint. We're simply saying if data is inserted into this table that's partitioned and I can't find a table that matches the constraints, go ahead and use this partition. Now, as you can imagine, managing partitions as your database grows can be a bit of an maintenance overhead. You might have to have a script that runs continually to make sure that you have available partitions. If you know you're going to get historical data, then you have to make sure you do something to create these partitions first. Now, I would say don't rely on a manual process. Again, I've seen this happen. Even people that use a tool, maybe like Flyway or another migration tool, to continue to manage their schema, they might try and use that as a way to create partitions over time. But that's not really an efficient way of doing this. Instead, the predominant extension that allows us to do this easily is actually pgpartman. And using pgpartman, or maybe your own pgcron job, a script that you've written, it can run periodically to make sure that everything's happening as you intend. It can detach partitions after a period of time. It can archive data. It can move data to a different table space. It can create partitions into the future so that you are sure you'll have them. Now, there are other ways to do partitioning. Again, not all of these use the current declarative partitioning, but even something like timescale.db is a way to partition your table. And in that case, because they use an older inheritance model, it actually can create the tables for you so you never lose data. And again, Citus, the Citus plugin is another alternative that you can examine as well. So there are a lot of opportunities, but if you're going to use the declarative partitioning in Postgres, you got to use pgpartman or something of that nature. And that is available in all the major cloud platforms for you to use. There's no reason you shouldn't be able to use a tool like this to automate your maintenance. And then finally, I just want to talk about 2 or 3 best practices. Now, a lot of these I've learned over time. I did spend a few years at Timescale, and as we would help clients and customers, have really large time series tables, we needed to help them identify how to make their queries more efficient. So the first thing to recognize is that the general value that most people start their shared buffer space at is about 25% of the available memory of the server. Again, this is just a kind of the community-driven way of or recommendation for starting shared buffers. However, again, remember at the very beginning, I showed you like the indexes and other things that need to fit in that space. And so when you partition, you do want to make sure that the size of your most recent partitions, the partitions you're querying most often, easily fit into shared buffers. That might mean that rather than a monthly table, if you have a lot of data coming in, maybe you make weekly tables. That will have an impact later, but right now that might actually be the thing that you need so that you can always efficiently be querying the things that are happening. So again, those hot partitions, think about how to make sure they can fit in that shared buffer. You may need to get a bigger server or increase shared buffers in some way. Now, too many partitions can begin to have an impact. In the last few releases, generally 1,000 or a little bit more partitions will increase the planning time of the Postgres planner when it's trying to understand which partitions to go to. So just recognize that. And for very large partitions, again, just ensure that the indexes really are available because the planner will use those constraints to exclude partitions that don't match the where clause or the predicate for the partitioning column. And so then it gets to that table, and we need to make sure we have indexes that can help it find the data quickly, particularly when those tables are very large, those partitions. Second, you always want to filter by the partition key. There's really no value in partitioning if you never use the key that you wanted to partition by, because if you don't, it means that the planner has no idea how to more efficiently go to an individual partition to find your data. And so it will still have to scan every single partition to find the data you want. Now, it might be able to get to each table and then use a different index, but if you're not actually using that partition key, you're still potentially querying all of the data all of the time. So make sure that you are specific and you use that partitioning column. Now in dates, this is still a problem in Postgres. And the problem is just a nature of the planner. When you do something like values of dates, particularly in date ranges, try and use a specific date or time. So if you have a process that dynamically creates queries, try not to use the date math like now minus a month. Now that will work, but it actually will, Postgres has to do a little bit more work, and sometimes it won't be able to prune the partitions or use an index appropriately unless it has the static value first. So really consider this, test the queries that you have, and see if they might perform better if you make that modification. And last but not least, use schemas and table spaces. If you partition a table and you keep those partitions in the same schema, you'll actually see them in all of the tooling. So you end up with lots and lots and lots of tables that you rarely have to actually examine, whether it's in a tool like pSQL or even in an IDE like dbeaver. And so we want to hide those partitions. Often this is easy to do simply with a different schema. Again, you're simply creating a partition that is a table, and it doesn't matter if it's in a different schema, and that might really help with just the maintenance and the overall view of the data as you're trying to query it, because you're always going through that parent table. And then you can use something like different table spaces. I can take a partition that is currently in the default table space, and maybe after a year, I transferred that partition to a different table space that's on slower medium, cheaper mediums, like an EBS volume rather than SSD, something of that nature. Maybe it can even be spit out to cold storage, like object storage, using an S3 plugin or similar on Azure. So just recognize that you can use schemas and table spaces to your advantage. And so that is the end of just talking about the basics of partitioning. There's a lot for you to think about and begin to understand and practice on your own. But hopefully this has been a good start, and I would love to talk to you more about partitioning if you want to reach out. Thanks so much for joining, and I really appreciate your time.
Thank you, Ryan Booz. That was lovely.
That was a great talk.
Always full of good tips, best practices, recommendations. Ryan walks you through it, kind of step by step. You're not racing to keep up. I really appreciated it. Ryan is on the Discord. So if you still have questions for him and you haven't had a chance to ask him, you can pop on over there. Thank you all so much for participating in today's live stream. And thank you, Flor, for hosting.
Absolutely. Thank you for asking.
It's been a day, and I could not be more appreciative of everybody who's helped make this happen. If you've got feedback on any of the talks you want to give to the speakers, I'm showing the survey link on the left. If you have feedback to the event organizer, I'm showing that survey link on the right. And you can submit the talk survey link multiple times, like once for each talk. And it's super easy. It's not a lot of questions, but enough to be valuable so that speakers can keep getting better.
Yeah, please do. It's really a gift for anyone who is speaking so that they can better their performance next time.
So now we have the wrap-up session. Flor and I have just a couple things to walk you through and share with you. For those of you who are still here, thank you for staying till the end. And we don't have a lot. I think we probably have about 10 minutes of things to share with you. The first is what's next after live stream 2. So just a reminder that there's 4 live streams. They're all unique. And so live streams 3 and 4 have yet to happen. You can go to ak.ms/Posette and just be sure to reload that page so that you're not watching a replay from some previous live stream when we push out the new version of the website. We already mentioned the Discord that you can join to go to the PosetteConf channel. We already mentioned in the bottom left the survey links. And you can also watch the replays of this live stream and or of the live stream one that happened in Pacific time yesterday, I think. I think yesterday. It's all a blur to me right now.
What even are time zones, honestly?
Yeah, what are time zones? I love that link that Heikki shared in the beginning of today's live stream about like universal greeting time or something like that. Anyway, the links are showing in the bottom right, ak.ms, Posette -ls, and the live stream number, and then YouTube. That's how you can go watch the replays if you don't want to wait for the talks to be published. And the talks will be published. Let me see if I can find them here on the schedule page, as well as there'll be a YouTube playlist that gets created. If you go to that YouTube playlist right now, you're going to find last year's talks, right?
Which are also worth it to watch, but
which are also worth it. But at the end of live stream 4, this should all go live, and you'll be able to watch these things as individual talks. Usually the way the algorithms work on YouTube, the first 24 hours is really important. So if you loved any of those talks, be sure to, and you want to see them or are desperate to see them, just be sure to go watch in the first 24 hours and give it a thumbs up and show some love to that contributor. So let's see what's coming up in live stream 3. This is really hard to see. It's a bit of an eye chart, but trust us, there's 10 amazing talks coming in live stream 3, and then another 10 in live stream 4. You saw some of the trailers today. And the other thing that's coming is next week, we're doing a live recording of the Path to CitusCon podcast, and it's titled The Making of Posette. So Teresa
that's so great.
and Aaron Wislang, both on the organizing team, are going to come chat with us and tell us how this event was made. So there's
sort of like a backstage, how it all came to be.
Exactly. Like,
will it already have the new title for the podcast then?
No, it will not have the new title for the podcast yet. So we are renaming the Path to CitusCon podcast to Talking Postgres, since it really is all about Postgres. But that won't happen until July, I don't think. So this is going to continue to have the existing name. It happens on Discord. That's where we do the live recording. And then if that time of day doesn't work for you, we do publish these on all the podcast platforms about 48 hours later. So it will be getting published. But
I love that you're doing a retrospective in the open. I think that's really, really cool.
Yeah, I hope they share all the things, not just the good things, but also the bad things. Like, I think it's going to be an honest conversation. People always at the end of a Postgres event like to share like the dates and info about upcoming future Postgres community events. So that's what we're doing here. Swiss PG Day is happening in just a couple of weeks. It's in a beautiful location in Switzerland. I think tickets are still available. I don't think it's sold out yet, but just go find it online, check it out. I gave a talk there a number of years ago. Just fabulous organizers, really a lot of fun. And then have you ever been to PG Day UK, Flor?
I haven't yet, but I will be there this year. I already committed. I don't know if the program is out yet, but registration is live since today. So definitely check that out. If Chris is still in Discord, maybe he can share that link again. And otherwise we will for sure.
Okay. And then what's PG Day Lowlands? Talk to us. You're an organizer.
I'm so glad you asked. So only 2 days after PG Day UK, we'll have a PG Day in Amsterdam, and the CFP is launching soon. I will make sure to notify everyone when the time is right. We're very excited about this one, and we wanted to specifically place it in close proximity, both time-wise, but also geo-wise, I guess, to PG Day UK in London.
Awesome. So CFP opening soon for that. And then PG Ibiza is the same week in Spain. And that CFP is open right now as well and closes June 23rd.
Yeah. So if you're more a lover of the sun, I guess go to that one.
And there's even more Postgres events happening later in the year. PGConf New York City, which I think is in its 4th year now, is happening in late September, early October. So I know that my company is a sponsor there and at PGConf EU. And the CFP is closed now for New York City, but it is still open for PGConf EU if you have talk proposals you want to submit. And because I'm half Greek, I'm super excited that PGConf.eu, which changes locations in Europe every year, is happening in Athens, Greece this year. So you're going to go.
That is
right?
I'm definitely going to go. Very excited about that one. I've never been to Greece, and what better excuse to have your first visit to be for a Postgres conference.
Absolutely. And it's a great community. It can be very welcoming. So I hope more people sign up and they exceed previous year's registrations this year. Okay. So if you're looking for more great content, you can, Flora mentioned earlier that looking at past CitusCon talks can be a great way to learn. A friend of mine, actually, one of the ways she spins up on all things Postgres is she downloads these conference talks onto her phone. And when she's out running, she's listening to the YouTube conference talks. And so CitusCon playlists are out there for 2022 and 2023.
That is a life hack that I'm going to steal. Borrow.
Kind of like a podcast, but different. You're just hearing the voice and not seeing the visual. And then we wanted to end this wrap up with some gratitude. Every great event, really, I mean, obviously you need organizers, but you can't have an event without speakers. And I really appreciate all of these people, their expertise, their willingness to share their expertise. You're on this slide, Flor.
Did you find me?
Yeah, I found you. Second row, second slot.
I can't keep, I just keep staring at the little dachshund that is on this slide.
Oh, next to Paulina. Yeah, on the far right. Yeah, I didn't realize it was a dog at first. I'm like, what is that? Is that a mask? And then I realized, oh no, it's an adorable dog.
As a fellow dachshund owner, I immediately saw it. Yeah.
So the link in the lower right-hand corner of the slide that I'm showing, aka.ms Posette speakers, not only gives you just kind of a visual view of all the speakers, but you should be able to click from there to get to their speakers pages. Can you? Actually, I don't know that now that I say it out loud.
Just say that is exactly what happens. Yes.
Well, or I know you can get to the speaker pages from the schedules. Like when you open up the accordion, you look at an abstract, you click on that speaker, you go there. My point is, I'm getting to a point, is that over half of the speakers submitted speaker interviews. And so when you go to their speaker pages, you can find out more about their background. And if they've done a podcast interview, that's linked to as well. If they were a past CitusCon speaker, also linked to. So more information if you want to learn more.
And some of those interview questions were hilarious. So, and answers as well, of course. So it's definitely.
So wait, not just the answers were funny, but the questions.
Some of
were
the
funny?
questions, I was just like, that's interesting. Nobody has ever asked me that before.
I'll have to go check it out. Okay. And then I thought we should finish with a thank you to the organizing team. Couldn't have happened, wouldn't have happened without all of your hard work. Some conferences, people hire agencies and there's large masses of people who work on organizing it. But for a lot of Postgres community events, and certainly for this one, it's a core set of people who love the community and really want to do something special and help more people learn about this beloved database. So thank you to Teresa and Aaron and Adi and Aaron, among others. And then I want to thank the audience, right?
Yeah, thanks for taking out the time of your day to join us. Maybe you've done some work on this side while also having this run. Excellent. So great that we had you here.
And Flor, I can't wait to see you again. I don't know when that will be. Hopefully in Athens, right?
Latest in Athens.
Okay, if not before. Awesome. All right. Thanks, everyone. That's a wrap for Livestream 2. And in just a few hours, Livestream 3 is going to start.